Hello, everyone. Hope you're having a good day slash evening slash morning, depending on where you are. Uh, Let me know if my sound is right. I do see, okay, I think Tristan turned my mic on. I completely forgot to check that, but I think I have the right microphone. Let me know otherwise. Uh, uh, Euro game day. Oh, do you know what you're going to play? I'm a big board game fan. That was my in fact, in a way, Sudoku is sort of my way of detoxing from being addicted to board games and then never being able to play them during COVID. It was sort of an outlet for my playing games and making games sort of headspace. Uh, but I really want to play Arc Nova. That is a new board game that I am very excited to play. That I will get as soon as I can get my hands on it. I really like games with cards where the cards have things and synergies and play stuff and trigger stuff, all that good stuff. Uh, yeah, Acquire and Wingspan are quite far apart. Although, is Wingspan new enough to be Cult of the New anymore? Uh, well, I didn't want to detox from playing board games all the time, but there was this whole COVID thing that happened that meant that I didn't have people in my house for 2 years, and that sort of forced me to detox from board games in a way that was not sort of enjoyable. And now, as a result of that, there's now like basically no board games coming out because no one's making board games anymore because no one was playing board games for a while. But I'm excited to see when we get back to uh, gaming being a thing again, what all people come up with. It will be interesting to see. Uh, and as always, I'll be hoping that they come out with another expansion for Spirit Island. Anyway, welcome everyone. I've got some fun puzzles lined up for today, I hope. I'll warn you in advance that I did basically not sleep last night, which is very unusual for me, but so I am going to be a little more loopy than normal, so I may need more help. We will see how it goes. But we're going to start here with this Shikaku-sudoku from Emphyrio. I should mention, by the way, thank you to all of our patrons and supporters and subscribers. We appreciate all of you. It would mean a lot if you could like the stream. Just go click the little thumb icon if you could subscribe. And if you are interested in becoming a patron, patreon.com/zetamath is there for you. All right, but with all that out of the way, I think we are in a good position to have a look at Forked. All right, so Shikaku is a kind of pencil puzzle where you have to divide the grid into rectangles of various sizes. It's a cool kind of pencil puzzle that I've done some of. But for this puzzle, we're going to be doing that on top of a Sudoku. So here's the way it works. We have to divide the grid entirely into rectangles. So, for example, that is a rectangle. But I'm very much not allowed to put a rectangle like this because, in fact, every cell in the grid is part of a rectangle. Sorry, I said that part. But every rectangle contains exactly one circle. So I could not do that because that would create a rectangle with 4 circles. But I could do something like that, and that would be fine, at least until you read the next rule, which is that the circle, remember there's exactly one, inside of a rectangle contains the size of that rectangle. So this is also not valid because this would involve putting 12 digits inside, or putting the digit 12 inside this circle, which is not allowed. Okay. But in case you're used to building lots of other things, then I should also note this rule is here. This rule is a none rule, which says that digits can repeat within a rectangle. So even if I do that, oops, not that, that's very much not a rectangle. This would be perfectly valid, even though there's 2 7s in it. That's okay. Yes. Squares are rectangles. It notes that as a rule as well. Although students don't always like to believe that squares are rectangles, but every square is a rectangle. But there are rectangles that are not squares. And so I think the easiest first digit we've had in a puzzle is this one. This circle has to belong to a rectangle. This is the only rectangle it can possibly belong to. And therefore, this digit is a 1. And we're already dancing. Today is off to a good start. Excellent, excellent. Okay. Woohoo! All right. So I'm going to try and note super congested circles. So this circle could be part of 3 different rectangles, but it's only from 1 or a 2. And the same is true of this one down here. And so it's either a 1 by 1 square or it's a 2 by 1. Liam, you missed very little. You missed me explaining the rules and putting a 1 in this cell. And I'm going to color my rectangles for no reason, other than that it will make it look cool, I suspect. This one actually can be up to... this one can't be 3, but it can be 1, 2, or 4. Because I could do this 2 by 2 like that. Okay. Now, I want to note that that's pretty big for this cell in particular, because I have a 1, 2 pair in this column. So this is now at least 3. And so in particular, because this digit is at least 3, I can't possibly let this region take this cell. So those are in a different place. So this rectangle is 1 wide. It's at least 3 tall, which means it has to take at least these 2 cells. So those are going to be in part of the same rectangle. That's, of course, not going to be in the rectangle. But this could go up to... this could be as high as 5, depending on if it takes all of these cells that it can possibly take or not. Wow, YouTube's already falling behind 7 minutes into the stream. YouTube, you are an amazing beast. So that's already nice. Now, this one I know also can't be 1 because there's a 1 here. So this is at least 2. Unfortunately, it being at least 2 does not tell me a whole lot because it could be 2 going in either of these directions or it could extend much further. And this is not really super limited in terms of how big it can be. Let's see. Russ is looking at row 7, column 3. Ah, yes. Good point, Russ. This cell also can't be... well, it can't be a 1, but it also can't be bigger than 3. So this cell is a 2 or a 3. And row 8, column 2, Russ also points out, this also can't get bigger than 3. So this is a 1, 2, or a 3. And that's now big because now we have a 1, 2, 3 triple living in box 7. So great spot, Russ, because now we can knock 3 out of this. And so now the purple rectangle must continue. I hear secret tell, by the way, that we're going to soon be able to choose the color of our ugly green border for the pen tool, which is very exciting to me. Okay. So let's look at other ones that might be restricted. Maybe I don't immediately see others that are super restricted. Yeah, the fact that whenever you use the pen tool, you almost certainly want to also color, and this green does not go super well with the colors is it's nice. Yeah, okay. So it is worth noting, and J40 sees this. This has to be at least 4. So it can't possibly take this cell anymore, because if it took that cell, it would be finished. In fact, this cell is completely symmetric to this one. It has to be at least 4, but it can be at most 5. So this is a 4 or a 5. Oops. This is a 4 or a 5. And it, of necessity, because it has to get to at least 4, has to take all of these cells. So we can go across that. Bloop, bloop. We can go ahead and fill in that these digits are 6, 7, 8, 9. Just so that we have that on record for when we look at those later. Let's see. Okay, row 3, column 1. Yeah, row 3, column 1 is it possible that this cell is strictly vertical and takes those 3? I mean, I know this isn't a 1 or a 2. It's at least a 3. I don't know which exactly. Okay, let's see. Russ is pointing out this cell is restrained. If I counted row 6, column 4 correctly.
Hey, can we get a shout out to our mod, Derek?
Oh, thank you, Derek. Thank you so much for helping keep the peace in the stream today. Hopefully, it will not be too bad. Tristan said we needed to pick a mod earlier, and he was not very pleased with my suggestion that one of those nice people that comes in and posts links in the chat would be a good choice. So thank you, Derek, for being far superior to the people who come in and post links in the chat. Let's see. All right. Carl. So Carl is claiming if this were a vertical 3, which there's lots of things this could be, but if this is a vertical 3... Oh, wow, I never turned on my lights. Whoops. Then that would make both of these a 1. I'm not sure I believe that, because I think this could go across, or this could grow up, or whatever. All right, I will treat that as retracted. Let's see. This digit has to be at least 2. So I do know that this rectangle is vertical and is at least 2. So it could dip down and dip up or whatever, but it has to grow. And so it has to either take the cell below it or the cell above it. But I don't think I know which one yet. Okay, where else are we going to find it? This cell is quite restricted because it can't grow up, and it can grab at most, yeah, this is good. Okay, this can grab at most 3 total cells. So this is a 1, 2, or 3, just by looking at how many cells it could possibly grab. I think maybe someone pointed this one out, and I did not process it at the time. Okay, this one could grow up. If it doesn't grow up, then it can only grow out. So this one's at most 5. It could also do that. But I think this is at most 5. This cell's now getting clustered in as well. If it grows up, it's done at 2. Otherwise, it could grow up to 4. So this is a 1, 2, 3, or 4. Yeah, this could be gigantic, but only if it reaches like all of those cells. It could be as high as 8. And if we wanted to cheat and use uniqueness, we would start thinking about, okay, there has to be an 8 somewhere in a circle. Where does the 8 in a circle go? And then figure out the solution from there. But we will be good little solvers and not use uniqueness to immediately ask where the 8 in a circle is going. Let's see. Well, this all started out very nicely. We got a very early digit dance, and then it sort of made us very sad after that. Okay. Is there a way I can benefit from Sudoku? Well, I know there's a 2 in one of these cells. That doesn't seem to be super helpful. Let's see. Pencurry, welcome, by the way. Welcome, everyone, by the way. I have not really been welcoming people today. But this cell can be at most a 5. which is if it does that. Oh, you're right. Okay, I think afraid not is right. I think we could have a 6 at maximum, and then 8 would be the size that doesn't appear and is not in one of the givens. You're right. Yeah, we don't need to necessarily have an 8-cell rectangle. There could be a 6. Let's see. Okay. But I'd really love to rule out this being 2, but I think it probably actually is a 2. Let's see. Okay, I do know one of these two is a 7. I should probably note that given the given 7s. That one's definitely not 7 anymore. Let's see. Nikki is looking at row 3, column 1. So it can be as high as 8. But let's try and write out. So it can't be 1 or 2. Could easily be 3 or 4. I don't think it actually can't be 5. It can certainly be 6. Can't be 7, and it could be 8. So this is 3, 4, 6, or 8. Derek has seen the something. Okay, Derek has seen that this can't be 4. Rex can be that shape. Oh, yeah, yes, sadly they're not all 1 wide. If only. Okay, so Derek is saying this doesn't work. So this being a 4x4, because it forces row 9, column 1 and row 9, column 7 to both be 1. Column 1 and row 9, column 7. Okay, so let's chase that. So if this is a 4, it makes this a 5, which means that green looks like this, which does indeed make this a 1. But why can't this be a 2 and go vertically? If this is a 4, I do believe this has to be a 2, but it could go vertically. Okay, so let's do math. These 3 circles take up a grand total of 6 cells. Now, how many cells have I just highlighted? I've just highlighted 7 cells. And so one of these cells at least has to be taken by either green or purple. And they could both be if this spills out of the box, which it can. So it could be that both purple and green take these 2 cells. This is the one. But I feel like that sort of area counting should be very useful. In fact, I suppose I could count all of the rectangles that touch this box. Their total size is 9 plus 6. Okay, so in total, maybe this is the smarter way to do this. In total, the rectangles that touch box 7 contain 15 total. Contain 15 total cells worth of area, which means that these rectangles hang out of this box a total of 6. So currently we already have 4, so there are 2 more, which could be here and here, or here and here, or any combination thereof. But I know 2 of these 3 cells belong to something from this box. Okay, I don't think this can dip down. I think because of that, if this dips down, I think we run out of cells. Because let's look back at these 6. And what are all the cells that could possibly in any universe be part of these 6? This is all the cells that could ever be part of these 1, 2, 3 rectangles. And so that is a total of 8 cells. Oh, never mind. I don't think that clear. I wanted to say if this went down and like that, that was going to cause a problem. But I think actually it just could. Interestingly, if this is a 2, then it forces... Oh, no, never mind. Every cell has to be in a rectangle, yes. So we can do the opposite of what we have been doing. I don't know why my voice is already hoarse. I'm only 20 minutes into this. So we could do the reverse question, which is, I think, the implicit behind Derek's question of just picking a random cell, or hopefully a not too random cell, and asking what circle it goes with. Let's see. Is there any low-hanging fruit where it's really hard for it to be part of a circle? Like this is, I think, maybe the furthest away from anything, but unfortunately, I think it could be part of that circle. It could be part of that circle, or this circle. So yeah, I don't think those all have something in common. The fact that there's no circles in column 6 is actually very interesting, because it means every column 6 cell is joined in a rectangle with something either in column 7 or in column 5. So all of these go with something in either column 7 or column 5, which is interesting. Let's see. Row 1, column 9. So row 1, column 9 can go 2 places. It can go there or there. Let's see. If row 1, column 9 goes here, then this would be a 1, 2, or a 4. Which would go with that 1, 2, 4, and be interesting in that regard. Yeah, row 4 also has no circle. So we can also say for every cell in row 4, it joins either in its rectangle something in row 3 or something in row 5. Let's see. These 2 cells both have to join something. So row 4, column 6, is that special? Yeah, so this... Okay, so that's a good point, Nickel. Sorry, I saw that as Nicky when I first read it, and I'm trying to undo that in my head and think nickel instead. So this needs to take either a cell from row 3 or a cell from row 5, and either a cell from column 4 or a cell from column 5 or a cell from column 7. So this is going to be part of a rectangle that's going to have at least 4 cells in it. So it could do something like that. But it could also do something like that or something like that. I mean, it can't do that exactly because that would put a 9 in a place where there's already a given 9. But, you know. Okay. Why couldn't they join row 6, column 4? Oh, sorry. That question has been retracted. Okay. So let's look at this row and see if we can say any of these causalities are just broken. So if this is a 2, that's a 1, that's a 4. That's a 5. Okay, so... But that actually works out nicely, because if this is a 2 and a 1, that being a 5 is a very natural thing to have happen. So 2, 1, 4, 5. Oh, no, that doesn't work. Because I can't... there's no place for it to get the second cell. Okay, so just to say that slowly. If this is a 2, then that makes this a 1 and makes this a 5... Sorry, I should say this. This is a 2, so that's a 1, so that's a 4. Okay. So just to help you visualize that, this looks like this looks like this, except that's a problem because we just hypothecated putting a 2 here. But that's bad because now this doesn't have a second cell it can take. So we can eliminate 2 as a candidate from that cell. Now, if this is a 3, it's going to make this a 4. But I don't think that's a huge problem. It's going to make these a 1-2 pair, but either of them can grab the thing above it. That is as good as I can see. See, if this is a 1, that's a 2. And that's a 4 again. So then this will be a 5. But then I think that's okay. This just ends up grabbing that cell up there. Let's see. If this is a 4, it makes these a 1-2 pair. Here's a good observation. Let's go back to these 7 cells. One of these cells is definitely taken by purple or green, because one of purple and green is a 5, and whichever one it is that's a 5, it has to take either that cell or that cell. So just by that logic alone, we are at perfect equilibrium with there being 7 cells here, and we know one of them is taken by purple or green, and 6 of them are taken by these digits. And so then anything that pushes into this box from anywhere else then forces something from this box to push out. And this box can only push out 1. So we could, for example, push here down 1, and then this could push out by 1. And I think that's okay. Hey, Emphyrio! This is a very fun puzzle so far. I've had this in my list for a while, and I've gone back to, these past couple streams. I've gone back to the top of my list because when I first started doing this, I was like, yeah, I'll go grab. I'll just grab some lists of puzzles. And at first, I was going through the puzzles like about as fast as I was adding them to the list. But then people kept adding. People kept giving me permission to do their puzzles, and so then I'd go through their puzzles, and then my list grew longer and longer and longer, and then I just sort of naturally started at the bottom. And so there's a lot of stuff that's been in my to-do list for forever because I just added stuff from the bottom up. I've been trying to go back and grab stuff, and so this is one of the puzzles that's been sort of sitting at the top for a long time that I have not gotten to, as backwards as that seems. One of these two's a 1. Average rectangle size is 3.24. Good to know. let's see. If this is a 1, it forces this to be a 2. Okay. Maybe the thing I want to look at is this being 5 broken. If this is 5, well, if this is 5, it forces this to grow horizontally, which would mean this would have to be the 2. Okay, that's an interesting point. If this is a 5, the 2 in column 1 goes here, because I need something to take this cell. Does the same thing work down here? If this is the 5... no, I don't get quite the same... Oh, interesting. Okay, if this is the 5, that's a 1, and so this is a 2. Okay, so if this is the 5, that's the 2, and that's the 1. And if this is the 5, it's the opposite. Then it forces this to be 1, and so that's the 2. Okay, so the 5 and the 2 go together in either row 9 or column 1. So yeah, I think that is a very different way of getting at the same point that Derek is getting at, which is that this cell is either horizontal or it's just 1 by 1. This cell is under an awful lot of pressure. Okay, if this is a 3, it's going to make this whole thing a 4. Which is then going to make that a 5, which we have learned makes that the 2 and that the 1. Okay, let's see. So Derek is saying the case where this is a 2, 5. Oh yeah, the case where this is a 2, 5 is definitely broken. Didn't I just say the 2 and the 5 go together in the row or column? There just aren't 9 cells for 2 and 5. Sorry, I don't think that worked. Okay, let's try that again. So how did that work? So if this is a 5... if this is a 5, that's a 1, that's a 2. So this grows up. That's a 4, of course. Grows up. And then there's nothing to take this cell. No, this could take this cell, right? We're definitely pushing my ability to visualize this. But the contention of chat, I believe, is that this being a 5 is broken. Hey, Nathan, welcome! If this is a 5, it forces that to be a 1 and this to be a 2. So that's a 4. Well, this is never a 2 horizontal. I think just by numbers, this is never a 2 horizontal, because if this is a 2, this is a 5, and so it's always eating that up. So actually, I can mark that. I know there's a border here. Oh, knowing there's a border here. Okay, so sorry, this is a smart way to say this. Knowing there's a border here. Oh, does it tell me what cell this goes to? No, it does not. It does not tell me. Let's see. Can I do a similar thing up here? If this is a 5, that's a 2, that's a 1. if this is a 4... Wait. Do both cases end up with... Oh, boy. Okay. If this is a 5, then it ends up looking like that. So that's a 1, and that's a 2. And the 2 has to grow down. Otherwise, this is a 4, that's a 5, which makes that a 2, which makes that a 1. Okay, so I can do the same trick. If I just examine those two cases, there's always a border here. This cell can never grow right. Okay. Okay, so let's see. J is looking at row 8, column 2 being a 3. It does not have to grow down. It just cannot grow right. Because the only universe where this is a 2, Chris, this is a 5, which eats up all of those cells. And so as soon as purple is a 5, that means this row 3, column 1 circle has to grow right, which means it can't take this cell, which means the only thing that can take this cell... Oh, no, maybe this cell could take it. Maybe this is a 2 and grows that way. And okay, sorry, I think I'm wrong. I will retract that claim. Okay, but I want to look at, let's see, J is saying this being a 3 is problematic. So if this is a 3, it's either going to go vertically or horizontally. Let's just do it horizontally first to visualize it. What does that do? Well, it certainly makes this a 2. It certainly makes this a 4. This is a 5, so it's going to grab everything. This has become a 1, but it's supposed to be a 1. And then this cell had to take this cell. Okay, but it's this cell over here that's the problem. Okay. Okay. So this being 5 makes this 1. So anytime this becomes 5, this becomes 1 automatically, because again, 5 pushes out the ability of this to be as big as 3. Okay, Emphyrio reassures me I do not have to bifurcate this deep down, imagining what all of these digits do. I will be reassured by that. But I'm trying to understand what all the links are between these various things, because there's this link of like this is a 5 means this is a 1, and so on. So here's a note about these two collectively. These two collectively are horizontal, and so they eat up a number of digits out of row 9 equal to their sum. Can row 9, column 9 ever be a 1? If this is a 1, this is a 3, this is a 4, this is a 2 that grows up. Yeah, I think so. So I think this being a 1, I think just fills in 3, 4, 2, and the 2 goes up. Let's see. Oh, okay, that's a good point. Okay, so Jay followed by Derek followed by Chris notes that has the effect of guaranteeing that both purple and green are 4. Okay, so let's go over that again. So if this is a 1, this is a 3. So we're hypothecating a 1 here. I'll go ahead and corner mark that. So that makes that a 3, which makes this a 4. And so now we're over to here. So this is now forced to be a 2 and grow like that, but that makes this also a 4, and that does not work. Okay, and so ergo, this is never a 1. Yeah, that was a good spot. I did not see that that contradiction. Is the point here that we have a Y-wing on these 3 cells? Unfortunately, let's see. Does the Y-wing here... okay. I think this is the point. I think. These 3 cells, I'll gray them for a second, form a Y-wing, which forces one of these 2 cells to be a 3. So none of these cells can be a 3. Is that useful? Maybe that's not useful. It sounded good. I mean, it looks very fancy. Okay, so Chris is suggesting that we ask, okay, can this cell be a 2 and go horizontally? And Chris is pre-suggesting the answer is no. So if this is a 2 and it went horizontally, it would look like this. It would make this a 1. This would be a 3, and then we'd be broken. Right. Yeah, if this is a 2, that's a 1, and this is a 3. And so as soon as this is a 2, this is a 3, which means it eats all of those, which means these 2 are definitely part of the same rectangle. Good spot, Chris. Okay, is there another Y-wing here? I feel like chat should be better than me at finding Y-wings, but maybe not. Let's see. Normally, I wouldn't think I would be the one who would be going, yes, here's a Y-wing. So now row 7, column 9 is 1, 2, 3, 4, 5. Yes. Okay. So yeah. So now this is 1, 2, 4, or 5. Okay. So the most this cell can now eat is all of these, which is 5. But by the Y-wing argument, this can't possibly be a 3. What about this cell? I've never marked it, but maybe it's worth marking because I know it can't be a 3 anymore. So it could certainly be 1 or 2, at least in theory. It can't be 3 because of the Y-wing. And it could be up as high as 6. But that's actually interesting because it's saying I still have not put a 7, 8, 9 anywhere in this box. And this being a 6 is almost certainly broken, right? If this were a 6, that would make this a 2. It would make this a 1. Maybe not. Okay, so if this is a 6, it certainly makes that a 1, that a 2, that a 4. Yes, okay, yeah. If this is a 6, it's going to cause the same problem where both of these are going to end up being 4. So I'll walk you through that again. So if this is a 6, what happens is This is now definitionally a 2. So this is a 1. So, wait, no, sorry. No, I don't think so. Okay, so I don't think it's the same as... Sorry, it's not the same as the other one. It's probably still broken. If this is a 6, that's a 2, that's a 1. This is a 3, but it can't be a 3. Because there are not 3 cells for it to take. So yeah, this can't be a 6. Yep. Breaks this cell ultimately. I somehow thought it was going to break the same thing over here, but it does not. Okay, so now we have a quintuple, which is gorgeous. So now we have a quadruple in this row. So these are 1, 2, 3, 4, 5. Interesting. Okay, so is there any universe where this is a 5? There is no universe where this circle is a 5. It just can't get 5. It can't get 5 cells in any orientation that makes a rectangle. So in fact, the 5 is here in one of these 2 cells. So either this is a 5, in which case it looks like this, or this is a 5, in which case it's going to take a giant pile of those. And as Chris points out, that points over at purple. So now purple is 4, green is 5, and that's going to do a lot for us, because once green is 5, we know what the 5 cells are. They're those. Oops. And it sounds from Emphyrio's comments like we're on the intended path towards success and betterment. Okay, so now this is a 1 because it can't get to 3 anymore. We already danced for our digit. We got this digit. But you can re-dance. I will not judge if you dance again. I promise. Okay, so that can be black. Okay, so that's a 2. And we know which 2. It's those 2. You can be orange. Why not? And so this is a 4. And so it looks like that. And yes, this one definitely felt worthy of an excited dance. Okay. So Sudoku makes that a 3 and that a 2 question mark? A 1? This has made me realize I have error checking turned off. Let's turn that back on. Okay, so let's go ahead and fill this in. Okay, so this is a 1. It can also be yellow. Just aesthetically, I'm not liking these both being orange, so you're going to be blue instead, just to make the world a better place. Okay, these are not 1 or 4. These are now a 2-5 pair, so that's a 3. And I know which 3. It has to be this 3 because it can't go up. So these 3 are all 1. Let's make that yellow. What color you make each rectangle is clearly the most important choice out of all of this. So these are not 1 or 3. Why is my phone ringing? Let's see. Okay, so there we go. So that's the 3. Now this 3 can only get 3 if it takes these. So this 3 is those 3 cells. Okay. Now this certainly can't be 4. So these 2 need to go together and be friends. Oh, I mean, we've just got so much going on. It's going to be a while before we clean up everything that we have that we know. Okay. Let's look over here. That 2, for example, we haven't yet even handled that 2 makes that a 1. Which which can go like that. Okay, this is not a 4 anymore. So this is either a 3, 6, or 8. Purple needs to go up 1. Thank you. I don't know why I had not counted that. Okay, so this now needs to take at least these cells, because it needs to get to at least 3. It can only do that in this direction. So those go together, but I don't know how far it goes. So these two now go together because this cell can only get taken by this, because I know this can't go up. So these two go together. They are friendly. Let's see. I know there's a border here. I know this is at least 2. Actually, I know this is 2 or 3. Suddenly we're doing pen tool all over the place. This is at least 2 and at most 3. This cell now, by the way, also has to go with that circle. So that circle, I'm going to go ahead and pencil mark over there like that. So that goes like that. Okay, we're saying this has to be a 3. Let's see. Yeah. How did this ever get marked as being able to be a 6 or an 8? I don't know. Don't ask me. It's a 3, that's a 2. I don't know anything, I just work here. Okay. This now has to be bigger than... Sorry, this circle now... Well, it has to be bigger than 2, so it has to keep growing. So we're going to get a border there and a border there. Okay. And now notice, actually... Oh, never mind. I was going to say something that was just not complete. That was not true. So this is a 3 or a 4. I know that much. Now, this can't be a 3. So this is a 4 or a 6 or a 7 or an 8. But it certainly needs to take that cell because it can't be done in order to make this work. This is not a 2 anymore. And in fact, actually, this circle... Oh, it's not a... Oh, sorry. It can be a 3. I'm looking at the wrong box. 1 second. I swore I was going to sneeze. I probably will in a second. I was going to try and protect you. This has to be at least 3, and it's also at most 3. So, in fact, this is a 3. We can go ahead and give it a color. Give it a border. Call everything good. So now we can bounce back over. Hey, Ambrose. We can bounce back over and contemplate which of these is a 5. In particular, this one can't be 5 because it can't go 5 that way and it can't go 5 that way. So this is a 2. That's a 5. I know chat was excited for me to do that one. So that goes like that. Woo. Go ahead and fill in all of those like that. Let's see. Row 4, column 3. Let's see. Could be 2. Can't be 3. Could be 4. Can't be 5. Could be... Oh, sorry. No, row 4, column 3. This cell. Sorry. I think what is being stated is actually this cell. Sorry. Chris said row 4, column 3, and then I proceeded to look at row 3, column 4. But this cell, I believe, can only go... Oh, maybe it can go either of those places. Oh, no, sorry. It's this cell. Sorry. This cell. I looked at the right place and then did the wrong thing. This cell can only go with its friend here. Those two are shacking up together for now. So this is at least a 2, but again, it could grow. It's definitely even now, which is interesting. So this is 2, 4, 6, or 8. Someday I will get the cells right on the first try, but today will not be that day. Row 2, column 9 is a 2. Yeah, okay. What are the possibilities for this cell? So it could be a 1. It can't be a 2. And then the biggest it could possibly get is 4, but it can't actually. So it just is a 1. So it can't be a 2 and it can't be a 4 just by Sudoku. So this is a 1. Sorry. Let's see. You get your own little box to hang out in. You can be blue, I suppose. And now this cell can only go with purple. So purple gets to extend all the way out there, and purple gets to grab an 8. See, I told you there would be an 8. Let's see. What are the possibilities for this cell? So this cell can't be 3 because it would make this 3 as well. So that's not going to work. Oh, sorry. It could be... Oh, this cell can't be 3 because there's a 3 in its column. How about we do that? So this cell needs to be at least 4. So this is a 4. It can't possibly be 5. It could be 6 or 8 in terms of its candidates. Let's see. Ambrose notes that row 6, column 4 has to be at least 4. Let's see. It is not... it sees... Oh, great spot. Okay, so this is... this cell sees 1, 2, and 3. So therefore, it's at least 4. Well, it can't get 4 total cells without going up. So those two are friends. Orange is not a great color there. Let's see. Go with purple. Okay, and now that's actually... That didn't look big at the time, but it's actually huge because it tells us that gray here is actually really a 2. Because there's nothing over there. Yeah, I was suspecting the given 9 is there to tell me that this is not a 3x3. Okay, so yeah, so this is 4. Okay, yeah, and so it can go up. Yeah, so it could be 4, but if it wants to go up any more, then it could be 6. So actually 4 and 6 are the only options for this cell. I don't think it can get as high as 8. Let's see. Yeah, I guess I could have a 3x3 over here. It's possible. I mean, I got to do something with all these cells. Let's see. Hey, Matthew, welcome. Okay, what are these cells? I'm just going to start doing Sudoku. 1, 2, 3, 4, 5, 6, 7, 9. That one's not a 7. That was disappointing. Let's see. So was the Y-wing necessary? I think we used the Y-wing to get the 5 locked up here, but maybe not. Sorry, I'm reflecting back on the way the break-in worked and how we got this very careful quintuple between these cells. And I'm not sure. I don't think it was necessary. Okay, so these cells are from 4, 5, 6, 7, 9. That's not a 4. I am being told it was not necessary. Well, I found it anyway. Let's see. Oh, interesting. This can't be a 4, because if this is a 4, it forces this to be a 6 or an 8, and it can't be. So this has to be a 3. Uh, now the only rectangle that can possibly take this cell is that one. Let's see. I know this rectangle can't take this cell because then it would not be big enough. And so, in fact, that tells me I know these two are also in the rectangle. So now this cell can only go with its friend here. And I know that it's bigger than 2, so it has to also take that cell at least. And it's bigger than 3 even, so it has to actually take this cell at least. Can we go for one more? Do we know it's at least 4, or do we know it's not 4? I don't think we know it's not 4. Chad has devolved into guessing where the 3x3 is going to go. I don't think there's going to be a 3x3. That is my official prediction. I think this given 9 is there specifically to tell us that this 3x3 is not correct. Okay, so I know that this is 4 or 5. I might as well fill that in. Seems wise. Okay, this cell... Actually, I don't even know this cell's not a 1. Well, that's disappointing. This cell can go anywhere. Well, not anywhere, but it can go in one of these two places. This cell can go one of those two places. Oh, sorry, it could even go here. Never mind. Okay. Actually, I think this cell's going to have to be a 1. Because if this cell's not a 1, it's going to be bigger than 2, 3, 4, 5. It's going to be at least a 6. It's not going to be a 7. Could be an 8. And it can't be a 9 because there's no 9-cell rectangle I could do. So if this is not a 1, it's huge. That's not, strictly speaking, a problem, actually. Let's see. Row 3, column 5 is at most 3, says Chris. Sorry, is at most 4. And I agree, because it could grow 4 down, or it could take this 2x2, but that's it. So this is a 1, 2, or 3, or 4, but it's not a 3. So this is a 1, 2, or 4. This is a really smooth puzzle. That 7 sees that that's not a 7. I would like to know which of the cells this takes. I probably have to count and figure out that I know the sum of the remaining circles, but I don't want to. Okay, Listesh says this can't be 8. So the only way this could possibly be 8 is if it looked like that. And then that forces row 2, column 7, and row 6, column 7 to both be 4. Row 2, column 7, and row 6, column 6. So that would be 4. Yeah, what are the candidates on this cell? This cell can't be 1, could be 2, can't be 3, could be 4, Yeah, and then or 6 or 8, I believe. Yeah, I don't see why this couldn't be 2 in that hypothetical. Yeah, so this cell is either going with that circle or that circle. Can I do anything with that? Okay, so people want me to chase this chain a bit. One thing I'm learning from doing this is that most solvers are way, way more willing to chase chains than I am. I think it's because people are better at visualizing these things than I am. But a lot of people, especially a lot of the really great setters that I respect, I'm noticing see things like way more steps ahead than I would ever think. Okay, so let's do this again. So saying this can't be 8, because if this were 8, it would look like that, which would then force this to be a 4 so that this 2 could finish. But then some other... Oh, but then this would also be a 4? Yeah, okay. These would both be 4, and that doesn't work. Okay, I agree. It's not an 8. Well... I did prove it couldn't be 8, even if you didn't want me to. Let's see. I'm kind of suspicious about this being 6 also breaking. Yeah, if this is a 6, then these two cells have now become broken. So this can't be 6 either, because now these two cells are homeless, because this can't be a 6 either. Verg sees that as well. By the way, welcome, Verg. So yeah, so this can only be a 2 or a 4. There's another way to make that a 6. Oh, is the other way to make it a 6 that? Doesn't that do exactly the same thing of stranding these two? I think this being a 6, I think either has to go like this. Oh, maybe it goes like that. Sorry, that. This. I think this way of being a 6 also. Yeah. Okay. Yeah, you're definitely right. I did not look at. I did not look at all of the different ways of making this a 6. This way of making a 6, I think, breaks box 5 because now this is a 4. Oh no, this could be a 4 and that could be a 4. That's fine. Before that would be a 4. That would be a 5. This 2 would take that cell. I think this cell. I think if you follow long enough, I think that's more chaining than I really want to rely on. But I think if you follow long enough, this cell ends up isolated. Chat seems to agree with me. Okay, I'll take it. Chat agrees. If things go awry from here, I can blame chat. I probably should pause and do some Sudoku. Maybe find some more Y-wings or something. Uh-oh. The setter is saying that in the solution this is an 8. Let's go through this again. So why was our proof that this can't be an 8 wrong? So we said, okay, what if this is an 8? If this is an 8, this is the only thing it can look like. I think we agree with that. Tell me if there's a thing I'm missing. Uh, but this has the effect of making both of these digits, which are in the same box, they both become 4s. So if this is supposed to be an 8, something else is wrong. Which is very possible. Oh yeah, that's how I removed it. Okay. I felt very good about that one. But then again, I felt pretty good about removing the 6, and then it was pointed out that that was way harder than I thought. Yeah, I'm always happy to double check, because if someone's not sure how something happened, that probably means that it's wrong. Or that it's very likely to be wrong. So yeah, I'm always happy when someone asks, hey, how did you get that, to go over it, because it's probably good to double check if someone's confused about how something happened. Okay. Okay. Do any of the forms of this break things? So if this is a 4, it makes that a 5, which forces the 2 to come out here. I think this is going to have to be an 8. I don't really want to do the counting, but I think if I do the counting, I'm going to get that the cell can't be a 1. So let's say I max every circle that's remaining. So let's say I make that a 4, 10, 15, 23, 27, 29, and try and make this a 1. That would be 30. Would that get me to 30 cells? Okay, how many cells is this? That is 1, 2, 3, 4, 5, 6, 7, 8, 13, 18, 23, 27. Darn it. I can't rule out this being a 1 just from that. Hey, Peter, welcome. Row 2, column 7 is a 4. What takes row 4, column 7? Maybe even just generally. Yeah, okay, yeah. If this is a 4, well, let's put it this way. Which circle is taking this cell? There's only 2 possibilities, the one above it and the one below it. However, if the one above it is a 4, then neither is able to take this cell suddenly. So this is not a 4, it's a 6 or an 8, which lets us yellow some more. Okay, that yellowing is quite interesting. This can't be a 1, I don't think. Because if this is a 1, I now have to deal with both of these cells, and there's no way I can deal with both. So that's not a 1. So that's a 1. Yep. We're doing a Shika hybrid. Row 7, column 5 is not 8. Yes. Now, yes. As Listesh points out, now there is no universe where this is 8. It is now exactly these cells, in which case it's a 6, or it's just a lonely 1. I still don't like this being a 1. This being a 1 feels ucky to me, but I can't quite, I think, prove it yet that it can't be. Let's see. But yeah, either this rectangle takes all of those. Oh boy, we can look at the parity of the remaining circles. That is both a beautiful idea, and oh boy, do I not want to do the math of it. let's see. Okay, so afraid not notes. We actually know that almost all of our remaining circles are even in size. And so if we count very carefully, we can find out whether these two have the same parity or opposite parities. I'm going to take a real short bathroom break. I'll be right back. And I am back. Let's see. Okay, so chat has not, it sounds like, come to a consensus about how many cells there are left and what the math is. And I'm still going to refuse to do it. Yeah, if it wasn't for the fact that there were two of them, then it would be a surefire win, because then you would just count and you would know immediately. But the fact that all I'm going to get is whether these two are the same or different is not immediately useful. Let's see. Chris says there's 27 cells left, so if we believe Chris, and I have no reason not to, then these are opposite in parity. You know what? That's a good point. Maybe I should have left it up so that people could do the counting. Okay. I do know that 1 goes in one of these two cells. The Sudoku part of this is going to have to do quite a lot of work. Because we're like nowhere near having the grid full. But it strikes me that maybe we're going to need to do some Sudoku to sort out what these digits are. Possibly. Let's see. Okay. Let's sum the minimum. Sorry. Let's sum the maximums of the none 2 digits again. Or sorry, of the ones that aren't this. So that would be 10, 18, 23. Yep, I get there. 27, 29. Okay. Sudoku means the top yellow isn't 8. Ah, yes, beautiful, beautiful. Okay, excellent spot. Sarvesh has the clutch thing. Where does 8 go in box 2? It definitely has to go in one of those two cells. So this is not an 8. So that's a 6. Okay. So that region ends there. Excellent spot. I think multiple people saw that. both Matthew and Sarvesh, I believe. So great. So now the 8 is down in one of these two cells, for the record. All right, so now we've got to look for lonely cells. Like, this cell now can only possibly get taken by this cell, I believe. So these are going to be friends now. Yeah, both Sarvesh and Matthew nailed that one. Oh, and I know, okay, now I know this can never grow vertically. I've probably known that for a while. So this is never taking this cell, and it's never taking that cell. So now this cell actually can only get taken by this. So, yes, okay, there we go. So now this is my own little rectangle. Sorry, I'm not going to use the orange next to the red. I know the coloring is really just for my amusement, but I'll try and make it better anyway. Okay, so now that needs to be taken by this. So now this needs to get taken by the green. And so now the green is a 5. Okay. Now this cell needs to get taken by this cell, and the only way that works is if this is a 6. So now these are all going to hang out together. Green, I suppose, again. So now this is a 4. That's a 2. This being a 4 comes up here. And so now this is a 2. And these two come down here. And now we have done the Shikshaku part of the puzzle. I believe. Unless I made a mistake in going over that too quickly. But I think that's right. But let me know if I did something horribly wrong. Let's see. I'm going to try and clean up that. Those aren't 6 anymore. Green line missing in column 8. That was very bad. But we fixed it. We got it. This is a really good hybrid. Yeah, we almost had a disaster there. We almost had to do this puzzle again next stream to fix it. Let's see. 7, 7. Still put 7 in one of the one of those. 1 is now placed. 1 is here in this box. 1 is now placed here in this box. 1's now placed here in this box. 1's, and we've got all the 1's. That's 9 1's, right? Yep. The 6 and 2 regions are also not separated. Yes, thank you. Bloop, bloop, bloop. Okay, so we've got all the 1s, so we just have to do the rest of the digits. And I will promise you I will be confused by the rectangles and where the box boundaries are and misplace something at least once. But let's try and nail down the 2s. We've now got all the 2s. What about the 3s? Let's see. That's a 3. One of these 2's a 3. Let's see. One of these 2's a 3. So this is a 3. I suppose I should have probably started with that one. Yep, so we've got 3's down to an X-wing. Yeah, we've got all the 2's, right? Did I miscount? Oh, I miscounted. We have all the 2's but 1 2. I did not place the 2 here, did I? There's a 2 there. That will do it. So that means that's a 3, so that's a 3. And so because we didn't actually have all the 2's, we now have all the 2's and all the 3's, I think. Let's see. Okay, 4's. We do not have all the 4's yet. And I don't see a whole lot immediately appealing with 4s. What about 5s? The 5 is in one of these two places in this box. Let's see, there's a 4-5 pair. Well, I can at least say that this digit's not a 5 while I'm talking about things that are or are not 5s. So, yeah, one of those two is a 5. Let's see, 6. 6s, we know not a lot about 6s either, unfortunately. We do know one of these two is a 6. So we know one of these two is a 6. Oh, and it's not that one. Okay, so we can actually place another 6, owing to that. So yeah, so 6 is now pushed over to here by Sudoku. Let's see, and I don't see more to do with 6s right away. Let's hop over to 7s. As expected, we're getting less and less good stuff as we continue to go up. Now there is only one 8 in the grid currently. And there's only one 9 in the grid currently. Now, I can actually do something with that 9, though, which is to observe that the 9 goes in the same places in this box as the 7s. So I can upgrade this from a corner marked 7 to a 7-9 pair. So that's going to be at least significant. So now the rest of this column is a 5, 6, 8. Now, this isn't a 6 or an 8, so it's a 5. So these aren't 5. They're a 6 and an 8, which means I now know what this digit is, at least in theory. I think it's a 5, actually, which gives us a 4 and a 5 down here. I know what this digit is. 4, 5, 6, 7. It's an 8, which places that 8 up there, at the very least. So now what are the... Oh, sorry. What's this digit left in this column? I think it's a 4. So what's the digit left in the box? It's a 9. So let's see. So that was not a 4. That did not quite help. Okay. This is not a 9 anymore. It's not a 5 anymore. So that's a 4, 7. That's a 4, 7. Oh, happy birthday, Pause. I'm sorry you are exhausted. Hopefully it's a good sort of exhausted and not a bad sort of exhausted. Like you had such a great birthday that you can barely keep your eyes open. I hope you enjoyed the various birthday puzzles that people made for you. I tested a couple of them. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Left in this row. I don't think that was helpful. Let's see. What is left in this row? 5, 7, and 9? Yeah, 5 in row 2 now can only go here. This is a 7 or a 9. I don't know which yet. Okay. 5 in box 1. Oh, yep. We got the 5 in box 1. Okay, let's clean up some of our pencil marks, like the fact that those aren't 8s anymore. Do I have more pencil mark cleaning that can be done? Let's see. Let's fill in this column. 3, 4, 5, 6, 7, 8, 9. Okay, this is not a 5 or a 7. This is not a 7. Well, that was not as helpful as I had hoped. 4 in column 8. Ah, yes, I have to place a 4 in column 8 somewhere. And it's got to go there. Good spot. So now that 4 is assuredly going to make our lives better in manifold ways. Because now I know there's a 4 here. Just continuing to chase the Sudoku dragon. That's a 7. That's a 4. That's not a 4 anymore. Nor is that a 4. Let's see. Yeah, we got the 4 in column 1 now. Okay, let's see. Oh, yeah, where's the 4 in box 1? That's a 4. That's a 9. That's a 6. That being a 9 makes that a 7. These aren't 7. This is an 8 or a 9 as well, in order to finish the row. I don't think it counts as a chaos construction because the things aren't regions. But I guess it depends on how loose. It's a very nice Omino puzzle, to borrow a Piotr V term. Although only rectangular Ominos are allowed. Yeah, I've been wanting to make another like Omino-related puzzle. I have not made one in far too long. These aren't 9s. Excuse me. I think the reason I wouldn't call it chaos construction isn't because it's not build your own regions. It's because things can repeat within the rectangles. And then I proceed to highlight a rectangle that's entirely contained in a row. But the fact that digits can repeat within rectangles is the reason why it feels like a significantly different beast to me, which is not a complaint at all about the puzzle. This is a very pure hybrid of the two. Let's see. Is there an X-wing? Sorry, not an X-wing. Is there a Y-wing? That's what I was looking for. I don't think so. I'm sure you can make an Alumino puzzle. Okay, let's see. What is left in column 1? 6, 7, 8, 9. Lovely. That's not a 7. This concludes the list of things I know about this. But now I have a tuple of 6, 7, 8, 9. So I know this is a 5 now. And so ergo I know that's a 5. This is not a 5. Oops. Still not a 5. Let's see. Column 2, the 6 and 7 look down. Ah, yes, excellent point. So that is a 9. Yeah, a few people, Ambrose and Carl, pointing out the 6 and 7 here. Okay, so the 7, 9, so that's an 8. Okay, so that being a 9 doesn't tell me anything, but this is not an 8 or a 9. So that's a 6, 7 pair that looks across. So those aren't 6. That one's not 7. So that's an 8, 9 pair. So that's a 6, and that's a 7, and that's a 9, and that's a 7. As we slowly fill this in. I'm really impressed that this resolves, by the way, from everywhere. Yeah, I think from a point of view of constructing this, I would not want to try to construct it so that digits did not repeat within rectangles. Because if you want to make that kind of thing happen, then you have to do you usually have to sort of do a weird pre-construct the puzzle sort of phase. And this, I think you probably got a purer version of it by not doing that. But yeah, the only having to have 3 givens in order for this to resolve when almost all of the digits you get to fill in are 1s, 2s, 3s, 4s, 5s, and 6s is quite a thing. Okay, there's an 8-9 pair in column 9, so there is. So that's not an 8, and that's a 6 or a 7. But spoiler, it's not a 7. So that's a 6, and that's a 7. That being a 6 makes that an 8, makes that a 9. These aren't, or sorry, that's not 9. That probably places a 9 somewhere. Yes, so that's a 9. That's an 8. That's a 9, that's an 8. That's a 9, that's an 8. Let's see. This is a 6. It's a 7. That's an 8. And that's a 6. Oh, sorry. I thought I was done. And that's a 6. And that's a 7. There we go. So yeah, the point was only one region ended up having a repeated digit in it. Or did no digits end up with repeated digits in them? Why do I not see it? People in chat were talking about it. Yeah, I don't actually see any repeats. Yeah, that was a super fun puzzle. I enjoyed that a lot. Nice. Alrighty. Well, let's proceed on to the next puzzle. So, I was going to say it's been a while since we've done a grkles puzzle. But it's not actually true. But because we did Death, which is a grkles Turganis one. But anyway, we do lots of grkles puzzles around here because we like grkles puzzles. So this is a between lines. Thank you for giving the like. We greatly appreciate the likes on the stream. Excuse me. This is a between lines fortress Sudoku. The between lines are these things where there's 2 circles on the ends, and what they say is that if you put digits in these circles, then all the digits between them have to be between those 2. So in this case, if this were a 3 and this is a 7, all these digits would have to come from 4, 5, 6. Okay. Oh no, my face cam is hiding part of the rules. Let's see. How about that? So that's how between lines work. The fortress clues, and so these are, and so don't look at the arrows. The arrows are completely nonsensical. But the yellow digits are digits which are all greater than all the digits around them. So for example, this could be a 7 as long as these are 6, 5, 4, 3, for example. So all the digits orthogonally adjacent to them have to be strictly greater. Strictly less. And somehow that got transliterated into arrows. And fortunately, in this puzzle, we don't have to worry about the fact that there might be less than. There's none of that here. Just regular old max clues. Which I would rather call them maxes, but whatever, anyway. And also this white dot says that these 2 digits are consecutive. But there is no negative constraint on any of these things. And it looks like no negative... there's no negative constraint on fortresses. I know there's no negative constraint on fortresses because if there was, there would have to be a fortress in box 8, and there is not. Okay. So... we get to really play with 1s and 9s here, and particularly 1s, because if you think about it, you can never put a 1 on a between line, and you can also never put a 1 on a fortress. And so if you look at something like row 9, for example, there's already only a handful of spots where 1 could possibly go. So let's see, in this box, the 1s can only go here. in this box, the ones can only go here. In this box, I guess there's a jajillion places. But I'm going to mark it anyway because I'm assuming we're going to be looking for aligning things. Let's see here. Yeah, here the ones can go there or there, which somehow is utterly failing to align. Let's see. Here the ones can go any of those spots. Here it's one of those spots. I was really expecting that these were going to align immediately. Yeah, my normal thing looking at this would be to assume there was a negative constraint on fortresses, but there is not in this instance. Okay, the one goes in one of those places in that box. The one goes in one of those places in that box. And if I'm not mistaken, absolutely... Oh, sorry, I didn't mark that one. If I'm not mistaken, absolutely nothing aligned out of all of those. It's very unfortunate. Okay. Now, let's think about where 9 can go in this box. Hey, grkles. Because I think 9's actually even more constrained here. I have a negative constraint fortress puzzle. I forget what it's called. Oh, I think it's called negativity, in fact. So where can 9 go in this box? And so here's the key observation. These two digits are both bigger than everything else around them. But they can't be 9. So these two digits, not only are they not 9, they also tell us I can't put a 9 next to them. I can't put a 9 anywhere on a between line. And so actually the 9 is in this box is forced into one of these two cells. So I can probably continue to play that game with using the fact that 9s can't be placed next to fortresses. So you can never place a 9 in any cell that's adjacent to a fortress. Nor can you place a 9 on a between line. And so the 9 in box 3 is in one of these three places. So yeah, we're going to go play the same game with 9s and see if we can get something out of it. Either that or we're just going to have the most ludicrously pencil-marked grid that I have ever had in a solve of a puzzle, and that's okay. These are the places 9 can go here. Okay, so in this box, 9 can go in one of these places. Let's see. What about in this box? Can't go there, 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 or there. Okay. So we finally have a place where we actually get something meaningful. 9 is locked into this column in box 5, and ergo that's not a 9, which places the 9 in that box, or in this cell. So that is now a 9. Oh, why did I put a 9 on a between line? I don't know why I put a 9 on a between line. Don't listen to me. This is not a 9 now. Now the 9 has to go in one of these two cells. Down here. We get our little digit dance. Although I kind of feel like 1s and 9s, like 5s, should probably not get digit dances in a fortress between lines puzzle. We'll dance for the first real digit, too. Thank you, Listesh, for pointing that. How did I don't even sleep or something. I should sleep. Okay. So yes, still can't put the 9s on the between lines. So what about over in box 6? So box 6, we can't put a 9 here, 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 or here, or here. So the 9 in box 6 is in one of three places. Let's see. What about here? So I can't put the 9 in those places. I also can't put the 9 on this white dot, which is probably why the white dot is here. Because if I put a 9 on the white dot, then I also put an 8 on the white dot, and then both 9 and 8 are used, and one of them is next to this. So the 9 in this box is actually bullied out of the white dot. So the 9 in this box is pushed into one of these schedzillion places. Let's see. In this box, the 9 can't possibly go on any of these places. It can't go next to the fortress, so the 9, and it can't go in the same column as a 9, so the 9's going to go in one of those places. Okay, and here we can't put the 9 on a between line. We can't put the 9 next to a fortress. Can't put the 9 next to a fortress. So the 9 in this box is going to end up in one of those two places, which is going to rule 9 out of this cell. Okay, so now we can start hopefully reaping our rewards, because now we finally have two boxes where the 9s align, which is the whole thing that I was looking for this whole time. The 9 in both box 6 and 9, provided that I marked this correctly, they're in columns 7 and 9. So that means this can't possibly be a 9 because there's already a 9 down here somewhere, which you can think about in a bajillion ways, but I think the most common is to think about it as an X-wing. So that 9 bumps over here and says these aren't 9. So yeah, one of these is a 9. The box 6 marking of 9s has an extra 9. Let's see. One of these 9s is not possible. Is that what we're saying? Ah, yes, this one can't be a 9 because it can't be next to a fortress. All right. Yep. Got it eventually. Let's see. So 2 down there. So we've got ourselves a little itty-bitty skyscraper on 9s that I don't think is a useful skyscraper because these are the two tips are in the same box, but that's the shape. Okay. Box 5 9s. Ah, yes. Okay. Wait. Box 5 9s, see box 8. Oh, yeah. These 9s are in that column, so that's not there. Ditto box 7. I don't know what we're talking about box 7. Why can't row 9, column 2 be a 9? Because if this was a 9, this would be an 8-9 pair, and now this fortress would be broken. I can't put a 9 anywhere on this white dot. That's a very clever construction, by the way. I'm assuming it was put in at the last minute as a disambiguator, but it works very cleanly to note that actually you can't put a 9 on this anywhere. Okay. 9 is actually placed in column 2. Let's see. Ah, yeah, this can't be a 9 because, again, I don't know why I marked that, but it's next to that anyway. So now, yes, now the 9 in column 2 is actually placed. I had this marked as being able to be a 9 and then just unmarked it for some reason. All right. So there's our 9. Well, it's a very sexy dot, grkles. Let's see. Row 6, column 9 can't be a 1. The fortress forces it. Row 5, column 7. Sorry, the fortress in row 7, column 7. Ah, okay. Got it. Okay, beautiful. So if we look at this between line in its totality and think about what it's telling us, this digit is bigger than this digit. And ergo, that tells us that this is the small end of the between line and this is the big end of the between line. So that means this is definitely not a 1. Hey, Playmaker, welcome. Good puzzling today so far. Okay, so this is low, this is high, and so because of that, let's actually mark candidates for this. So there need to be 6 digits bigger than this. So this can be 1, 2, 3, and there need to be 6 digits smaller than this. So this can be 7, 8, 9, I believe. As we sort of break our way into other things. Yeah, Playmaker, I somewhat regret the way I pencil marked this. I assumed that the second I pencil marked this, it was going to tell me where all the 1s and 9s were by stuff aligning, but then nothing aligned. So it just looks like a mess, but we're pot committed now, so we've got to stick with it. Let's see. Okay, the 9 in box 4. Oh, because this can't be a 9 either. I did not do a good job of not putting 9s next to fortresses. So thank you, Listesh, for noting that. Okay, so that's a 9, that's a 9, that's a 9. Okay, so now we can go back and note that this is the low end of this between line. So you could imagine this being 8, 7, 6. This has got to be at most 5. Okay, so that's going to place the 9 in box 8. Because now that's the only place for a 9 in box 8 is there. Which is very interesting because it now means this cell is actually unable to be an 8. Because if this cell wants to be an 8, then it would need to have a 9 on one of the ends, and both ends are locked off. So this is now actually at most a 7. On the other hand, it's definitely at least a 3. Let's see. 8 in box 7 is very restricted. Well, it can't go next to that. And I can't put it on this, because then it would put a 7 there, and that would be bigger than everything. So the 8 in this box... and the 8 can't go here either. Because if I put an 8 next to this fortress, well, now this fortress is at most 8. So it can't be that. So in fact, 8 joins the... Oh, sorry. There's 9s pencil marked here that are just nonsense. But there is an 8 in one of these two cells. Yeah, good point, Alima. This can't be a 3. I wasn't super... I wasn't super worried about the low stuff because I'm pretty sure it's not going to turn out to be low, but you're right. You can, without really looking at it, see that if this were a 3, I'd need to put a 1, 2 around it, and that's not going to work because I can't put a 1 on a between line. Let's see. Row 9, column 1. Oh, yeah, row 9, column 1 could be 8. Yeah, I think you're right. I think that can be 8. How can the cell you pencil mark be a 3? Oh, yes. Matthew also got there. Yeah, this can be an 8. I just missed it. Let's see. So where does 8 go in box 4? It can't go next to a fortress. Can't go on the between line. Sorry, can't go next to a fortress. So that rules out of all of these places. So 8 actually could be on a fortress. If 8 is not on a fortress, then it's there exactly. So there's 3 places 8 can go in this box. I don't know if I want to pencil mark that. Row 9, column 1 sees all fortress lower cells. I'm trying to make sense of what is being said about this. I don't think I quite get this. Row 5, column 3 can't be an 8. Because that can't be a 9. Right, okay. So actually, the 8 is, in this box, can only go in one of the fortresses, I think, is the moral of that story. Can't go next to the fortresses. Can't go next to the fortresses. Can't go on top of a 9. Can't go next to that fortress either, for more complicated reasons. So yeah, so one of these is an 8. And ergo, one of those is an 8. Okay. Would it be okay if there was a 1 on this dot? Or would it break if I put a 1, 2 here? If I put a 1, 2 here, then this has got to be at least 3, 4, 5, 6, 7, or 8. That seems fine. Let's see. 8's in box 2. Let's see. Could still go either of those places. Could go there, I think. Or there. No, sorry, not there. Yeah, so I think 8 can go in these 3 places in box 2. Per Chris's comment. Okay, what about H's? Or sorry, H's. What about 8's in this box? Are they in this a similar situation where... Yeah, I guess the 8's in this box can go in one of these 3 places. And the 8's in this box can go in one of these 3 places. Where does 8 go in row 3? Well, we've ruled it out of those cells. It's not going in that cell. It's not going in that cell. Yeah, yes. Okay, 8 in row 3 has to be in one of these 2. Okay, so that is a good way to phrase that. Okay, so the 8 in row 3 can't go over here, because none of those cells can be an 8, as we've argued before. Could go there, but it can't go there or there, because it can't be next to a fortress if the 9 is gone. And therefore, we get our little 8's marked in these 2. Okay, and so now once I have that, now when I ask about 8's in box 3, oh, that doesn't change the answer for 8's in box 3. 8's in box 3 can still go in any of those 3 places. Sorry. I was getting excited. Russ saw it a different way, which is to say, we argued these are the 3 places 8 can go in this box, these are the 2 places 8 can go in this box, and ergo, the 8 in this box has to go in row 3 and can only go in one of those 2. So Russ saw it a different way, but got to the same conclusion. Oh, hey, Alex, welcome. Having pencil marked those 8's in box 2, you can place 9 in row 4, column 7. Yes. Okay. Excellent. Okay. Yes. Alex has an excellent point. Eleventicles has the same point. Carl has the same point. I see many people have the same point. We just put an 8 on a between line. And as soon as you put an 8 on a between line, it tells you that one of the ends has to be a 9, because one of them has to be bigger. Well, it's not that end. So therefore, it's that end. That's a 9. So this is not a 9. Now, that places the 9 in box 5 there. See, this is kind of what I was expecting when I started this whole journey. Okay, now I want to look at this, because this is now very sus. If this is a 7, then the maximum this could be is a 6. And we'd have to put like 5, 4, 3, 2 around here, which is, I suppose, technically maybe possible. Yes, we have one final 9. Okay. So I expected that to happen quickly, but it did not happen super quickly. But we now do have all the 9's. Once we have all the 1's, then our pencil marks will look much better. Okay. So here's an interesting question. Where does this digit go in box 9? This digit I am going to make green. Where does it go in box 9? Well, green is larger than these. So green cannot go any of those places, and it can't go those places either. So this cell is green. And therefore it's not a 1. One of these 2 is green, although that's not really going to tell me anything. Okay. So that was huge. That's really nice. That was a nice setting to let us get those there. Okay. Unfortunately, we seem to have already had an X-wing on ones that would have told us that, but whatever. Uh, so yeah, so where is the 8 in box 9 is a different way of getting at the same question, or a similar question. Namely, 8 can't go on the between line, because neither end can be 9, but it also can't go next to one of the fortresses, which can't contain a 9. So in fact, green is 8, and that will get a real digit dance, because that feels well-deserved. No, sometimes I feel like my digit dancing is more like digit boxing. I'm not sure. I'll have to work on that. Okay, so that means that's not an 8. So see, when I didn't pencil mark this as an 8, I saw that and now 8 is placed in box 3. It's placed here. I can lose the green coloring for the moment because it can't go next to the fortresses again. So now that is going to place 8 in box 1. It's going to go there. Let's see. Okay. So we can continue our journey of 8s. Let's see. This needs to be at least 6. Yeah, so this is from 1, 2, 3, 4, 5, 6. I don't really want to pencil mark that. So yeah, where is 8 in this box? It's not in any of those spots. So the 8 in box 5 has to be in one of these 3. It's either in one of the fortresses, which seems very likely, or it could go right there. Better question. Where's 8 in box 4? Let's just look at our pencil marks. We don't have to think at all. We've already done the thinking, so we just get to place the 8 there for free. Which does say that, yes, the 8s go in one of these places, which now gives us an X-wing on 8s, which means that the 8s in column 4 and 6 are spoken for, and so the 8 in column 5 can't come here or here. It has to come in one of these two cells. So one of those two is an 8. So now we have that little X-wing on 8s. Okay. So now we can play a similar game. Where does this cell go? Okay, yellow was absolutely the worst choice. Where does this cell go in box 9? It goes there. Because it can't repeat on its between line, can't go in its horizontal. It's not 8 or 9, so purple goes in one of these two places. So is purple going to show up on this dot? I don't think I know it can't, unfortunately. I know one of these two cells is purple, because purple certainly can't go on one of these yellow lines. Let's see. Whatever this digit is, it goes in one of those two places. Okay, in fact, I should pencil mark this. At most, this would go 7, 6, 5, 4. And so this is at most 3 as well. Could very well be purple, of course. Row 7, column 6 can't be 3. If this were a 3, it could go 4, 5, 6, 7, 8. Ah, because this is an 8. This being an 8 knocked off a degree of what this could be, because this is not allowed to be a 9 anymore. So this could go at it just purely in terms of thinking about counting. This could go 8, 7, 6, 5, 4, 3, and this could be a 2. Just in terms of there have to be 5 digits lower than 8 and bigger than purple. So purple is actually a 1 or a 2. Let's see. We could do the same thing here, but it's not nearly as good. Yes, counting with zeta. Everyone's favorite weekly pastime. We can add an extra weekly stream of computing intersection numbers on algebraic surfaces with zeta. That's what I've been doing lately. I suspect that would not be as popular. Okay, so let's think about this box. I have to put a 7 in it somewhere. The 7 cannot go anywhere but on one of these fortresses. Because otherwise it will be adjacent to one of the fortresses and will break it. Okay, and I see great minds think alike. Chris is now talking about 7s, but Chris is thinking about 7s in box 1. So in box 1, we have a similar issue where I can't possibly put 7 on the between line because one of these digits would have to be bigger than 7, and it can't be. So one of these is a 7. Seven in box 2. Can't go in any of those places. Actually, can't go in those places either. So yeah, 7 in box 2 actually joins the 8. Because I can't. So the 7 can't be in these cells. It can't be on the between line for the same reason over here. The ends would have to be, one of the ends would have to be 8 or 9. That's not going to work. I can't put a 7 here because, sure, one of these could be an 8, but they can't both be 8, or that would be problematic. So, in fact, this becomes a 7-8 pair. So that was a good spot to whoever said that. Carl. Kadira's ghost could show up. I'm not 100% sure Kadira is dead. Do you know that Kadira is dead? I would have guessed not, but... Okay, so that 7-8 pair says that's not the 7. So that is the 7. Further counting with zeta. 6, 5, 4, 3. So this is a 1 or a 2. Much like purple. Now, I have to put 6 in this box somewhere. The only place I can possibly... Oh, no, I could put 6 in 2 places, can't I? I could put 6 here or here. But 6 is definitely in this column. I can't put 6 in one of those places. So 6 is in one of those 2 places in this box. So... doesn't quite get me there. 5 is in one of 3 places. I think, for a similar reason. Hey, Bronte. Oh, no, because this could be a 6. If this is a 6, then 5 can actually go, like, basically anywhere at once. 1's in box 1. Gaze longingly into box 3. So the 1's here, gaze over and see that these aren't 1's, which is gorgeous. And so that's a 1. Good spot. Oh, that sucks, grkles. I'm sorry to hear that. So that's not a 1 anymore. So now, yeah, now the 1s are officially in one of these two places. In fact, actually, in this box, let's ask where 1 and 2 are in box 6. Well, I can't put... Oh, darn it. No, I could put 2 here, couldn't I? Darn it. Chris is saying we should do a Counting with Zeta episode about this circle. So this would go 7, 6, 5, 4. So this could be 1, 2, or 3. I agree. That was a good episode of Counting with Zeta. Yeah, those algebraic geometers, they tend to live a long time. We just lost John Tate and Grothendieck. And we still have Sayre, I'm pretty sure. Which is just insane. I'm told he's still good at table tennis, or at least I was told he was still good at table tennis as of a few years ago. Row 3, column 9. We did not... When we updated this, we needed to update this as well, because let's see, this could go 3, 4, 5, 6, 7, 8. Okay, so is there a problem with this being 4, 5, 6, 7? Yes, there is. Wait, no. If this were 3, this would have to be a 7. I don't think I see that. But I believe there's some smart thing that's eating one more level of freedom that I'm not seeing. Yeah, Tate definitely has a lot of terrifying things named after him. My favorite John Tate moment. This is, by the way, this is a famous number theorist who died recently. But I was at a conference where Tate was sitting in the front row, and there were all of these tables, and the talk ends, and everyone is like slowly packing up their stuff, and I just watch Tate jump over the table so that he can get out of the room faster from the front row, rather than waiting for a bunch of grad students to get out of his way, which was quite lovely. Let's see. This number is smaller than both 7 and 8. Okay. Yeah, Tate is my advisor's advisor's advisor. So my great grand advisor. Yeah, my great grand advisor. Okay, this 7 looks down and says that's not a 7. I could do that much. Row 3, column 9 needs a home in box 6. So yeah, this cell is one of these. So the point is, this isn't a 1 anymore. That's beautiful. Okay. This cell, somehow I didn't learn my lesson from last time. Green needs a home in box 6. Green therefore can't live anywhere along the between line, so green lives over here. But green is not 1 anymore, which lets us actually fill in that these cells are from 1, 2, 3. So that's a really good spot, Russ. And so now... sorry, I thought that was going to do more, and then I don't think it did anything. But it was a beautiful spot, regardless of whether it actually did anything or not. There are a lot of stories about the economist de Broglie that are of that sort, like the Dirac thing. Like when de Broglie won the Nobel Prize in economics, a reporter was interviewing him, and the reporter asked if he could give a glimpse into what it was that he had done for his research that had got him the Nobel Prize that would be accessible to the general public, and he just said no. Yeah, I looked at whether purple and green could be the same. I don't think I see why purple and green can't be the same. Let's see. So if purple is not green, well, then purple could be 1, and that would be fine. Yeah, I think there's too much flexibility for purple to be green or purple to be 1 for us to figure that out. The manifold doesn't have to consent for you to do surgery on it. That's probably true. I do recall having an issue with my... I was working on my dissertation and my advisor was out of the country, and I needed I needed to fill out a form for the Human Subject Review Board, which, spoiler, there were not going to be any ethical concerns regarding the human subjects in my study about solutions to points on elliptic curves over blah, 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 function fields, whatever, whatever. But my advisor wasn't there to sign something saying that, and there was a whole big hubbub about trying to get them so that they could approve the ethical issues related to human subjects for my dissertation. Row 9, column 3. So now Matthew is now looking at this cell and looking at the implications of the white dot. So if this is a 4, then we would need this to be a 2-3 pair. And we'd need this to be a 2-3 pair. Oh no, this could... So I think this works, maybe. I think this could be a 4 if this is a 1 and that's a 2 and that's a 3 and that's a 2. The answer is there were not human subjects, but because of bureaucracy being what it is, I needed a form to say that there weren't human subjects. Okay. Let's see. Okay, so Chris is saying then can't have 1 on the endpoints. So if this is a 4, then we can't have 1 on the endpoints? I think I would believe that, although that's getting further down the chain than I would prefer. So maybe I should ask, should I ask about where... Can I get something by asking about where 1, 2, and 3 go in row 9? because one of them goes there. And one, of course, goes in one of these two places. No, I guess I could hide. Oh, hey, this is close. So I certainly can remark that I can't put the 7 on this dot, but I could still put the 7 there, I suppose. So I think the 7 actually could go in any of these places. But the 6 and 7 in this box have now been bullied over into these cells. Oh, actually, sorry. The 6. Oh, yeah. The 6 in this box is now actually quite restricted. Because the 6 we placed at some point in our lives, we placed 6 in column 1 in box 1. So 6 can't go here. 6 can never go here. 6 can never go on the dot. So actually 6 in box 7 has to go in one of these two places. Now, if 6 does go here next to this fortress, that would mean this fortress would have to be a 7, which, let's be honest, it probably is. Oh, okay, good point. Chris sees, I was saying 7 goes in one of these. 7 doesn't go in that one, because that would put a 7 next to this fortress, which would break it. So, in fact, 7 goes in column 1 in box 7. So actually one of these two is 7, and now I know which one it is. It's that one. Because I can't put a 7 here for all of the reasons that we have just outlined. Okay. Does that get us buy-in to push 7s around anywhere else? Okay, so where can 7 go in this box? Not... Well, it never could have gone there. Yeah, the 7 can't go any of those places. Can't go in any of these places. So yeah, the 7 in this box has to be in one of these two places. I don't know if it's worth marking, but I'll mark it anyway. Let's see. Okay, so Matt is looking at... Okay, if this is a 4... then it forces these to be 2, 3. Which makes purple 1, which then breaks. Beautiful. Okay, so let me say this. Let me say this slower now that I understand it. If this cell is 4, what Matt notes is that makes these two a 2 and a 3. Now, that means I put a 2 on this between line, so I have to put a 1 on one of the circles on the ends. But beautifully, by putting a 2, 3 here, I have actually made purple 1, which has made it impossible to put 1 anywhere on the circles because purple actually sees both ends of this. And so, in fact, not only can this not be 4, these digits can never be 2. Because if either of these digits is 2, we immediately have the same problem. If either of these is 2, then purple is 1, and it's impossible to put a 1 on the line where we have to have it. So these digits are actually only from 3, 4, 5 that are on here. So let's take this a step further. Oh, wait, no. So if purple is 2, yeah, then I guess these have to be 1. Or sorry, one of these has to be 1. They're not both 1, obviously. Yeah, okay. I'm still trying to look for like hidden pairs in row 9 because I keep thinking like, yeah, so 1 and 2 have to go, and then not quite having it. Actually, where does the other of 1 and 2 go in row 9? I can't put the other of 1 and 2 on this line, because if I put the other of 1 and 2 on this line, then I now have a huge problem because I need this to be a 1, but I can't because I just put a 1-2 pair in the box. So the other of 1 and 2 does actually have to go here. My spidey sense about that, I think, actually, for once paid off. I think this is the other 1, too. Which is nice because it tells us that the 1 can't go on this dot anymore. And it also tells us that the 1 can't go here anymore. So, in fact, this digit is now a 6, 7, or 8 in order to not break the world over here. Okay. Now there has to be an enormous amount of pressure on what this can be. Let's see. It could be 2, 3. It could be 3, 4. I think that's probably it, right? I think this could be 2, 3, 3, 4. There's no way it is... Oh, wait, maybe it could be 4, 5. Dagnammit. 2, 3, 4, 5. Certainly not 5, 6, 6, 7. Yeah. 2, 3, 4, 5, I guess. 7, 8 pair in column 1, box 7. Yes, good point. Okay, so we've bullied 7 and 8 over into here, and so they have to live there. Okay, and so now one of these two is a 1. Yeah, this digit over in this box is going to have to live in one of those two cells, but that's okay. Where is 1 in row 8? Good question. So 1 in row 8 has been pushed here. Good catch, Chris. So that is going to make these 2. Well, enjoy the Eurogames, Russ. I will let us know if you find anything good. Let's see. So that's not 1. Okay, so we can depurplify these. Okay, so these can now just be anything they want to be, with basically no restriction. Let's see, 7 in row 9 in 2 places. Yes, 7 needs to go in one of these 2. Good catch. So this is not a 7, is the upshot of that. Yeah, we can throw a 1 over here. I'm trying to think if this can really be 6. Because if this is 6, that forces that to be a 5. No, this can't be 6. Because if this is 6, it rules 6 out of the entirety of row 9. Because if I make this 6, I can't put 6 here, and I can't put it along the line. So this is 8. Which makes that a 7 and that an 8. Let's see, did those 8s buy me anything? Not especially, it would seem. But hey, I felt good about the deduction. Unfortunately, that still doesn't tell us that this is a 6, because now that this isn't a 6, This doesn't have to be a 6, because I could put 6 over here without issue. Just make that a 6-7 pair. Green in box 9 now. Yes, green is probably not here. So green is this none 1 digit, which shows up over here. I should have done that. I don't know why I didn't. So green is this digit, which you know showed up over here. And so the question is, could green be here? No. So this is a 2, which means green is 2, which means this is a 1-2 pair. Which lets us lose that coloring. That was a good spot. Who saw that? Carl, and I swear someone else said it, because I thought they phrased it differently. But anyway, good spot on the green now being done over there. So green was purple all along. That's true. That is a good point. So that 2 now is huge, because it now places a 1 over there, which I assume matters. Maybe it doesn't matter at all. This isn't a 1 or a 2 anymore. It is a 3, 4, 5. Oh, directionary on Cracking the Cryptic today? Woohoo! Which one? Is it one of the ones I did? Let's see. Ah, yes. Okay. So now, and so someone said this, but I did not understand it at the time. But I now understand it. Where does 2 go in row 8? Well, it can only go here. And so, ergo, this has to be a 2-3 pair. So that's not a 3. It's a 4 or 5. These 3 cells are now known. 4, 5, 6. If I know these are 4, 5, 6, I probably know which one this one is. Although, given the state of my brain today, I wouldn't put it past me to miss that. Let's see, these need to be a 3 and a 7. And again, I can't put the 3 here because it will be less than the 4, 5. So that's the 7. That's the 3. That gives me a 7 up here. Okay, let's see. So we've got 1, 2, 3, 4, 5, 6, 7. Yeah, okay, 4, 5, 6. So yeah, this is a 4, 5, 6 triple, as one would expect. I know there's a 3 down here somewhere, but who knows where. Okay, let's write in the rest of this column. 3, 4, 5, 6, 7. That one I know is not a 7. These I know are not 7. So in fact, that is 7. In fact, the 7 was just placed by Sudoku, if I'd paid any attention at all. I did not. Okay, 7 is placed in box 6. Yep. I just noticed that in the most roundabout possible way. The 3 is in one of these 2 cells, so this is not a 3. So this digit is bigger than 4 or 5. So this is 5 or 6, because it can't be 7, 8, or 9. So let's see. What else is left in this box? 3, 4, 5, 6, I believe, is all that's left. I guess I don't know a ton about that off of the bat. No, not a 3. Wait. Did I really have the 3 locked here, or was that just me not pencil marking these? I have this feeling I just said 3 had to go in one of these 2 cells without really thinking about it. Did I screw that up? Let's see. Chat is not telling me I screwed up. I'll go with it for now. But if the puzzle breaks, then we'll know what happened. So these are 2, 3, 4, not 3, 4, 5, 6, 7, 8, 9. Okay, 4, 5, 6. Oh, yeah, the 3 is up. Okay, yep, that was right. Okay. This 3 was what told me those weren't 3. Okay, got it. Yes, okay. And now the question is, where does 6 go in this box? Because 6 can't go in either of these places because it would definitionally be bigger than this. And so that's a 6 because it sees everything else in the universe. Good catch, chat, in that one. Oh, don't worry. I am happy to blame chat when things go horribly awry. That was nice, the way it was sort of pushed towards this, because sort of like we pushed all the other digits out, so all the remaining digits got pushed here, and this was forced to be the biggest of the remainder. Okay. Oops. Speaking of 3, 4, 5, 6, 7, 8, 9. Okay. Okay, that was not as instructive as I hoped. 7 in box 5 can be placed. Okay, 7 in box 5 has to go in one of these 3 cells. Okay. Could the 7 go here? And the answer is no, although it takes a second to see. If I made this a 7, that would be an 8. And now this would need to be an 8 or a 9, but it could be neither. Likewise, if I put the 7 here. So actually the 7, and this is a beautiful spot by Chris Palmer, the 7 is placed here, which then is going to place this 7 down here. And that 7 down there is going to give us that that's an 8 and that's a 7, which is then going to give us that that's an 8. Okay. Now, that's not a 1 anymore. That's not a 1 anymore. So now, where does the 1 go in this one, box 2? The 1 can only go here now. So that's a 1. And let's go ahead and write out all the digits that are left in, let's do this column first. We've got a 1 and a 2. You're not a 1. We need a 3, 4, 5, 6 is what's left. So those can't be 6. This needs to be bigger than at least 2 of 3, 4, 5, and 6. So it's not 3 or 4. This is 5 or 6. And so that's at least the teeniest bit of progress. This digit has to be at least a little bit small. But I don't think I can productively use it. Row 2, column 6 sees a 6. Row 2, column 6. Yes, excellent. So yes, if I had bothered to look up here, then it would have said, yes, so this is the only place for 6 in the column. So yes, so that is a 4, 5 over there. Okay, I was encouraged to pencil mark this row, so why not? 1, 2, 3, 4, 5 is what's left. This is not a 1. I think it can be any of 2, 3, 4, or 5. This is not a 1. I think it can be anything. So this digit has to be at most 4 now because of that digit. This 6 has now placed 6 over here, which has now, I am being told, place 6 over here. Yes, because of this 6. So that 6 is there. So yeah, we've got 6s just bouncing all over the place. That 6 looks down and says, that's a 5. So that's a 4. That's a 3. That's a 6. Uh-oh. I broke it. No, I'm okay. Never mind. So that's a 6. Not a 5. Not a 5. This certainly can't be a 2 or a 3 anymore because there's a 3 or a 4 on the bulb. So this is only from 4 or 5. Let's see, I can finish the 6s. Yes, the 6 in this box goes here, and so the 6 in this box goes here. So what is left in this domain are 2, 3, 4, 5. These, again, can't be 5. And this needs to be bigger than 2 of them, so it can't be 2 or 3. So this is a 4 or a 5, next to a 2, 3, 4, and a 3, 4. Oh, but that just means this is a 5, because there's nowhere else for 5 in the box. I am now realizing. Which is going to place that is a 5 as well, just by Sudoku. Sudokology, or whatever I call it. Let's see. We need a 2, 3, 4, 5, 6, 7. No, not 6, 7, 8, and a 9. Okay, this is a 2, 3, 4. That's not a 5, by the way, because of that 5. Yep, we've got that all doing. Yes, everyone give Derek a big round of applause for his feature. That's a 4 that I cannot wait to watch, but it will be a while before I can watch it. So that's a 4, 5. So that's a 3, 5. So that's a 4. That 4 comes down here, so that's a 5. That's a 4. That's a 3. That's a 5. That 3 removes 3 as candidates from up here. One of these days while I'm streaming, I'm going to get a feature, but so far they've dodged that. But I'll have to figure out if I'm like, okay, bye everyone. I'm going to go watch this now. Yep, 2, 3, 4, 5. That one's not 4. Okay, what about this column? 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is 2, 3, 4. I could stream watching Simon solve my puzzle. That would be interesting. It's not a 2, whoops, or a 5. It is a 3 or a 4. Let's see, 2, 4, 3, 4. 2, 3, 4, 5. Let's see, I can finish column 2. Oh, I can finish column 2. Excellent, good spot. So that's a 2, that's a 3, that's a 3, that's a 2, that's a 5, that's a 2, that's a 4, that's a 3, that's a 4. These are not 4. Yes, hello, Tallcat. We did finish Only Murders in the Building last night. Excellent, excellent recommendation. But now, sadly, we have to continue to fill the TV void. Okay, what is in this column? We still need a 1. We've got a 2, 3. We need a 4, 5. Yeah, 6, 7, 8, 9. Okay, 1, 4, 5 is what's left to place. All of which seems cool. Ah, right. This, now that 3 actually says that this can't be a 3 anymore, so it's a 1 or a 2. But it's not a 2 because there's a 2 in the column. So that's a 1. That's a 1. So that's a 2. That's a 1. 2. That's not a 1 or in the corner. 3, 4, 5 triple places a 2 over here. 3, 4. I'm sure I did that in a really circuitous way. I bet there was a way that did not involve using a triple to see that. That's a 2. That's a 5. That's a 4. That's a 5. Let's see. These are not 5s, so they're a 3, 4. And it's resolved by this. So that's a 3 and a 5 and a 3 and a 4. Very nice puzzle. I like that one a lot. That is a very smooth. Very smooth path there. Nice. Okay. I'm going to take a short break, and then I'll be right back, and we can do some more Shikaku-Sudoku. And we're back. And yeah, that Kropke was definitely a very artful Kropke dot choice. Let's see. I can embiggen myself a bit for this one. All right, so good news if you liked the previous puzzle, because this one is going to have a very similar rule set. We need to break the grid into not triangles. Though that would be fun, but we're not going to do that. I'm going to break the grid into rectangles. And so we need to do that so that each rectangle contains exactly one circle. So, for example, this could be a rectangle. We'll have to. We can do triangles as soon as we get a tool that lets us draw things. So the first puzzle of the stream was a Shikaku by Emphyrio. We're now doing one by Qodec. Spoiler, this will not be the last one of the day. There's just a run of these that I had that I had been meaning to do for a while. And so into the circle that goes with the rectangle, so for example, if it looks like that, into the circle that goes with the rectangle, you put the size of the rectangle. So for example, this would be a 6 if I put it like that. Okay. And of course, rectangles can't overlap. And so this is a thing that you might be expecting that's not true. Digits can repeat inside a rectangle unless there is a reason they can't. So, for example, it is perfectly fine if that's a 3 and that's a 3. No problem with that. Oops. Alrighty. So I believe these are exactly the same rules. Is that? Yeah, everyone put in your bets for row 1, column 1. I have indicated that it is going to be the bet cell. Get in your bets real quick because it is a 1. I'm going to hold off on counting that as a digit dance. I don't think this is quite a danceable digit. I think there's we will wait on the that. Let's see. Jaleb would like to make row 8, column 5 the bet cell. We can make this the unofficial Jaleb bet cell. Let's see. Oops. I don't want to do that because it hides the fact that there's a circle there. Okay. Let's look and see. Okay, so the thing that was really helpful in the previous puzzle was to count what the maximum size of a region things could be. So, for example, the maximum size of this cell would be 9. And so we could mark this as being 2 through 9, but that seems somehow unproductive. I'm suspecting it probably can't actually do that, but I don't see why not yet. What about this cell? This cell could get up to 5 if it runs straight down. Otherwise, it can get up to 4. So this is 1, 2, 3, 4, 5. This cell, it's not 1, so it's at least 2. So let's go ahead and blue this. It's at least 2, and it can't grow left, so it's got to grow down. So this is a 2 or a 3. So we know there's a boundary there. Row 9, column 5, some people are saying is limited. Let's see. So it can't grow up. But can't it be like can't it be like the whole row? Yes. So now this can't be a 9 anymore. So now we can go ahead and we can write out. So we said, oh, this could be anything up to 9. It can't be a 9 anymore. And it can't be a 6 or an 8 either. So this is now down to a more palatable collection of digits. Okay. This is at most an 8. This digit is at most a 4, right? It could take at most those cells. There are no unhighlighted cells that this can possibly take. So this is 2, 3, 4. This one can go up to 6, but it can't be 5. So I think this is a 2, 3, 4, or 6. I think this one can take up to 6 or up to 5. So I think this is 2, 3, 4, 5, 6. And this one can go up to 8, but only using evens. So it could go 2, 3, 4, 5, 6, or 8. I believe. Okay, that one was maybe not the most useful pencil mark I've ever made. There's a 3 in the column, so this one's not a 3. So that's a little bit of progress. Row 7, column 5. Yep, okay, so this can only grow left and right. So this is a 1, 2, or 4. It can't be a 3 because there's a 3 in the box. Let's see. Being asked if this is a 5... 2, 3, 4, 5, then what happens up here? And the answer is it breaks. So in fact, this can't be a 5 or a 7, because if this is a 7, the problem just gets worse. Because these two things now, they have to grow to be at least dominoes, but they can't both be a domino. So this isn't actually a 5 or a 7. It's actually only a 2, 3, or 4. And notice the given 6 and 8 are here, exactly telling us that we can't do something fancy like that. Okay, meanwhile, this one I think is at most 12, if we look carefully. I don't know how to pencil mark 12s into cells, though, so I will postpone that one for now. Two, 3, 2, 4. It's very suspicious. Let's see. Oh, could this be a 4? Oh, can I pencil mark C's? I don't think I can pencil mark C's. It won't let me pencil mark C's yet. I think that feature is coming too. See, the problem with this being 4 is that it could be 4 if it went like that, I want to say. Row 3, column 5 is max 4. Yes, okay, so this is bunched in both those directions. I could draw in some pencil lines if I want to feel like I'm being productive here. It can grow up to, at most, 4, and it can't be 3. So this is a 1, 2, or 4. Good catch. It's actually 2 1, 2, 4s in the column. This one can be 1, 2, 4, or 5. Right? Yeah, this is 1, 2, 4, or 5. This can be anything its heart desires, basically. This can be up to 4 if it stays in its line, and then it can be any of the evens above that. Oh, it's not a 6 because there's a given 6 that looks at it. Let's see, row 6, column 7, Chris says, is also a max of 4. Do I have to be really complicated to see why it can't do something like that? Is it going to break this string of cells? So it would force that to be a 1. That could be a 2. It's very restricted, but I don't want to chase that too far down until I absolutely have to. No problem, no problem. Just making sure that I am seeing everything. But we get to like have 40 or 50 of us, or however many of us, solving puzzles together, so we get to hopefully catch each other and not make too many mistakes, unless we're doing a Stefan compass puzzle. Then we'll only break it horribly once. Let's see. Yeah, the 1, 2, 4 pressure in this column is quite immense. Let's see. if this is a 4, is that a problem for what it does down here? And I think the answer is no. Unfortunately. Row 5, column 1 is restricted. Okay, so what can row 5, column 1 be? It can be 2, 3, 4, 5, 6. Oh, it can't be 6. It can't be 7. And it can't be 8 just because of the given. So yeah, moderately restricted. Okay. Is this being 5 a problem? Because if this is 5, it's forced to be exactly that. But unfortunately, there's lots of optionality for these circles over here. Oh, I meant to restart the timer, but I forgot to today. Or forgot to on this puzzle. Oh, let's see. Okay, so Matt says the 4 in row 2, column 1... this breaks if it's a 4. Okay, so the easy case is if it's a 4 and it does that. Actually, even if it's a 4 and it does this, this allows the option that that's a 2 going down and this is a 3 going across. Oh, no, that doesn't work because of that 2, 3. Oh, wow. Okay, so even this case is really complicated, but if you try and make this a 4 going across horizontally like this, the most these two circles can be is 3. And that's bad because I already have a circle that's at most 3. So I couldn't do that. So if I want to make this a 4, I have to do this. Oh yeah, I somehow missed the 7 vertically. There are lots of digits, but the digits don't block anything. Okay. What if this is a 4 shaped like this? Then what happens? Then this is now still at most 3. Okay, yeah. As soon as this cell is blocked off from this, we break. Because if you just imagine this cell doesn't take the cell below it, it's now at most 3. And so it also is now forced to go over here. Oh, wait. No, maybe I'm missing one. I think I'm missing the case. Oops. I think I'm missing the case that this is a 4, this is a 2, and this is a 4. I think that case is okay, actually. Oh, no, that doesn't work. It doesn't work because I made this a 2 and this a 4, and so I've broken this cell instead. Okay, here's a smarter way to say it. If I put a bar here, what's the maximum size this cell can be? Well, now the maximum size is 3. What's the maximum size that this cell can be? Well, because this has to grow, remember, it can't be only size 1, the maximum this cell can be is 4. So this is max 3, max 4, max 4, max 3. And that is 4 cells from 3 values. So ergo, this cell always takes this thing below it. Okay, and that doesn't feel too caseworky. Like I was sort of I felt like I was devolving into chasing all of the cases and was worried I was going to miss one. But now I think we can see that if this region did not take the cell below it, that would break. So now this region takes the cell below it, which immediately lets us D7 this cell. Also D4 this cell. Because now this can only get to 3, and now this can only get to 5 if it takes the entire thing. Okay. So we've got that. I'm trying to see if now anything breaks out the... this can't... Oh, no, it could be 5 if it ran down exactly like that. Is that broken? Let's check. If this is a 5... yeah, I think that's okay, unfortunately. Let's see. Is there similar stuff I can do? Oops. Yep, we have another one. They are multiplying. Be careful. They might become the next hit thing. It's like a mini theme of today. I think I'm going to do 3 of them today. Unless chat starts revolting and saying they never want to see one of these ever again. But I think it's a very cool, very neat little rule set. I don't actually know which of these is the original, so I have no way of attributing any of this. I am just doing the puzzles. I'm trying to imagine the world where this is a 4. So then that's a 2, that's a 3. I don't think I see it. Okay, so maybe we're doing the original one now. I mean, I do like drawing things, so if I get to use the pen tool and color stuff, I'm usually pretty happy with a puzzle. This is not the Secret Santa one, but minor spoiler, there is a Secret Santa one in my list of things I intend to do today. I did get Santa's permission to do puzzles, which was difficult, but not quite as difficult as getting Fistula Fells, so there is that. Fistula Fell is actually incredibly kind to just reply to a YouTube comment and say that I was allowed to do his puzzles on stream. Zetamath does drawings. Yep, that is going to be the new channel. Well, this is at most 9. I can say that. Maybe I'm supposed to be asking who gets this cell. Bye, Chris. Thanks for stopping by, and thanks for your help. Always appreciated. Hope to see you again. Whatever region gets this cell, it's going to have to be pretty big. Like, this is the smallest, but it could grab that, for example. I'm pretty good at drawing a 2-holed torus. That's probably about where my my manifold skills drop off, unfortunately. So maybe I should look at this column. I need to put a 7 and a 9 into this column, and I have not pencil marked those anywhere yet. I've considered so many times making a torus puzzle where like there's some sort of geometry thing that wraps around a lemma, but every time I think about it, it always ends up feeling like it's a gimmick rather than that it would actually like enhance the puzzle. So I've never actually made one. I know other people have made them. Okay, so Matt is pointing out this can't be a 6. Because if this is a 6, the only thing it can look like is this shape. Oh, I'm not saying I'm not ever going to do one. I think I probably will do one. I just haven't found the right way to base a puzzle around it where it works. I could make the draw an island puzzle style that I'm working on now even worse by making you have to draw toroidal maps of the various continents. Hey, Qodec, how are you? Okay, so this being a 6 bullies this cell into being a 2 exactly, which makes this a 4 exactly. And this a 3, and then this needs to be huge all of a sudden. I need a given digit 1 in row 7, column 5. Oh. Oops. I wonder where did I pick this from that did not have that. Well, that will make it easier if there is a... So we will take the given digit. Oh, I got it off of LMD and then didn't check that it disappeared off of LMD. My bad. Okay, well that is going to give us... there's some purplage happening over here. So that means this can't... Oops. That means this can't be 1. Oops, I still circled it. Yes, thank you, Qodec, for letting us know. Row 3, column 5. Yes, okay, yep. And now we have a 2-4 pair. Beautiful. We did have a 1 pencil mark here until this. But yes, now we have a 2-4 pair in here. So are we going to get another Y-wing? That is always the question. Okay, so now if this is 6, this is 3... and that's just immediately broken. Because if this is 6, now this is 3, but it doesn't even have 3 that it can possibly get. So this is immediately not 6. Getting ever so close on these. Okay, so if this was a 2, now that's a 3, so that's a 6. Okay, what happens if this is 6? Now, does that break? If this is a 6, maybe not. Now row 1, column 5 takes 3 digits in row 1. Good point. Good point, Jay. This is a 3 or a 6. Well, if it's a 3, it looks like this. That's the only way to work it. If this is a 6, then it looks like this. So it always takes these cells. That is a very smart observation. Yellow can't reach row 1, column 4 at all. Yeah, yellow is now doing this. So yeah, so now, but yellow can still go down here, I think. There may be further repercussions that we've not yet picked up on. What about this cell? So it could be a 1. If it's not a 1, then it's at least 5, but it can't actually... Oh, it could be 5 if it took exactly those. And it could be a 6. Can't be a 7, but it could be an 8 or a 9, I want to say. Okay, that was not as fruitful as I'd hoped. Row 6, column 7, circle. This is getting a little constricted. Yeah, so this could be up to 4 in the row or column, and it could make a 2 by 2. So this is 1, 2, 3, 4. Good catch, Pankuri. Yes, and so same logic, actually, that we did with green here works here. Bronteman points out. And that's because, again, if this is a 2... Actually, wait, why can't this be a 2 and go like that? See, this can't be a 9 because then row 1 breaks. Yeah, that does not look healthy. Yeah, okay, so this can't actually be a 9. I don't think it can actually be 8 either, which is, I think, an easier observation. I don't think there's any way of drawing an 8 business going on through here. Usually when I suspect something is very low and I just mark all the high options, I don't think too much about whether I can shave those options off until later if I think it might be useful. I worry about the options, and I think this is going to be a 1, but who knows? It could end up being a 6. I did not think it was very likely it was going to end up being a 9. But yeah, it's good to shave that off. Let's see. Okay. Could this be an 8 now? If this is an 8, it has to look exactly like this. Yeah, makes that a 2. Makes this whatever its little heart desires. So one of these, so this is weird. One of these 2 by 2 squares is in. Is there any commonality I can identify between the world where it's the left square versus the right square? It seems like that's awfully restrictive, but I don't think there's anything that's sort of like forced by both of these. But probably there is. And you are all smart. You are all smart and will tell me what they are. If I start with an 8, all options for row 1, column 8 have to take the cell below it. Yeah, because if this is a 2... Okay, let's think about this. So if this is a 2, it absolutely cannot take that cell. Because then it breaks this, which now has to be a 4. If this is a 3, then it has to go down. If this is a 4, then it could either go down or be a square, but either way it goes down. If this is a 5, it has to go down. If this is a 6, it has to go down. And if this is an 8, it has to go down. Yep, so I agree. In all universes, this takes the cell below it. Okay, so people really want to rule out 8 from this. Again, I really don't think it's an 8, but let's look at this. Okay, so if this is an 8, it's going to force this cell to be a 1, and that to be a 3. Go 8, 3, 6. So this would have to look like this. This would be a 2, of course. This could be a 4. I feel like what I just outlined worked. So if this is an 8, okay, I'll go through this once more, and you can tell me if I say the same thing twice. If this is an 8, this has to be a 3 now, and so this is a 6. Now this has to be a 2. And now this can't be 2 or 3, but it could be 4. And so it could just go down like that. row 3, column 5. Ah, okay. Sorry, I was not thinking about this, because now once this is a 2, got it. That's right, okay. Once this is a 2, this now has to be a 4, and it can't be. Got it, okay. So I agree, this can't be an 8. Yeah, it's this 2-4 pair I was not appreciating. Does this circle always take this cell? Oh, okay, so let's look at, people are saying, yeah, what about 6? If this is a 6, then it looks like this, which again makes this a 3, which makes this a 6. And for exactly the same reason makes this a 2 and that a 4, and that doesn't work. So that's not a 6 either. So same exact problem if that's a 6. I mean, I presume the same thing happens if this is a 5, right? This is a 5. It has to look like that. This is a 3, so this is a 6. Ah, but now this gets to be a 4 there, so it's actually okay. Now, people are pointing out that they would like me to use the fact that we have a quadruple. We have a 2, 3, 4, 5 quadruple, so therefore this cell has to be a 6. I will oblige. So that is green. And that is our real digit dance. Ta-da! Okay. So that's good. So that means that's a 2 and that's a 4. So this now does that, takes those 2 and finishes. This now needs to grab a color and then take those and finish. Let's see. I now have a 2 in this column, so I can put a circle around that circle. That's not really what I wanted to do. I will be honest. So now this is a 4 or a 5, so purple keeps going out quite a ways. At least as far as this. Of course, these are a 7, 8, 9 triple. Oh yeah, this is a very cool construction. Row 4, column 9 is limitless. I think limited was probably the intended. I think that was a typo. I think this is only 1, 2, 3, 4, or 6. Capping out there. Oh, this can't be 6, because if this is 6, then it actually makes both of those 2. So that can't happen. Actually, this can't be 4 either, because if this is 4, there's 2 options, one of which is this, which creates the double 2 problem, and the other of which creates a more subtle problem, which is that this cell now has no value, because I need to put this in a region, which then breaks. So that's not a 4 either. I don't think it can be 3 either, because if this is a 3 now, this is a 2. Yeah. If this is a 3, that also breaks. A bunch of people in chat are sort of following along with me as I go through these numbers one by one. 3 also breaks, because 3 would have to look like this. It would make this a 2, which would force this to come down. But now I've chopped off this cell. It has no friends. So that's not a 3 anymore. What about 2? Any takers on 2? What if it's a 2? Verg is betting on can't be 2. Let's see if this is a 2. Well, that's a 3, so it goes like this. And so this goes like that. So this is a 2. That's a 3. Yep, and now... Yeah, now what's this going to be? Well, it's not going to be a 2 because that isolates this cell, and it's not going to be a 3 because there's already a 3 in the box, and it's not going to be bigger than that because it breaks. So yeah, so this is, in fact, disappointingly, a 1. Ones will get the shade of shame for this this puzzle because they are not very useful. Okay, so suggested to look at what happens if this is a 2 in general. If this is a 2, I need to put something here, and there's nothing nothing I can do that will take this cell, because this thing, which is the only thing that really wants to take this cell, can't. This cell is, in other words, only able to be taken by this. So that's a 3. And so that's blue. I think Jaleb suggested looking at it in that direction, and that was indeed very fruitful. So those are not 3. In fact, they're not 4 either. This is not a 1 or a 3. I can tell you that much as well. This is not a 6 because there's a 6 in the box, even though it doesn't seem like boxes should be relevant in this. It feels to me like you could make one where the rules are that you have no regions, but you can't repeat digits within rectangles. I think that would be a good rule set if you wanted to try to do the whole chaos construction business, which I'm not at all saying you have to do, but since some people were talking about if you wanted to make a chaos construction with this kind of rule set, I think that's what you would do. You would have no regions in the grid at all, so it would not, to the purists, it would not count as a Sudoku, but you would have the rectangles not able to repeat digits, and so the rectangles would act as like mini regions. Okay. Row 5, column 7. Circle is limited. Yeah, okay, so this... Is there something wrong? Oh, sorry, that's not 7. This is 7. Row 5, column 7. Got it, okay. Well, it's not a 1, because there's a 1 in the box. Could be a 2 or a 3. Actually, it looks to me like this can be lots of things. I don't think I'm quite ready to pencil mark everything that this can be, because it can, like, stretch out across like that as far as I can see at the moment. Row 5, column 1. Yeah, can and maybe does do that kind of thing. Poor 6. Who takes row 3, column 7? Interesting. Okay. Once this stopped being able to be 6, which actually happened because of this 6, this became prime, or 1, which is prime-ish, but only in spirit. It stopped being able to take this cell. So this circle, and that is beautiful setting, by the way. I love that kind of thing. So this can't take that. So this cell now can only be taken by this circle or this circle. Or I guess this circle. Could do something like it could back up into that. Maybe there's still a few options. This cell doesn't take it, though. If this cell is a 5, it does exactly that. Which I bet someone in chat can tell me is impossible. Because someone in chat will be able to visualize what happens if I fill in this as a 5-size rectangle. Yeah, these are fun puzzles. I think it would be cool. I think I will try making a version with no regions, with the rule that things can't repeat in rectangles until I tear my hair out. But that sounds like fun to me. Emphyrio just says 8, which I'm not sure if it's advice or sunglasses that are sideways or whatever. I was very amused. I was looking at a Qodec puzzle earlier where it described the circles as sunglasses. Hey, Adam and Caroline. Glad you get to hang out with Panthera, who has a name, which I should remember. What do they call you? Hopefully you were enjoying watching me coloring these things. Oh, row 3, column 7. No, okay, row 3, column 8. Ah, this cell. Okay, this cell. Oh, sorry. This is the cell we were actually meant to talk about. Aunt Amy. There we go. Hopefully you're having fun with Aunt Amy. Okay, so who gets you? So this circle never gets that one. Oh, it has to be this one, doesn't it? This is the only circle that can reach there, so all of these are friends. Okay, nice. Those can be friends. So this is at least 3. And I guess it can only be 3 or 6. That was a very good spot. That I then horribly, horribly mangled by picking completely the wrong cell. But whatever. We live and learn. So now, amusingly, if this is a 6, then it goes up like this. So there's 2 different universes where there ends up being a boundary exactly here. Because if this is a 5, it also takes those cells. But I don't think I quite yet know that these all go together, because I think it could be that that's a 2 and that's a 3. I think. I am again just keeping my eye out, expecting that this whole puzzle is going to be a giant setup for a punchline of a Y-wing again. Even though that did not actually happen, I was convinced of it the entirety of the last puzzle. And so now that has just continued, and now I am expecting again that there's going to be some Y-wing that I'm not seeing. Let's see. In all cases, I get a border between column 8 and column 9. Do I know that it's not that this is a 3 and that's a 2 and this does something like that? I don't think so. Yeah, so Carl is saying it's either true that yellow is 6 or red is 5. I would love to know that. How do I know that it's not the case that yellow is 3 and red is 2? Why does that break? Because then I would need... Then this cell now needs to be picked up by something that has to get picked up there. And so now I'd end up with something like this. But that doesn't look broken to me. Like, this would be a 4. This would be whatever. I mean, I think it's very likely that either this is a 5 or this is a 6. But I don't think it's immediately clear that it's not possible. Okay, so I think I believe this. Okay, so if this is a 5, there's a border here. If this is a 6, there's a border here. If this is a 2 and this is a 3, now this cell needs a home, and its home is going to have to be here, and then there's a border here. Okay, so that I 100% believe. Proof by 3 cases I will take. I believe the 3 cases, and I don't have to argue something. So there's always a border here, which means that this has to find a friend down below. And it will be green. Okay, so this goes like that. Okay. Oh yeah, Playmaker wants to say it as noting that there are X's here, which is a smart way of framing this, is that there's no way that this cell ends up detached from the cell above it and the cell below it. So these are all in one rectangle. I just don't know where that rectangle lives yet. Row 6, column 7's circle is limited. Let's see. If this is 3, what can I take out of it? It could be 4 looking like that. I don't see yet what is restricted here. How can row 8, column 5 be 5? Zagris's concern was Zagris, right? Now the chat went away. Oh no, it wasn't. Basti. Who knows? My brain is in places. If this is 5, then we create this sort of separation where now this cell has to be this cell now has to be huge. It has to be like it has to be an 8 or a 9. This can be 2, that's fine. And then this can take these in some quantity. The green can be 2, though. Right? I don't see why the green can't be 2. It's really interesting because if you looked at this grid and asked me how Qodec started setting this, my guess would have been, it started with these 5 diagonal circles and just asking, what happens if I put 5 diagonal circles in there? Because that's a very natural way to start setting a puzzle, is to just set up something you think might be restricted and then work through it and then find out it breaks and then put in another cool thing that you think might be restricted until it works. But unless we're way, way, way off the intended solve path, that definitely can't be how this puzzle started, because we haven't touched anywhere near this diagonal of circles. And so these can't have been the starting point that the rest of the puzzle came from. Now, I agree with Verg's statement. This cell is always bigger than this cell, because this cell's always taking at least this many cells. So now this has got to be at least 5, because it can't only take 4. Because if it took 4, that would make this a 5, which would then isolate the cell. So this is 5. It can't be 6. It can't be 7. So this is 5, 8, or 9. Now, I think it's possible that this is 5, this is 4, and this is 4, and this really does stop here. Yep, it's Shikaku Day here on Everybody Loves Zetamath. And welcome back, yes. is a really snug. I could probably look at what this could be. Let's see. I think this can be 2 or 3 or 4. Oh yeah, and this could be 5 if it takes all of these. So there is the universe where this goes vertically and takes all 5 of those. Yeah, Qodec. That's a familiar problem for lots of the puzzles I like to set. Usually what I do is I set it forwards and then figure out how things work. And then I decide I like most of this, but it doesn't quite resolve or whatever, and then rebuild it backwards from the solution I end up wanting to get it. So I sort of figure out like, okay, what does my intro logic look like, and how do I structure it in such a way that there is a solution for the end part. Like if you look at something like Keep Talking, that's how that works. So Playmaker asks where 7 goes in box 8. Is there any universe where this cell is a 7? No, this cell cannot possibly be a 7. So Playmaker has correctly spotted there's a 7 over there, so there's a 7 over here. Yeah, every once in a while it'll get super lucky and it just won't destroy the universe when you go backwards. Now, I really do like, for puzzles like this, setting without regions. If I can get away with it. Because if you set without regions, then it leads to less of stuff breaking. Of course, you need some rule. I mean, you don't need it, but I always use some rule about things can't repeat in the things you're drawing or whatever form it is. But then that gives you a little more give to make sure that you don't accidentally make a puzzle that doesn't have any solutions. Like, I think it's possible that Crop Yamanos is my best puzzle that I've made. And that is a puzzle that did exactly that. There is a 9x9 grid with no regions, and you have to break everything into ominoes that can't have repeated digits. How big can row 3, column 3 be? Let's see. It looks to me like it can get up to 6 at the biggest. It can't be 1 or 2. 3, 4. It can't be 5 either, I don't think. So yeah, so it's only 3, 4, or 6. So that is also a good point, that this is way more restricted than I had assumed it was. I can't do the same thing with the 8, can I? I cannot. My brain briefly was like, I haven't used yet that you can't repeat the circle digits on the lines. Maybe I can use that. And then I was like, oh, wait, this is not the last puzzle. I mean, it is true that you can't repeat the circle digits on the lines, but it is less helpful here, somehow. Okay. Does this being a 5 break? Is a question I am very reluctant to ask, but that I think I have to ask. Because if this is a 5, it now puts a wall here, which now means every cell has to get taken care of over here. So in particular, this could now only be a 2. Yeah, I don't like it. but I don't see it breaking. Hey, Javier, welcome. Uh, as Simon says, it's an incredibly unappetizing question to ask as these things go. Uh, yeah, and unfortunately, this being 2, 4, and 5 are all very plausible. This being 2 and 5 is plausible. This being 3 and 6 is plausible. Uh, too many things are plausible. Okay. I think I can probably break this being an 8, because if this is an 8, it looks like this exactly. Which means now this cell has to get grabbed by here. Which now means this now has to grab there, and that's broken. Okay, so I think this is true. I think if this is an 8, I think it breaks very quickly. Because if this is an 8, I have to ask what's getting this cell, and the answer is, it has to be this that's grabbing that cell. Oh no, that does work, because now this can be a 2, and that's a 5, that's a 3. No, never mind. That's fine. Sorry, I was thinking that I had put two of the cells that were tied together in separate places, but no. Never mind. Let's see. Sam asks what row 8, column 4 can be. It's a fair question to ask. It can be 2 or 4, or 6 or 8. Oops. Or could it be 5? I guess it could be 5. That is more things than I was hoping. Row 3, column 3 has to take row 4, column 3, saith Matt. Yes, it definitely does. That is a good observation. This can't be. This can't take only that cell. So this always takes the cell below it. We'll go ahead and make that red. And now this cell is now getting boxed in. So this cell is just by Sudoku. It's not a 1 or a 2. So it's got to be a 3 or a 4. It's in no universe a 5. And it can't be a 6 because there's a 6 looking at it. And that's all the cells it could possibly ever hope to take. So this can only be a 3 or a 4. Yeah, there's a lot of times people see things very similar times. It even happens to me a lot that I see something and I'm happy about it, and I look in chat and see that at exactly the same moment, a whole bunch of people have seen it as well. I think this cell belongs either to that region or that region, but I don't think I know which. Now, I do think this cell always... No, never mind. Never mind. Is there a problem with this taking it, Basti? It's possible that I'm missing a reason why that's broken. I think it just makes the people in chat feel sad when they get sniped on the deduction that they were proud of to share. But I try and have lots of moments for helping chat feel smart by watching me do these things. It breaks the circle in box 5. Okay, so if this takes all of these, this would now be a square. And this would now be a nothing. Okay, great. So this circle... You're welcome, Verg. Hope to see you around again soon. So this is the cell we have to ask about. Where does it go? And so there's only two places it can go a priori. It can go there or there. This one is the most damning. So we'll look at that. If this cell takes that, then now this is a 2x2 square. Because it has to take 4. All that's fine until you ask about this cell, which now needs to take at least 3 digits, and it can't. So that means this cell and this cell are buddies. Good spot, Basti, by the way. That was not easy to see. Yeah, okay. So Jay has a different way to see it, which is, hey, what happens if neither of these cells takes a cell from column 4? Well, then they can only possibly take these 6 cells, but that's a problem because their sum has to be bigger than 6. So that is a great way to see it. I like that way of seeing it a lot. I feel you could probably build a whole puzzle around that kind of deduction if you wanted. Okay, so this being an 8 is, again, very restrictive. But again, I don't think helpful. Okay, so Playmaker asks what cell takes this. And now, amusingly, it can't be this cell, or it can't be this circle anymore. So it's got to be this circle or this circle. But I don't think I know which one. Can row 8, column 5 ever take... Sorry, row 8, column 4. Can it ever take a cell in box 5? Well, I agree at the very least this is now down to not being able to be 6 or 8. Oh, no, sorry, it can be because it can go over there. But can this possibly go up and take one of these cells? So that's the question that Bronteman is asking. I don't immediately see a problem with that. Like if it takes both of these and that's a 3 and that's a 4, that doesn't work out. I can attest. Wait, no, that works. That's fine. Yeah, this would be a 3. This would be a 4. We'll take that. Those. I think it's okay. I suspect you don't think it's okay. So if you have a reason why it's not okay, I am excited to hear it. Oh, did you just try making this an 8 and then it worked, so you found the solution? I mean, it's very possible that this is actually an 8. Uh, I'm trying to see what that would do to this cell. But I don't think I can figure it out yet. Uh, I wish I could put a poll in chat as to whether people think it would be cool or sad if this works out to be a 9. Oh, sorry, row 7, column 3. That one. Okay, that one. That one being a 9 would be cute. I would be a little sad if this one works out to be a 9. Oh, I mean, sometimes in these puzzles, it just works out that in order to make them work, that the region ends up being just a line, and it's a little sad. I was very disappointed in Keep Talking. It ends up being that one of the regions is just a row, and I was very sad about that. In the original version, it wasn't, but then I removed a negative constraint and had to move stuff around, and that was the only way it worked. And it's just like, fine. Let's see. Where am I supposed to be looking? I'm trying to decide if there's Sudoku that could be helpful. But I know so few digits, it seems really hard to see much in terms of Sudoku. What circle can take row 5, column 6? Yeah, I think we said there's 2 of them, right? Okay. So there's 2 universes for this cell. Playmaker is pointing out. So there are 3 universes for this cell. Because this cell could get taken by this, in which case it would look like that. It could get taken by this, in which case it would look like that or that. And it could get taken by this, in which case it looks like this. But in all 4 of the cases, this cell... No, it's not true. They don't all end up tied with row 6, column 6, because it could do that. Oh, no, sorry. It can't be this, because this is a 3. Sorry. Nope. Don't listen to me. This is not 4 because there's a 5th one there, and that's not a rectangle. It's a pentomino. So, Clemen, if you're new to this kind of puzzle, there are lots of places where you can find them. So if you look up at the top of the screen, there's a link to Logic Masters Germany. Oh, maybe there's not. Sorry. There might be a link to something else. Let's see. But if you Google Logic Masters Germany, you will find a site that is not the easiest to use, but there's an English version of it that where people post their favorite puzzles and they're rated and all that kind of thing. So you can find basically endless puzzles of this sort. If you're on Discord, the YouTube channel Cracking the Cryptic has a Discord. And that Discord has people posting tons and tons and tons of puzzles. So if you're on Discord, probably the lowest effort way to access tons of Sudoku puzzles is to just join the Cracking the Cryptic Discord. So back to my ineptitude. I said this could take this. That's blatantly untrue. This gets either taken by this in this kind of pattern or this. And so the point is these 2 are always together. They are buddies. That was Playmaker's point. So that is presumably interesting for something. that I did not go far enough down to in Playmaker's comment to read. Which means this can't be 4 anymore. That's the point, because... Oh, and it can't be 3 anymore either, because it can't take this. Yeah, okay, that's got it. Yep. So, yeah, that means those are not part of the same Houdigi, because I can't make a rectangle that bends around the corner. And now this is a 2 regardless of the universe that we're in. And so this is not a 2, and so it extends down at least 2 more. Okay, that's going to be huge. Okay, thank you very much to Playmaker et al. For that. So this is definitely a 4 now. So that's a 3. That's an 8. So now that's a blue. That is a wretched 1. This 8 now is going to look like this. This is going to inherit a color. It can be purple. Is the more than 6,000 puzzles, are we talking about the Cracking the Cryptic Discord or Logic Masters Germany that has more than 10,000 puzzles? I realize there are constant posts about how many puzzles there are on Discord that I do not read, so I probably should know how many puzzles are on Discord. But anyway, 2, 3, 4, 5, 6, 7, 8, 9. LMD is over 10,000. Okay, that sounds believable. The fact that LMD has really clear ratings of the puzzles from people who've solved them is super helpful. Now, there are issues with the ratings in a few dimensions. Particularly, the difficulty is unlikely to be super helpful until you're a little bit more experienced. But it at least can be a guide a bit. But the goodity of the puzzles, I find, is incredibly well documented on Logic Masters Germany. So if you only do puzzles that are rated 95 or above, you will still have tons and tons and tons of puzzles that you can do. And there are plenty of perfectly fine puzzles that are rated below that. But even if you just take the puzzles that have been done by 20 people and are rated at 90+%, you've already got tons and tons of puzzles to do that you know are excellent. Let's see. So we had a little bounce of stuff that I did not articulate super well because I was trying to converse about Logic Masters Germany at the same time. I mean, the ratings are great for stream because I really want to do good puzzles for stream, and so it's really helpful to have that. So yeah, was that the intended deduction codec? I'm curious. The one that Playmaker saw about these two always being together, because that was a really gorgeous piece of logic. But seems very, very difficult to have deliberately engineered. And welcome, Tall Cat. Okay, so now this is only 5 or 9, interestingly. I have another deduction, which is that this cell is not a 4. That feels like a very Fistomafellian sort of observation to make as part of a puzzle, since Fistomafel is apparently now an adjective. Oh, row 1 got done? Oh, yes. Wow. How did I not see that for so long? Okay. That was not great on my part. Anyway, we're just going to move right along past that and pretend that I didn't just ignore digits that I had laying around for forever. We're going to go ahead and blue this. We're going to re-blue this. Edge this. Get rid of a 3 there for so many reasons. Okay, so this cell now is besties with this cell, right? Yeah, these two cells now have to go together because there's no other circle. Oh, no, this circle could grab it if it went vertically. Never mind. Let's see. Row 7, column 8 is now resolved. Let's see. Well, it's not a 5. It can't be a 4. So it's a 2 or a 3. But probably it has to be the cell to take this cell because nothing else can. So this is going to be a 3. That's going to be red. Go ahead and do our continued little bit of edging. We'll go ahead and make that one gray. It's a bit tricky, Logan. So I would say there's plenty of puzzles that are among my favorites that are rated in like the high 80s, even maybe even the mid 80s. So what a high rating really says isn't necessarily that it's like the puzzle that will be your your favorite puzzle ever. But as you're getting started and delving in, and before you sort of have a good sense of what your tastes are, if a puzzle has a really high rating, that's a pretty good sign you're probably going to be one of the people who really likes it. But there are plenty of puzzles which are not to everyone's taste, but that get those sorts of things. I'll generally say for me, I sort of say I try and only post puzzles to LMD if I think they will be good enough to get like above 90. I don't always succeed, but that's my my rough standard. So I try and make them. I try and post only my best puzzles on LMD. Also, the meaning of the rating changes a lot as the difficulty of the puzzle changes. So, like, if I'm looking to do a 2-star killer puzzle, then basically anything that's rated passing is probably going to fulfill my desire to do a 2-star killer puzzle. If I'm going to do a, like, 4 or 5-star puzzle with some novel rule set or something that I have to wrap my head around and invest a lot of time in, then the bar is a lot higher. Okay, 3 is in one of these two cells. Over here, I am noticing. 3 in row 9, column 7. Okay, Matt has spotted a Sudoku. Okay, a wild Sudoku has appeared in row 9, column 7. Which is a 3. Excellent. Wait, no, there's already a 3 in box 9. Yes, I think Qodec is absolutely right. A 90% 2-star puzzle is basically a 99% 4-star puzzle. I think that's absolutely right. Oh, yes, there. Okay, sorry. Yeah, 3 over here. Yes, the wild 3 has appeared here. Which means that's not a 3, which means this is a 3. And that 3 is in a circle. So your wild Sudoku has been very helpful. Because now we have a 3 in a circle that we can speculate about the nature of. And one thing that we know about it is it cannot grow left. And it must grow down. So these are part of the same region. Let's see. Now, this cell... right. Nothing can now grab this 6 and 8 except this cell. So this is all part of this region. Doop. At least those. And now this cell can't be anything but yellow. And so now this stops here. In particular, this is not a 2 anymore. And so we have a 4-5 pair in the row. Did not see that coming. And so this is a 7 or a 9. Yes. Why is there a 4-5 pair? Who knows? let's see, fixes the row 9 circle. Okay, so does it? Can't I still do that and that and let that just grab those two? Now, I can certainly limit this circle. Actually, this circle has to be a 2. Because this circle is at most 3, but it's definitely not a 3 by that old Sudoku stuff. I would say in general, I think how much I like my puzzles is pretty closely aligned with the LMD rating most of the time. Although I will say that, like, a lot of the time it's a lot of the time where it's not, it's that LMD liked to puzzle a lot more than I think they should have. Like, I was not the biggest fan of antimatter, but it was such an interesting idea that I published it anyway. But I don't think in terms of, like, if the goal of a puzzle is to be fun, I don't think it was a super fun endeavor. Okay, so now people are asking about this cell. Yeah, this cell now is getting grabbed by this circle. So these are all buddies, which tells us what this is. It is, and it's going to get a color any second now once I pick. I spent most of my time on this puzzle, I feel like, picking colors. Okay, this can't be a 2 or a 5 anymore. Also, spoiler, it can't be 8. So this is a 6. Oops. Okay, so now this needs to be a 5, and this is a 4, and this is a 5. And we can finish our coloring. And we can finish drawing in our edges. Okay, is Afraid not here to tell me all the edges that I'm missing before I screw something up and miss an edge, and we're very sad? It's a very nice puzzle. So I will say, I think, bizarrely, if you're very new to Sudoku, a lot of the 4 and 5-star puzzles will be the easiest puzzles for you to start with. Because a lot of the time, the puzzles that are 4 or 5 stars are rated 4 or 5 stars because they involve logic that the people who study Sudoku for full time have not seen before. And so that means that it does not require logic that the people who've been studying Sudoku for a long time have seen before. And so, for example, one of my puzzles that's rated 3 stars on LMD involves a swordfish, which is just something that no one is ever going to see if they're new, even though 3 stars is sort of like, oh, hey, this is a new player-friendly puzzle. Ha, 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 ha. And so... whereas if you looked at something like Keep Talking or whatever, that's definitely a 5-star puzzle on LMD, but also I don't think you have any significant disadvantage in solving it over someone who's very experienced. And so my puzzles tend to be rated very highly, but they also tend to use very little technical stuff. And so one of the most common comments I get on my puzzles and like YouTube videos on Cracking the Cryptic or whatever is like, oh, this is the first hour-long Simon video puzzle I've been able to solve or whatever. And I think it's because usually the logic involved is something unfamiliar. So that's a really weird skew that you have to sort of think about when you think about the difficulties on LMD. Okay. All right, so what's left here? We still need a 2, a 4, a 7, and a 9. Okay, well, that one's not a 2 or a 4. These aren't 7. Let's see. I am being told about the existence of a 6 in box 7. Ah, yes, there is a 6 in box 7, and it is there in the cell I have just labeled 3. Let's see. I'm also like thinking about this comment about if people won't solve it. Yeah, I think there are many solvers who will view the goal of solving the puzzle as just to solve the puzzle, and if they do that, they will presume they have done it quote unquote correctly. And I think that there is a setter personality, solver personality mesh that has to happen where the solver understands if they're doing something that's horribly unfun, that probably isn't what the setter intended, hopefully. There's not a 2 there, by the way. There, the 2 was there. But any puzzle anyone can solve by taking a long enough chain to get to the answer. Because you just guess enough, and you will figure out what it is. Oops, why did I remove 4? It's 7 and 9 that are gone. That's a 5. That's a 4. And so I think a lot of the times when people end up sort of forcing their way through a puzzle and end up not liking it. And so I think this is exactly what happens where, like, if you look at classic Sudokus on Logic Masters Germany, classic Sudokus are almost uniformly rated in the C+ range. That is, like, in the high 70s, even though they're just gorgeous. A lot of the ones that are up there, because they're only... We're talking about people like Shye and Jovial who make, like, the best classic Sudokus that exist. And it's because, yeah, any classic Sudoku, if you just put in numbers, eventually you'll get there. And you probably will not have had that great of a time at the time when you're done solving it. And so I think there's a complicated, like, necessary communication as to, like, what the spirit of the puzzle is when you're doing it. And you'll see, actually, this happens a lot just in the 2 in box 7. Yeah, that did not end up being a 9. It was very sad. Oh, that 2. How about that 2? Yes. Yes. So that's a 2. That's a 7. But even just if you watch the stream, you'll see, like, my general tendency is not to look ahead hardly at all, and Chad is always sees things very far ahead. There's certainly a lot of stylistic disagreements about that between chat and solvers and setters and whatever. These aren't 6 because there's a 6 down there. I'm being told there's a 4 in box 4 somewhere. There is. It's there. Let's see. I mean, I think chat is my set of precogs in a lot of ways. 3, 4, 5, 6, 7, 8, 9. That's too many digits. There's a 3 in the column already. That one's not a 5. Oh no, 2 4s. Oh well, time to scrap this one and start again, Qodec. All right, let's see. Can I place 4 in this box? I can place 4 in this box. It's here. Yeah, I mean, I totally understand why this given one is a little bit sad to have to give, but it has really not ruined the puzzle. I have really enjoyed this. Little wooden bingo balls. That sounds perfect. Oh, this is not a 9. It's not a 9. Also, there must be a digit in here that is not. Oh, it's not an 8 either. Okay, so this is a 1 or a 5. That's a 1 or a 5. So this row, oh, that 4, I saw someone saying something about a 4 and a 9 being resolved, and then I was like, where? I don't see it. It must have been that 4 and 9 that they were saying was resolved. 2, 3, 4, no, not 5, 6, 7, 8. These are 2, 7, and 8. That one's not a 2. These are 3, 4, 5, 6, 7, 8, 9. Let's see. 5, 8, 9 triple in box 1. Aha! Also known as a hidden 6, if you prefer. 6, 6, 6 looks over here somewhere. But yeah, by the way, I should re-emphasize that by nature of the fact that a lot of the people I know are experienced Sudoku people, I often end up talking a lot with experienced Sudoku people. But if you are a newer to Sudoku person and you have questions about anything I do, by all means, please ask. I am happy to go over things if people ask. 5 in box 1 points down. Ah, yes, 5. So that's a 1 and that's a 5. For example, someday I will know what pointing means. I secretly just think of pointing as meaning look at that digit, but I think it has a more profound meaning. But I always get confused by it. Let's see. What are these? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say this is 79. Okay. Hidden 1 in row 6. That's not a 1. That's not a 1. How do I know? Which of these do I know is not? Ah, there's a 1 in the box. How about that? Yes. Okay. The 1 over here in the box. That is the disadvantage of these, is the constant overlapping things make it really hard to ascertain where the boxes are. Okay, so this is not a 1 anymore. Okay, we've got a 7, 8, 9 triple in this row now. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. These are a 1, 2, and a 6. That one's not a 6. That one's not a 1. That one's not a 1. Or a 2. In fact, that one's a 6. That's a 2. That's a 1. So that was good stuff. Yeah, I think pointing is a lot like what I think of as locked candidate stuff, but I think there's a technical difference between them that I think Ranks once eloquently explained to me, and then I forgot because my memory is very leaky. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. But if there is any like Sudoku technique stuff that you want to learn and are uncertain about, I think Ranks and Philip Newman have a podcast, and Ranks has put up a lot of videos, which I think are some of the best explanations of some of the more complicated stuff. What's a hidden single? Asks Sam. A hidden single is a place where there's only one place a digit can go. So if you say there's a hidden 6 in row 4, for example, there is a hidden 6 in row 4, as just by random chance there happens to be, what you're saying is if you look at every cell in row 4 and ask, can this be a 6? No. Can this be a 6? No. Can this be a 6? No. And you just continue. Then at the end, after you've asked that question to all 9 suspects, only one of them could possibly be it, and so that one has to be it. But you can have a hidden single in a row, you can have a hidden single in a column, or in a box of the Sudoku, or a region of an irregular Sudoku, or whatever. So quite often you'll see that you could see a hidden digit in a couple different ways. So often you'll see something like a tuple will work in the same way. So I have a hidden 5 in box 6. do I now? Let's see. Well, that's not a 5. That's not a 5 either. Okay, yeah. And so you could see this as, there's a 7-9 pair. So these two digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are a 5-8 pair, and so that 7-9 pair has removed that. That 5 has done that, and so that places an 8 and a 5. Or you could have seen that the other way of, the only place 5 can go out of all of these places is that one. Okay, that's not an 8, so that's a 7-9 pair. Yeah, and so as Tallcat is saying in the chat, the distinction between a hidden single and a naked single is that if you're talking about a naked single, you're picking a cell and asking, hey, what can you be? So you're focusing on a cell and you're asking, hey, can you be a 1? Probably. Can you be a 2? Sure. Can you be a 3? No. What about a 4? Maybe. What about a 5? No. 6? No. 7? Sure. 8? No. What about a 9? Maybe. And so you look at the cell and you ask for every digit, can you be that digit? And if the answer is only 1, is only yes for one of them, that is, if instead of getting this horrible mess, we had only gotten 1 yes, then we'd know what that digit was, and that's a naked single. And so basically the way you should think about it is if you imagine that your brain is able to constantly update your candidates in every cell. So like this cell can be a 7, 8, or 9. Imagine your brain just constantly keeps an updated list of what all the candidates are in every cell. Then what happens is that whenever a cell only has 1 digit, it now becomes obvious that that digit is that, and that's what a naked single is. Okay. For example, this 2, 8, I would update when I place this 2, theoretically, and realize that it can't be a 2 anymore. And now this is a naked single because it can only be an 8 out of all the digits, and it has to be a digit. So it'll be an 8, that'll be a 2. At least for now, every cell has to have a digit in it. But just wait, the next era of Sudoku is coming. That one? Oh, which cell is a naked single? Row 3, column 8. Okay, row 3, column 8. Okay, let's look at this. So this would have been a much better choice, apparently. Okay, so we ask ourselves, can it be a 1? No. Can it be a 2? No. Can it be a 3? No. Can it be a 4? No. 5? No. 6? No. 7? No. 8? No. And so because it cannot be 1, 2, 3, 4, 5, 6, 7, 8, then it must be a 9, and that's a naked single. So right, that's a perfect example of a naked single. And so that being a 9 makes that a 7, that a 1, 1, 7. So I will say, I don't think that knowing the difference between these things and that kind of thing is super helpful in terms of solving. Oops, what did I do? But it is super helpful in terms of communicating what you see. If you can say, if you can concisely say hidden 6 in box 4, you can very rapidly sort of communicate without having to type a lot and without the person who's reading it having to see it what exactly is going on. So it ends up being helpful for communicating about puzzles more so than that it, I think, helps you solve better or anything like that. 3, 4, 5, 6, 7, 8. Okay, so these are a 2, 8, and we know the order. That's an 8, that's a 2, which means this must be a 6. That must be a 5. This must be a 3. Yes. Also, of course, they have to constantly make jokes about it on Cracking the Cryptic because they're British, and so they have to make innuendo jokes. It is just part of the deal. Just like, heaven forbid, they do a snake puzzle. Oops. Let's see. So that's an 8. That 9 that's a 7. That's a 9. That's a 5. Uh, that's 7, says that's a 9. That 9 says that's a 7, that's a 9. It's not a 5 or a 9, so it's a 7. That's a 5. That's a 1. And there we go. Only took 10,415 minutes, according to that. To be clear, I'm a huge fan of British humor, but yes, the innuendo is a common piece in a way that it is not in others necessarily. Yeah, not bad. Yeah, that was a very fun puzzle. I'm sorry that you had to take it down from LMD because of a stupid 1, but we'll they never solved the snake puzzle with a giant 69 in it. Alrighty, I'm going to take a very short break to get myself a beverage, and I will be right back. Reminder, special thanks to all of our patrons who support us. Thanks to all of you who subscribe. Subscribing makes a big difference. You can help grow the channel by by recommending other people subscribe as well. I encourage you to do that. You're welcome to become a patron as well at patreon.com/zetamath. I'll be right back. Alrighty, here we go. Next up, we have a Renbon Arrow puzzle by Playmaker. Which may or may not end up being a set puzzle, we'll see. But it looks like a cool puzzle, and it has Renbon in it, so we're going to do it. Maybe it'll end up like a herringbone or something. Anyway, rules for this puzzle. Purple lines are Renbon, so a length 2 Renbon just tells you these 2 digits are consecutive, so they could be like a 5 and a 6, for example. A length 3 Renbon tells you the 3 digits are consecutive, but they could be consecutive in a weird order. So, for example, it could be 3, 5, 4. Oh, Simon's puzzle by today is by one of our mods, so we are huge fans of that. In fact, actually, the mod who Simon's puzzle is by the mod who just talked, by Dictionary. Okay, so that's how Ren bonds work. In a lot of puzzles, they'll be longer, and it just means that you get a string of consecutive digits along them. But in this case, they are all length 2 or length 3. And then these things are arrows. And what they do is they sum the digits on the arrow, and they put it in the circle. So this 1, 2, 4 here adds to 7, so I'd put a 7 there. You get lots of information that, oh, hey, look, for example, I can't make this bigger than 9, so these digits have to be pretty small. Alrighty. So we're going to start by noticing what I said about digits being small with these. So what is the absolute minimum one of these yellow stripes could sum to? And that would be 1, 2, 3, 4, 5, which sums to 15, which is just a sum that you do a lot in these puzzles. So these digits sum to 15, which means that the sum of these two cells is 15. It is effectively a double arrow, really. So these sum to at least 15. And so the most one of them can be is 9. So the least the other one can be is actually 6. So these are from 6, 7, 8, 9. And exactly the same deal happens over here. These are from 6, 7, 8, 9 as well. So that gets us at least a little bit of a start that we can pencil mark a couple places. Oh, by the way, I did not even notice these length 1 arrows tell us that these two cells are the same and these two cells are the same. This is just saying if you sum this one cell, this is what you get. Well, of course, if you sum this one cell, then you get that. So that is good. Okay, so the most I can get from these is 17. 8 plus 9 is 17. So if I think about it, what's the largest digit I could possibly have on one of these lines? Well, the largest digit I can possibly have on one of them is a 7. Because that would be one. Because if I took 1, 2, 3, 4, and 7, that would get me 17. So 8 and 9 in this column both live down here. So there's an 8 and a 9 in this string of cells. And in this column, there's an 8 and a 9 in this string of cells. Okay, which is going to be difficult to pencil mark, but we're going to try and make a go of it anyway. So one of these yellows is an 8 or a 9. One of these yellows is an 8 and one of them's a 9. One of these yellows is an 8 and one of them's a 9. Because I don't have anywhere else that I can put 8 and 9 in the column. Now, that has interesting impacts on these circles. Because if I put a 9 over here, for example, then I have to put an 8 next to it because 8 is the only consecutive digit, which would immediately knock 8 out of both of these circles. And they would be unable to be 8. Which has huge ramifications, because again, remember, these two things are on a pretty tight schedule as far as what they can actually sum to. Of course, I could put the 9 down here, and then put the 8 up here, and then everything is nominally back to being okay again. But I think I know one of these arrow circles has to be a 9 now. Good night, Daniel. I will try to enjoy the Aaron Bandero. I'm going to reset the clock, by the way, while I remember. And then I can just re-yellow these, because the only progress I have made is coloring some cells yellow, which I think I can manage to recreate. Technically, I'd also filled in 6, 7, 8, 9 to these. So I think I can prove one of these has to be a 9. Because what happens if neither of these is a 9? Let's just imagine the world. Well, remember, the total of these has to be at least 15. So the only way that works now is if this is a 7-8 pair. But remember, I have to put both an 8 and a 9 in yellow, which means one of those is going to end up here. If the 9 goes up here, then I have to put an 8 here, and we're broken. If the 8 goes up here... Oh, crap. No, this does work. This is okay, isn't it? Dagnammit. Because if this is an 8, or if I put an 8 up here, then I could get away with putting a 9 over here, and a 9 here, and that works. Darn you. Okay. I still think this is very relevant, though. Now, let's see. Is it possible that this arrow is not an 8 or a 9? So if this is not an 8 or a 9, then I have to put both 8 and 9 up here. So the 9 is going to go with an 8. And the 8 could go with a 7. Yeah, the 8 certainly couldn't go with a 9. So I'm imagining now the universe. What if there's an 8 and a 9 up here? Well, then I have to have an 8 here. And I could not have a... I could not put the 8 with a 9, so I'd have to put it with a 7. And so this would be exactly 6 and 9, which, again, seems just barely okay. So Tallcat wants to know where the arrow cells in column 4 go in column 3. Isn't that the whole story that we're currently talking about? I think this is the. I think that is. I think Tallcat is on a very similar spot as far as this. Oh, except column 3 is better. I see. Okay, I understand. So now column 3 actually has a really neat thing going on. So let's erase this yellow for a second. These 2 digits have to go somewhere in column 4. Well, this digit can't repeat on this arrow, and it can't be either of these 2 places either. No, I don't think this is... I don't know that this is different other than that, because there's still 3 places that I could put it. Because I could put this arrow's digit on that arrow, and I could put this arrow's digit on this arrow. I think both of those are fine. Can't go on the 2-cell arrow? Ah, right. Okay, beautiful. Okay, yeah, I had not appreciated that. So that is a beautifully elegant way to put this. If I try and put this digit on one of these 2 cells, which a priori I could do, because this could be a 6, and then that could be a 2 and a 6, and this could be an 8. Fine. Great. But that doesn't work for the following beautiful reason. If I try and put this digit on this arrow, then I have to think about, okay, this digit on this arrow, I'm going to pluck it off and replace it with these digits that have the same sum, but that tells you the minimum of that sum is 10. It does not work. Okay, so this digit does not go in any of these 5 places. It doesn't go in these 2 places. So this digit goes in one of these 2 places. This digit, so I can go ahead and do this in green and do the green-gray thing like that. And say, okay, one of these 2 cells is that cell. Now, unfortunately, I don't think I get a similar deal here. if I replace, if I make this a 6 and this a 9. Oh, wait, no, I can't do that, can I? I don't think I can. Okay, if I try and make this a 6, then I could make this a 9 arrow and put it on here with a 1 and a 2, except I can't make 6. So actually, incredibly bizarrely, I don't understand this at all, these two cells have to be these two cells. Yeah, so there's some smart explanation, because the explanation I gave is terrible, but if this is a 6, then the only way the 6 can go on this arrow is as a 1, 2, 6, but 1, 2, 6 breaks both of the ways of making 6, because 6 needs either 1, 5 or 2, 4. Yeah, I'm sure there's a smart Tolkat way of explaining that, but I do not have access to it at the moment. Okay, so now, what's this digit? Well, it's going to be orange for the time being. And so, well, what is this digit? Well, it's consecutive with blue or with green, but it can't be blue or green. Okay. And that's huge because it tells us that... Wait, does it tell us that blue and green aren't consecutive? Now I'm not sure. 1 second. I want it to tell us that blue and green aren't consecutive, but it might not tell us that blue and green aren't consecutive. Okay. So Tallcat points out, yeah, so now where does orange go in column 3? Well, because of these arrows, which are really just palindromes, they're really just reflecting this down here, orange has to go on one of these arrows. And the biggest digit I can put on an arrow up here... Oh boy, here's where I have to think about this, and it starts to break my brain. Because I was going to say the biggest it can be a 6, but no, the biggest I can put on here is 6, but I can put one up to 8 on there. And that's all fine. So this is not a 9. 1, 2, 3, 4, 7. Well, I was just saying I can't put a 7 here. But remember, that's right. The biggest digit I can put on... sorry. I argued already, the first thing I argued that I was talking about over here, that then we went over into this, was that I can't put an 8 on one of these arrows, because if I do, these two digits can't add to be big enough. So the old fry you can't fall fast enough tells me that this is a 1, 2, 3, 4, 5, 6, or 7. Okay. However, I can prune this down a lot because it has to be consecutive with blue or green. And so it can't be 1, 2, 3, or 4. It is 5, 6, or 7. So now I have to speculate what I can do with this. So, yeah, if blue-green is 6, 9, then this could be a 5 or whatever. I feel like we've made it awfully far to have made it nowhere, but I think we have successfully made it nowhere. But I'm not 100% sure. It all seemed very cool. I thought it was going to go somewhere. Let's see. Chester says 1, 2, 3 must be on the top arrows in column 3, as the 4 arrows must add to 28 at least. Oh, Chester's now throwing in these. I don't think I have to... I think I could even just say, these need to sum to at most 17, And so if I try to have 5 digits that sum to less than 17, but I don't use a 1, 2, and 3, then I can get to 1, 2 is 3, plus 4 is 7, plus 5 is 12, plus 6 is 18, and that's too big. So yeah, so I agree 1, 2, and 3 are definitely on these arrows. Likewise, 1, 2, and 3 are definitely on these arrows. I agree with that. Let's see. So I think, yeah, these are 1, 2, 3 are here. Let's see. This whole deal with the orange digit seemed very useful, like it was going somewhere I can't quite find yet. Tolkat is very good at spotting the logic of where does this giant cluster of digits go in this other place, which is like really sort of a hidden quintuple almost, I guess, going back to our earlier discussion about hidden and naked things. Yeah, all of these arrow digits. Yeah, so all of the arrow digits show up in these cells and orange. Let's see. Okay, do we absolutely have to look at the set argument? I suppose we absolutely have to look at the set argument. Okay, so Carl has a set idea, which is to take column 3 to be one set, and column 4 the other. Okay, and so, oh, I think this is simpler than I would not call this set, but I think we can do this. Okay, so I think I am capable of surviving this. Okay, so blue and yellow have the same sum because they are exactly the same digits. But if I remove all of those, blue and yellow still have the same sum because I removed the same thing from both sides of the equation. The same is true here. And these are literally the same 2 digits, so I can just chuck those. Okay. And so almost immediately, just by observing that, we're going to get that these 5 digits have the same sum as these 2 digits, which is, I think, the same thing we got to with Tolkat's argument before. But let's see, what is that now going to do for us? Oh, we can do the same thing over here. So let's see, let's do the same thing over here with green and purple. So, oops, like that. Okay, this side is not as useful yet. Let's look at this yet. This I know this is somewhere in there. So yellow sums to at least 15. So these sum to at least... Yeah, so I guess this does give us a little more oomph than the way we were looking at this before. Because here's the point. There are 5 of these cells, so they sum to at least 15. So these digits are automatically from 6, 7, 8, 9. And this one, we argued this couldn't be 8, so that can't be 9. Now, if we look at this cell, Yeah, I think this is a nice, colorful way of articulating what we were doing already, uh, which is good. I like colorful ways of articulating things. I've got stripes of color, which is cool. So now the question is, uh, how am I getting to 15? And so, can I get to 15 without a 9? And the clever answer is no. I can't get to 15 without a 9, because if I don't use a 9, then what do I have to do? I have to use a 7, 8. Uh, except this is broken, because I now need this to be... Oh no, this could be a 6. Dagnammit. The upper blue is not a 9, because this yellow digit is on one of these arrows, and the biggest one of the yellow digits can be uh, is 7. So because this can't be... And so because this is at most 7, this is at most 8. Oh, okay. So sorry. There's more cleverness. We have to chase this just a little bit further. So say I don't use a 9, then I can't use a 6. So now this has to be a 6, because it has to be adjacent to 7, 8, but it can't be 7 or 8, because this actually sees both 7, 8. So it's not a 7. So it would have to be a 6. But now my yellow doesn't sum to 15. Now my yellow sums to at least 16, because the absolute minimum I could make my yellow now is if this is 1, 2, 3, 4 plus 6 would be 16. Okay, so what that means is we do need a 9, and the 9 can't go here. Okay, so Tallcat got us that this wasn't a 9, and then Carl got us that this is the 9. And so that gets us a digit. So that's not a 9 either. Okay, and so now we go back to the start of the program, where we argued that there's definitely a 9 in purple. And so there's a 9 up here. And so there's an 8 in one of these, and so neither of these are 8. And we do get to excitedly dance about having the 9 here. Okay. Now, because this is 6 or 7... That's actually a very tiny digit. This has to be a 9 now, because if this were another 6 or 7, they would add to 13. So that's a 9. So that's not a 9 for the record. This is a 6 or a 7, so it needs the 1 and the 2 for sure. So there is neither a 1 nor a 2 on this arrow. So this arrow is either 3, 6... or 4 or 5. Those are the only options for this arrow at the moment. And so we're off to the races. So now the question is, is it possible that this isn't a 9? And I think we already answered this question in a roundabout way. Because in fact, I think basically if we just did all of this by just marking that these two cells were these two cells, which was what Tallcat had argued, we'd be in literally exactly the same place. We just have it marked in this other way. But anyway, if neither of these is a 9, the most they can be is 15. Oh, wait, sorry. Never mind. These two digits are these two digits. We know from Tallcat's previous argument. And so one of these has to be a 9. It's not that one, so it has to be that one. I did not argue that very articulately, but we'll go with it. Okay. So we've got 9s all over the place. So there's a 9 somewhere in this column. Okay. So 9 there and an 8 there. Okay. Okay. Where is 8 going in this column? And so the answer is, can I put an 8 here with a 7 over here? That would make this 9, 6 exactly. Now, the other one turned out not to be able to be 9, 6. Is there a reason this one can't be 9, 6? I will pretend to think about it while I wait for Tallcat to tell me. So I would like to believe that this can't be a 6 either, because then that would let me place an 8 here. Okay, well, while I wait for Tallcat to tell me, I will tell you that we know 1, 2, 3, and 4 are all amongst these, because this is either 3, 6, or 4, 5, and I definitely have a 1 and a 2 down here. And so then I either have a 3 or a 4. So I do know all of these digits are from 5, 6, 7, 8, 9. So I know all of these digits are from 4, 5, 6, 7, 8, 9, and they're not 9. Let's see. People are claiming these yellows have to be a 1, 2, 3, 4 quad. I don't think I know that until I know that this isn't a 5. Do I know that this isn't a 5? I don't think I know that this isn't a 5 yet. Because I could do 1, 2, 3, 5, 6, and 1, 2, 3, 5, 6 total 17. So I think the yellow sum equals the... okay, so that's a clever way to look at it. Yeah, so the yellow sum is the blue sum. So if I look at it, okay, that's really smart, actually. That's very clever setting. So this cell is one different from this cell. And so so that tells us that actually what needs to happen in order to make that work, if I think about it, on the one side, I have the sum of all of the yellows, and on the other side, I have 9 plus blue, plus whatever that blue is. I can unmake this blue. I don't know, maybe I'll leave it blue. Then I need to have the sum of these 4 yellows needs to be 1 away from this 9, because I've changed 1 digit by 1 on one side of the equation. I have to change 1 digit by 1 on the other side of the equation. And the only way that works is if that's 1, 2, 3, 4. Which is just bonkers, but true. So this is 1, 2, 3, 4, 5. I threw in the 6 for good measure, just to be safe. Better keep it just in case. So these are from 5, 6, 7, 8. Yeah, that is very clever. And now I have a 5, 6, 7, 8 quadruple in this box. So yes, that was the elegant way to get that row 9, column 3 is equal to 9. That is a good way to put it. So here we go. 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 9 is what these are. Of course, those are not 9. These are from 1, 2, 3, 4. Yeah, these are 5, 6, 7, 8 as well. So row 6, column 4 is not an 8. If this were an 8, this would be a 7. Doesn't that work? If this is an 8, that's 7, and that's the 8? Where does row 4, column 6 go in box 8? I think this is 8. I think it has to be. Let's see. I will wait to be convinced and think about other things. Yeah, the 9 in this box is actually pushed almost, but not quite, onto this renbon. Where does row 6, column 4, better than row 4, column 6, which is what I looked at last time. Where does row 6, column 4 go in box 8? Oh, interesting. Yeah, if this is an 8, then it has no place to go. So in fact, actually, my math over here was wrong. So yeah, this digit has to go over here. It has to be that digit. These digits are friends now. They're going to be red. So this can't be an 8. That is the point. Okay. So now, because these two arrows literally are these two things, right? That's what we know. I think that's what we know. I'm now forgetting what we know. But I think these two digits are literally these two digits, right? Hey, Niverio. So that means this is not an 8. Which means this is a 6 or a 7. Okay. All right, so I know my 1 and 2 are on here, so there's no 1 and a 2 on here either. Let's see. I know red goes up here somewhere. I know that these are from 3, 6, 4, 5 for the same reason that these are from 3, 6, 4, 5. Okay, these two. Okay, so I'm trying to figure this out again. Okay, so these are the same digit. Yeah, so let's just work through this. If red is 6, this is a 6. The sum up here is 15. And then this also has to be a 6. So if you just do the arithmetic, and I'm sure there's a linear equation that's being solved in the background here that should tell me this, but I am not at the point where I can do that in my head at the moment. But if red is 6, this is 6. And so then I need... Wait. No, never mind. Don't listen to me. Hey, Nicholas. Nope, I lost it. Let's see. One of those is 9, so one of these is 8. Now, I do know... Can row 9, column 7 be? Yeah, that that is what I was going to look at. 3, 4, 5, 6, 7 is the answer for what this can be. Oh, but it can't be 3 because we know there's a 3 somewhere, and it can't be 4 because we know we actually argued already that 1, 2, 3, and 4 are in this whole region. Which gives us a 5, 6, 7 triple in the row. Seems relevant. So where is 8 in column 7? Okay. How did this... okay. I see it now. Wow, okay. The point is... Good night, Qodec. The point is this. When we figured out these are 1, 2, 3, 4, it removed the possibility that this was 8. And so if you think back to the very start of the puzzle, the first thing I did was note that we need to put 8 and 9 in this column somewhere, and that it's going to be really bad if we put them up here. And that deduction, without me noticing it, made it so that we now have to put 8 and 9 up here. And so what do we do when we put 8 and 9 up here? Well, we have to put 7 and 8 over here in order to make that work. And so this now is a 6. So that's a 6. So that's a 6, because this digit's also red, even though it's blue. In fact, we're just going to get rid of all the colors for the moment. We can recolor as needed. And so now we have this. So this is 5 or 7. That's 5 or 7. Oops. These are not 6. That's not 6. These are not 6, so they're not 3. So this is a 4, 5 pair. And so this is a 6 arrow, which is 1, 2, 3. Oops. So those are a 7, 8 pair. So that's a 5. What could the coloring give me now? I can't imagine how the coloring could be useful at this point. So this is a 3, 4. These aren't 3 and 4. They're a 1, 2, 9 triple, so this is not 1 or 2. These are not 7. Yes, this is a 1, 2, 3. These are a 4, 5. And these are not 5. Oops. I can get rid of the corner marks. Those are a 6, 8, 9. Okay, so these are never 4. Let's see. And they're never 6. There's a 6 down there. So these are a 5, 7, 8 triple. So what is left in this column? 1 and 2. Oops. 1 and 2 is what's left in the column. Let's see. Okay, so... Okay, well, this can't be a 6 for sure, because I have lopped off the ability of this to be bigger than 4. Let's see. Okay, and now where does 8 go in row 9? It has to go over here, because I can't put 8 on this Renbon, because then I would need to put it with a 7, and that's not going to work. So that gives me this disambiguation. Comme ça. Which is very nice. Okay, now 8 is placed in this box. Because it, again, can't go on this Renbon. Now 6 is pushed up here. And so these are from 1, 2, 3, 4, 5. So they definitely have a 3 on them. So there's no 3 here. So that is a 3. But now that 1, 2 eats up the 1, 2 from this, which gives me a 3, 4, 5. I feel like that was probably very circuitous. But we'll do it. 6, 7, 8, 9. And go up there. So that's not a 9. Was this satisfying me a remark about the 6, 9 pair? Where's my mind in a weird place? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are from 3, 4, 5. Let's see. Let's keep chasing these. I can place 9 in box 8. I can place 9 in box 8. Good for me. Me in the royal sense. Let's see. So, I can place 5 as well, because this 5 looks over here and sees that that's a 5. Let's see. Okay, so let me mark what these can be. These can be 2, 3, 4. Oops. 2, 3, 4, 5, 6. Okay, this one I know is not a 6 and it's not a 3. So it's a 2, a 4, or a 5. Okay, this is not a 5. It's not a 6. So there's definitely a 3 on this Renbon somewhere, because this Renbon is from actually, this Renbon is from 2, 3, 4, 5. So it definitely has both a 3 and a 4, which definitely see this. So this is a 5, right? There's no way to use these digits without using 4 and 3. And so that's a 5. And so that is not a 5. And so this is a 2, 3, 4 triple. One of those is a 3. This is a 6, 7, 8, or 9, based on whether this is a 1, 2, 3, or 4, except it's not a 3, so this is not an 8. Hey, Riffcloud, no problem. Just happy to have you here. So yeah, this is a 6, 7, or 9. Based on that, yep. Okay. Why not 1 in row 8, column 1? Oh, why couldn't the Renbon be 1, 2, 3? Because I didn't mark that as being a possibility? But it could be. I had to go up. Gotcha. Okay, so I had to go up to 7. I had to go down to 1 and up to 7. Got it. Okay. This can't be 7, though. Can't be 5. Can't be 6. Good catch. Keeping me honest. Okay, this I know is 1, 2, 3, 4 as well. This... Okay, so can this be... this can't get up to 7 anymore because it can't have a 6 anywhere. That can't be 6. Can't be 3. Okay. So it is still true to say, though, that this can't be a 3, because this is still from 1, 2, 3, 4, 5. I just mis-Renband. Yeah, so if this is a 4, this is a 1, 2, 3. Okay, so this is 5, 6, 7, 8, 9. It's not an 8. Okay. I do know there's an 8 in one of these two cells. Could it be there? If this were an 8, it would put a 7 here, which looks okay. Uh, okay, so this Renbon, someone in chat pointed out, and then I got distracted rewinding because I missed a 1 over here. But someone in chat pointed out very wisely, this Renbon is super restricted because 4 and 5 are gone from the box. So it can't be 1, 2, 3 anymore. And so because it can't be 1, 2, 3, it's now got to be from 6, 7, 8, 9. So these digits are all huge. Let's see. The 3 on the box 7 Renbon excludes it from row 8, column 2. I agree, because this can't be a 3. So one of these two is a 3. That's not a 3. 9 in row 3, column 4. Looks across and sees that that's not a 9. And because that's not a 9, that's not an 8. So one of these is 8, but that doesn't help us, I don't think. Okay, so this digit still is restricted. It still can't be bigger than 5. It still can't be a 3. Let's see. If it was 1, it would make this a 5 or a 6, which is okay. So let's see. So yeah, so we need a 7 and an 8 up here, of course. Which is pulling 7 and 8 out of being options here. So it makes me think I'm supposed to look at where 7 and 8 are in this row. Okay, I want to think about this real quick because I need to remind myself that these go down. So this is a 6 and a 5. I don't know which of these it is, but it's a 6 and a 5, an 8 and a 7, and a 9 and an 8. Let's see. Nick has a somewhat nuanced point over here that sounds good, which is that if this is a 3... oh! Yes, okay. I understand now what was being said about the logic being from before. This Renbon can never have a 5 on it. Because someone said your logic from before was still good. You just made a mistake. This is the mistake. Or sorry, this isn't the mistake. This was the logic that was still good. This can't be a 3-4-5 Renbon, because if it was a 3-4-5 Renbon, this 4-5 would be broken. So this is not a... So neither of these can be a 5. So these are from 1, 2, 3, 4. Okay, so that is a big plus. Okay, so let's do that first. And then let's look at this point of what happens if this is a 3. Well, if this is a 3, that's a 4. And then this has to be a 2. But 2, 3, 4 sounds good to me. Unless I'm missing something that's happening in one of the rows. Yeah, that was really bad, given that I literally found the deduction and then just rewound it and didn't look at it again. The column 6 pair. Oh. Yes, how about I just do that? There's a 3-4 in row 7. The 3-4 pair in row 7 give me that this is a 5. I think that is that was the desired thing for me to see out of that. This isn't a 5 anymore. It's a 6, 7, or a 9. So that's a 1, 2, or a 4. We have a quad. Oh, we do have a quad. Oh my god, that's awesome. Okay. Nothing makes me happier than a spontaneous quadruple. Okay. So here we go. One of these is 4, and because of the quad, and ergo this is not 4, because both of these cells see this cell. This is one of my favorite little Renbon tricks. Both of these cells see this, in that if either of these is a 4, this can't be a 4. So that's a 3. So that's a 4. That's a 3. So that's not a 3. Okay. Well, it turns out, by hook or by crook, you were right. This cell could not be a 3. There's definitely a 4 in one of those two cells. Okay, so these are from 1, 2, and 8 to finish the row. 5 in box 4? Indeed, 5 in box 4. If the person who is asking about what a hidden thing is, 5 can only go in this cell. It's ruled out of everywhere else in box 4. Okay, so we've got 1, 2, 3, 4, 5. So must have 6, 7, 9 left to place. That 5 looks over here and gives us that as being a 7. And so remember, these always go down. So that's an 8. So these are not 7. These are not 8. Now that 8 looks there and sees that that's a 5. I probably could have noticed that something like that was going to happen if I'd have been smart, but I didn't smart this time. Today is not a me smarting kind of stream. Let's see. So the 9 goes not in any of these places. Let's see. We've now placed a 5 in the box, so that's not a 5 anymore. Got a 1, 2, 3, 4 quadruple. So these are just a 6 and a 7 as a pair. I think so. 5 keeps looking right. So is the point that this can't be a 5? I'd have to put a 4 there. I don't see it yet. Yeah, 5 is in one of these two places. I can pencil mark it. It seems worthwhile to pencil mark. The other 5. Not that 5. I don't know which 5 people are talking about. In row 4, there we go. Okay. I have identified the rogue 5. The rogue 5 has been taken care of. We won't talk about the fact that I then put a 5 in the row. Apparently, I really can't see this 5 because I then tried to fill in the same digit. All right. That is not a 4 anymore. The 5 is now here in this box. This box... Oh, this box is not quite done. Well, I guess I do know these are from 1, 2, 3, 4, 8 is what's left. And these aren't 1 or 2 because there's a 1, 2 pair already in the column. So these are from 3, 4, or 8. And that one's not a 4 because of that 4. Yeah, I suspect I could have gotten something over here much sooner if I'd have realized that the 8 over here was going to stop something from being an 8 over here. Like, I think probably I was supposed to notice a long time ago that I could figure out the order of this. I'm not sure. Playmaker may or may not confirm. So this is neither a 6 nor an 8. It is a 7 or a 9. Let's see. This being a 3 or a 4 means that's not a 1 anymore. So this definitely has a 3 on it now. So that's not a 3. let's see. There's an X-wing on 4s in columns 1 and 2. Yes, there is an X-wing on 4s in columns 1 and 2. Ah, yeah, okay, beautiful. So one of the 4s. So yeah, so there's an X-wing on 4s, which means we either get this pattern or this pattern. But notice there's a thing about those patterns. They both put a 4 on the Renbon. So because there's a 4 on the Renbon, there's no 1 on the Renbon. That's very nice. I enjoy that. So this is actually a 2-4 pair, which means that's not a 2. Sadly, I don't think it does anything else, but it was nice while it lasted. There is a 6, 7, 8, 9 quad, actually. So I know these are from these digits are from 1, 2, 3, 4, and they're not 4. And they're also not 2, owing to the 2-4 pair here. So this is a 1 or a 3. Is that the only place for a 3 in the column? That's the only place for a 3 in the column. Oh, yeah, the 6... Got it. Okay. The 6, 7, 8, 9 quad that I pointed out, I should have immediately said, yes, that means this is a 1. So that makes that a 3. So that was... I overcomplicated that by several factors. We'll get there. We'll get there in the end, maybe, possibly. You may not be having faith of that at the moment, but we'll see what happens. Also, I could have gotten rid of this 3 immediately when I saw that there was this quad, because I just didn't. Let's see. These are not 1s anymore. There's a 2-4 pair, making that an 8. So that 8 and that 8, place the 8 on this Renbon up here. That's not an 8. Say 7 or a 9, and this is a 6 or a 7. So it could go 9, 8, 7, or it could go 6, 8, 7. Annoyingly, I don't think I know which of those happens yet. There's a little bit in row 9 I can do. So that 1 bounces over there and says that's a 2, that's a 1, that's a 2, that's a 1. Thank you. Oh, there's a 6, 7, 9 triple. Oh, wait, no, that doesn't tell me anything. Never mind. Ignore the 6, 7, 9 triple comment. Row 9, column 5. We filled in row 9, column 5. Box 8. Yes, box 8 is resolved. A couple of you might have fallen a little bit behind, because I think I'm more than 60 seconds past having resolved all of this box. So you might be just slightly behind on the video. Granted, I only did it because people told me about it, so I'm not claiming I was ahead of you. I'm just claiming I think you might be just a smidge behind. So it tells us this arrow can't be 6. Are we trying to use uniqueness here? Because I think I agree by uniqueness. This can't be a 1 anymore, but I usually don't use that. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. These aren't 4. So these are from 1 to 7. Because the 6 in column 1... I got it. Okay, yes. There we go. Okay, yes. This 6 now is... the 6 in column 1, good point, is in one of these two cells. So this is not a 6, which does remove 1 from here. Oh, no. My claim about uniqueness was completely bogus anyway. Because, yes, this does end up being a 2-4, but it's going to get resolved by the arrow, is the point. 5 can't be on the Renbon in box 3 now. Okay, let's see. If this were a 5, I'd want to put a 4 here. I don't yet see the problem with that. 4 in box 5. is in one of two places. It looks like to me. Let's see. I've cleaned up this column, I think. Row 7, column 8, and row 8, column 8. Have to find a home in box 6. So one of them goes in the... Okay. I like this way of looking at this. So these two digits have to go in box 6, and they can't go any of these places. So these digits are 6, 8, or 9. Just flat out, there is no choice. This can't be a 9, of course. So this cell is a 6 or an 8. And so therefore this cell is a 5, which it can't be, a 7, which it can, or a 9, which it can't. So this cell's a 7. So that's not a 7. It is a 1 or a 2. It's not a 2 because there's a 2-4 pair in the row that's been there for we won't talk about how long. That's a 1 and a 7. Okay. Now, the 5 on the Renbon contradicts the arrow in box 2. If this is a 5, then it needs to put a 4 here. But I don't see... Let's see, 5 and 4. I don't see how that breaks this arrow. This 7 is fixing this, so that's good. 6 and a 7. And that 7 looks over here and sees that that's a 6, so that's a 7. That 7 looks down, makes this a 7, which makes that a 2, that a 4, that a 2, and that a 4. Now if I come and look up at what these two digits are, they are exactly a 1 and a... no. 7, 8... They're a 1-9 pair, and we know the order. That's a 2. Let's see. This digit now is a 4. So that's a 3, that's a 4. Let's fill in these digits. We need a 1, 2, 3. We've got a 4. Need a 5, 6, 7, 8, 9. Okay. So I certainly cannot put 5 on this Renbon. I can't put 5 in the column with a 5. So 5 goes here. This Renbon definitely has a 2 on it, so that's not a 2. There's a 1 or a 3. And it's not a 3 because there's a 3 in the column already, so that's a 1. That's a 2. That's a 3. That's a 2. 2, 3, 4. Okay, that's a... yes, this is a 4 because it's not a 2 or a 3. That's a 3. That's a 5. That's a 4. That's a 1. No 1 here. Let's see. Yeah, I hope I can do it from here. I'm not 100% confident, but I'm optimistic. We'll say that. I'm optimistic that I can do it from here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go in here. These are not 8. These are from 2, 6, 9. Let's see. You just said that before there's a horrible Y-wing I have to spot, didn't you? That was all buttering me up for the horrible Y-wing. Although I feel like I could find the Y-wing in this mess if I absolutely had to. Let's see. Column 6 gives us a 1 there, 3 there, 1 there. So these are not those. Okay, so these are 2, 4, 6, 8, 9. There's a 4 already in this column, so that's a 2, that's a 3, that's an 8, that's a 4. That 8 looks over and reveals that that's a 6, that's a 9, that's a 6. This is an 8. That 6 looks over and says that's a 9 and that's a 6. That's a 9. That's a 2. Not a fan of Y-wings, huh? We found a Y-wing in the wild earlier, which is apparently unnecessary. I so rarely find Y-wings in the wild, and I thought it was going to be an exciting, this was like carefully plotted so that all the Shikshaku all converge to get you this Y-wing, which then resolves everything. But then it turned out to be tertiary to the solve. I've always wanted to set up like a Y-wing or an XYZ wing with those like circles in a Amino puzzle, but I have never succeeded in doing it. All right, I'm going to take a real quick break, and then we'll be back with more Shikshaku. If I said that right. Well, we'll be back with it whether I said it right or not. Yeah, that was a fun puzzle. I enjoyed that. The chat had a bunch of different ways of thinking about the same opening logic, which I think made it more of a struggle for me because I was kept sort of bouncing between them and then getting confused about them. But the idea of this setup was really cool. And the way it sort of plays these two pairs of columns against each other. The setting on this was just excellent. All right, I'll be right back. Yeah, just a break. And we're back with another Shikaku. So if you've been here for some of today, you probably have overlapped with one of the Shikakus I've done. But I had a bunch of Shikaku-Sudokus laying in my bucket, and I pulled them all out for today. I think all of them. So this is a Shikaku-Sudoku. I got Santa's permission to do this. This was Qodec's Secret Santa gift. It may or may not be easier than the others, but the rules are different, as you may notice, by the fact that there are circles that have numbers in them and the numbers are given. So the way this one works is that all the circled clues are part of a rectangular killer cage. And so you might, for example, make this cage, if you were so inclined. And every words. Every wow. I'll get there. I can word, I swear. Every cell has to be part of a rectangle. Every rectangle has to have one circle. There we go. Yeah, screenshots for a solution guide are very helpful. I originally wrote solution guides without pictures, which I'm sure drove anyone who dared to look at them just absolutely mad. But then I started just throwing together screenshots, and then it was better. Okay. Now, one thing I notice is that Santa... By the way, Santa is Shye. I don't think I'm revealing anything I'm not supposed to. Santa was not kind enough to tell us what goes in this circle. But this circle is basically a write-in. If you are willing to type all of these digits into a calculator, which I am definitely not willing to do. But experience tells me that if I struggle enough, one of you will type all of these digits into a calculator and tell me what number this is. Okay. This 26 is interesting. Yeah, it's really weird to me as a choice of setting that Shye didn't give this digit. So it's a 7. I will just write that in. So, well, if it's a 7, then the only way it works is for it to take these and do that. And we will learn quickly if we were wrong, or very slowly, as the case may be. A 26 cage has to have at least 4 cells in it. Because I can't make 987 only sum to 24. So this 26 cage needs at least 4 cells, and there's only one way it can get at least 4 cells, which is that. Yeah, I guess it rewards you for doing the math. I think when Tristan and I did this, we did not get that this was supposed to sum to 7, and so I think we got off onto a very bad foot. Okay. Now, the 6 now has to live with the 28. And the minimum size of 28 clue can be is 4. So we can go ahead and blue these. By the way, we are postponing the dance until we get another digit, because chat kind of did this one for me. Now, a 6 cage in 4, a 26 cage in 4, I don't know exactly what's in it. A 28 cage in 4, do I know exactly what's in it? So it has to be 2 less than 6, 7, 8, 9. So it could be 4, 7, 8, 9, except this one obviously can't be that. Or it could be... No, there's no, wait. No, it could be 9865. 9865 would be 28. Okay. So if this is in 4, it is 9865 on the nose. Okay. So this 41 cage is suspicious because 41 has to be done either in 7 or 8 digits. Now, annoyingly, it could be done in 7 digits, exactly like that. Oh, no, it couldn't. Gorgeous. Okay, so 41 has to be done either in 7 digits or 8 digits. Well, it can't be done in 7, because although I can fit a size 7 rectangle here, the digits that are missing from a 41 cage would of necessity be 3 and 1, but we'd know there's a 6 missing. So this 41 cage needs to be size 8, which means that no matter what happens, it needs to grow up. In fact, it needs to grow up again because it needs to be 4 high at least. Well, sorry, it needs to be exactly 4 high. And then the only question is, does it take this side or this side, I want to say. Okay, this 8 has to be at least 2 cells, which is interesting because it sees a given 8. Yes. Good point. The 37 cage, okay, we might even be able to say more, but the 37 cage definitely has to go down because the 28 cage can't go down. And so if the 37 cage never went down, we'd be saying that the total of the first row was somewhere in the 60s, which is probably too many. Ask Simon. So the 37 cage definitely has to go down at least 1. Now, I can do 37 in as few as 6 cells, which is interesting. Okay, now, this cell must be part of the 40 now, which I see Kuraban has noted exactly as I have noted. That has to go with the 40. Now, the 40, there's no way the 40 doesn't embiggen in the leftward direction, because if it didn't, the 40 would be these 5 cells, and we would need to omit 4 digits that summed to 5. So these are also part of the 40 cage. And indeed, now we've hit a border. So now these are also part of the 40 cage. But now the 40 cage is never going to have size 7, so it's going to have size 8. So it's going to be exactly like that. And it's going to need to have every digit in it except for 1 and 4, except for 2 and 3. And I'm noticing a Sudoku thing. There's a 6 here. And that gets us a digit. Because purple needs to have a 6 in it, because it has either every digit except 1 and 4, or every digit except 2 and 3. And the only place in it that can be a 6 is that one. Because of the plethora of given digits that we have generously been given. So let's see, there are 6s in one of these 2 cells. Now let's see, can we chase the 6s around the grid more? I know one of these 2 is a 6. Oh, yes. Let's do counting with zeta again. Thank you, Tom. This is 1, 2, 3, 4, 5, 6, 7, 8 cells, which means there's 1 digit not included, and that digit is a 5. So my logic about the 6 is still correct. It just so happens that there's only 1 digit omitted, and that digit is a 5. So there's a 5 over here somewhere, which pushes the 5 down into one of these cells down here, like that. Okay. This cell can only go with a 23, I believe. Yeah, it's certainly not part of the 41, because that would break in all kinds of ways, so we'll go ahead and orange that. This 26 clue. I should have looked at this 26 clue much sooner, because this 26 clue is exactly the same as this other 26 clue, and it's in exactly the same place, so it's very cleanly telegraphed that I'm supposed to look at this 26 clue, and I just didn't. The 26 clue needs at least 4 digits, and 4 is the most digits it can possibly get. So ergo, it's going to look exactly like this. And just like happened at the top, that's going to force this 24 clue out. And notice that a 24 clue can be done in 3, but not if it contains a 6. And so we're going to have this size at least going on down here. Good. Okay. Why can't the 26 clues be 1 by 4? Oh, maybe it can. It could have up here, too, couldn't it? Oh, no. We have to start again, don't we? Because I think Josh is completely right. I think we did not do this right. Okay, we're going to restart. Okay, so this can go across like that, which I did not previously account for. And I don't know where I assumed that. But what I do know is that chat said this digit's a 1, and this is a cage. But yeah, this 26, I agree, it could do that instead of that. Okay. Now, let's try and recover some of what we did before. The 37... No, I don't know that 37... Yeah, so it's definitely true to say, okay, we can say at least this much. The 26 clues have to grow 1 cell in this direction. Because if they didn't, then they would only go this direction and then they would not work. Okay, so this is a hopefully much righter way to do this. And so now that's going to force that these go out at least this far. Okay. Yeah, the 41 clue still can't be in 7 because there are not 7 cells for it to take, so it has to be an 8, which has to be a 2 by 4. It can't be an 8 by 1. And I can't go 4 horizontally, so I have to go 4 vertically, which means the 41 clue does still have to do this. This 40 clue has to be in 7 or 8. It can't be in 7, so it has to be in 8. So it has to grow either 4 this way or 4 this way. But 4 this way is broken because of the 37. Because if I try and put 4 this way, then I'm going to block off the 37 from going down. In fact, I can just fill in. The 37 definitely goes down. So the 40 now has to actually take exactly this shape. That's the only shape that it can be, because it has to go 4 down and then finish like that. Okay. Can I still put in my 6? I'd be very sad if I couldn't still put in my 6. Yeah, the 40 cage needs a 6, and it still needs that 6 exactly in that cell. So that's something. I know this ends here. Okay, this 37 I can do more with. Because even if the 37 takes these cells, it's not enough. 4 is not nearly enough. So the 37 has to grow down at least 1. Great minds, Tom. Now the 37 has to either keep growing down a lot more, which is possible, or grow over and finish. Those are the options for the 37. Or I guess it could even grow down and have a size 8, couldn't it? Because it could just be missing an 8. Can the 18 clue take row 5, column 4? Can this take the 9? There is no way it could possibly take the 9. Because remember, these are killer cages. So unlike the previous ones, digits can't repeat. Yeah, there's a 5 over there. Oh, row 5, column 4. Being asked what clue can possibly take it. The 18 clue cannot. Yeah, I think actually the 38 clue is the only clue that can take it, right? Hopefully you agree that this is the only way that this is ever going to work. That's a good spot. It would have been a while before I saw that. Which tells us that there's a 7 down here, which tells us that there's a 7 exactly here, owing to the fact that 7 can't repeat in purple, which tells us that there's a 7 in one of these two cells. Okay, we're now being asked about where can this 7 find joy in its life. And now the particularly nasty thing about this 7 is it can't get gotten by this 38. Oh, it could be gotten by the 38, but only if I do exactly that. Because this 38, if it were 38 and 8, it would not have a 7 in it, and so it could not pick up the 7. There's no way I could do 27 and 8. Oh, yeah, so I think this 7, actually, we'll see if chat agrees, I think this 7 has to look exactly like that. Missing 1, 2, and 4. And now this 7 has to go somewhere, and now the 7 is trapped. It has to go in this 37, and the 37 is now blocked off. So now this orange is finished. Bloop, 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 bloop. Like that. Uh, 9 can't be in an 18 clue that's size 6. Because the minimum you could get would be 1, 2, 3, 4, and 9, which would be 19. If I had to do it that way. That's how the 9 got locked out of there. Okay, this 8 now has to go with the 24. It has no other places it can live because the 41 cannot be 12 cells. If you take 12 different digits between 1 and 9 and take their sum, it will be bigger than 41. So these can be really out of colors here. Gray. Okay, and so now our 26 cage is, as pointed out, forced to take these cells. Okay, so good thing that it was pointed out by someone in chat. I forget who. Sorry, but it was pointed out by chat that, yes, we incorrectly identified that the 26 had to become a square when it did not. Now, in fact, this has just become a 27 region. It just finished on its own while we weren't looking at it. This cell... Oh, no, sorry. This cell could go with either 24 cage. Now this 23 cage has to take all of these cells. It can't take any more. Because all of these cells can only be gotten by the 23 cage. And now if 23 tries to take more cells, it's now got to take 8, and it's full. Hey, Mr. Hippo. Welcome. We're having a Shikshaku sort of day. Okay, and so now the question, as Kuraban points out, is what cell's going to take this... What region is going to take this cell? Well, it's not going to be the gray, because then that would now have 8 cells, and again, 8 cells is going to sum to more than 24, so it's got to be the green. And now, these are gray. So we have made good progress on the Sudoku-zing part. Or sorry, on the Shikshaku-ing part. Let's see. Okay, so there's definitely a 3 over here. Let's just continue. Our 41 is missing a 3, so there's a 3 over there. Okay, so now this is 23 and 4, but it's got a 3 in it. So now I've got to do 20 in 3 cells. Which is, I guess, not super exciting. There's still lots of ways to do it. Let's see. Oh, the 41 is missing a 4, not a 3. I don't know math with zeta. Well, anyway. Same deal, just that. Okay, and yeah, this is missing a 7. 1, 2, 3, 4, 6, 8, huh? Is that the only way to do this? Now, I know there's no 1, 2, or 4 in here, so this is every digit except 1, 2, and 4. So this is 3, 5, 8, 9. I should go ahead and fill that in so I can keep track. That one's not a 9. In fact, I know the 5's up there, so these aren't 5. So yeah, one of these two is a 5. I know there's a 9 over here, because there's a 9 in orange already. The 9 in this box has to go down here, which rules 9 out of these cells. So I think we might be trying to Sudoku this down to size while we're thinking about this. Let's see. Josh says, I think column 6, 1, 2, 3 rows are 1, 3, 6. Unless there's other ways to sum to 10. How are we figuring out the sum here? There's lots of overlapping stuff going on with these killer cages. I'm not sure I follow the math that's going on up here. Let's see, the gray 24 clue. There's another 16 and 5. Okay, yes. So So this I agree. 16 and 5 is always 1, 2, 3, 4, 6. So those are the digits that go in these cells. So these are not 6 or 1 because there's a 1 and a 6 above them. That's not 1 or 6. So in fact, this is a 1-6 pair. Good catch, Medi. So yeah, so that's a 1-6 pair. There's a 2, 3, 4. Yep, we've got 1 and 6 in light gray. So I should go ahead and fill in 1 and 6 over here while I'm at it. Uh-oh. Oh, there we go. 1 and 6. Okay. So 1 and 6 show up in orange. 6 does not show up there. Over there. So that means these aren't 6. Continuing our winnowing down of these digits. Is it row 6 on 1, 2, 3, a 3, 9, 7. Sorry, row 6. A 3, 9, 7. Let's see, 6 goes in row 2, column 8. Six goes row 2, column 6. Sorry, I misread it. Yes, 6 is now, because of this 1-6 pair, 6 is now locked non-trivially out of this cell, so the 6 is there. One of these two is a 7. Let's see, is there any way I can possibly get away with putting a 9 in this? So if I put a 9 in here, that would make a 6 and a 9 would sum to 15. I cannot. That's too many. Okay, so the 9 in box 8 is in one of these two cells. Because if I put a 9 in green, it's way too big. So the 9 now is up in one of these two cells. Now note the 9 is definitely not in an 8 cage. So I can go ahead and note that. Let's see. Now, is it possible there is no 1 in a 6-cell 24 cage? It is not possible that there is no 1 in a 6-cell 24 cage, because a 6-cell 24 cage would sum to at least 27. So the 1 in this box is in one of these two cells. Let's see. People are talking about the sum of the yellow and purple boxes in 6 and 7. Boxes 6, 7. Boxes 6 and 7 are way apart from each other. Oh, I think we're probably talking about these. 4 and 7. Okay, got it. Yes, okay, beautiful. So the sum of the rectangle I have shaded, I actually know. It's 64. And this sums to 45, which means that these sum to 64 minus 45, which is 19. So these 3 digits sum to 19 and include a 7 and a 9. And so what that means beautifully is that they are exactly 379. Okay. Thank you, Abid, for that. That is a very good spot. I had not appreciated this this mathing, but that is a very good spot. So yeah, so that's a 379, which is going to be huge because it's going to make that a 5 and that a 6. This not a 3. These are not going to be 6 anymore. Oops, not going to be 6 anymore. It's not going to be 5 anymore. Let's see. And now orange, as Josh points out, needs a 3. And so it can't get the 3 from this box, so its 3 has to come from here. Agree. So now I know there's a 3 up here, just by Sudoku, because there's a 3 in one of these two cells. There's a 3 here, so one of these two cells is a 3. So in fact, this has become a 1-3 pair out of nowhere. This, by the way, is not a 3, because it's in a box with a 3. Okay, what is left in this row? We need a 1. We need a 2 and a 4. Yep, that's it. 1, 2, 4. Okay, so we can begin contemplating. I mean, maybe we've already begun contemplating what the nature of this 8 is. So if the 8 is in 3 cells, it has to look like this, and it would have to have a 1 exactly here, and then it would have to have a 2 and a 5, which seems possible. If the 8 is going to be in 2 cells, it's going to have to be 1, 7, 2, 6, or 3, 5, all of which are broken. It cannot be in 3 cells. So in fact, it has to be exactly that thing I just said. It has to be that, with the 1 going here and a 2, 5 here in some order. And again, the beauty of this is that this 1, 3, 6 that I knew over here broke every way of making 8 in 2 cells. And I knew the 8 was in more than 1 cell. So it had to be in 3 cells. This was the only 3 cells. It always has to have a 1 and be 1, 3, 4 or 1, 2, 5. Can't be 1, 3, 4 anymore, so it's 1, 2, 5. And so you get all of that. So now this cell becomes green, finishing off that story. These two of necessity become blue to finish the 26 cage. And these 3 cells are purple. Sure, why not? To finish off our rectangling. Okay. Gorgeous. This is not a 2 because there's a given 2 looking at it. Not the most profound deduction I've ever made, but I'll take it. Okay. I was about to remove the pencil marked 7 from this cell because there was a 7 in the cage, but then I realized there was a problem with that. I will leave it to you to discover for yourself what the problem was. This is a 2 or a 4, being opposite this. This 37 has every digit but 8. So let's go ahead and pencil mark that. So that does really weird things. The 8 in orange, orange does not have an 8. So there is an 8 in one of these cells. And I know that's gratuitous, but it says there's not an 8 in one of these, which says there is an 8 over in one of those cells, which I thought was going to do something. And now I'm wondering what on earth I was thinking it was going to do for me. I have no idea. It really sounded good, though. Oh, well, whatever. Okay. So there's a point to be made from Tom about purple plus yellow in box 7. Which is that the purple cells go in yellow and the yellow cell goes in purple. Where is 8 in box 2? can I put 8 in an 18 cage? A priori, it seems like I can. I don't see any reason why I can't. So got it. So the point is, I don't have any idea what these digits are. All I know is the yellow contains all of 3, 7, and 9 regardless. So these digits are exactly 3, 7, 4, 9. That is really cool. I did not see that, and I have not seen that before. But because of the way this is set up, again, the purple digits have to appear in this cage. So they have to appear over here. And so regardless of what this is, because this is a 3, 7, 9 triple, there are a 3, 7, and a 9 in here, and they must be joined by a 4. And hopefully that adds up to 23, because we don't have any choices. And so there we go. So we get our own lovely little build-your-own quad. So we can fill in these digits. They are a 1, a 2, a 5, and an 8. Well, this one's not a 1 or an 8. This one's not a 1. I admit I have to delete what this is because I've completely forgotten what this is. A 38. Okay, so this does have a 1 in it somewhere. This can't be a 1 because there's a 1 in the box. That's always the hardest part about these for me, is remembering that there's still boxes floating around. Got it. So that's a 1, is Tallcat's point. So let's see. 2, 5, 8. And these are supposed to be adding up to, got to delete it real quick, 26. Can I possibly use a 2 if I also use an 8? So if I use a 2 and an 8, then that now sums to 10. So I would need a 7 and a 9. So if I use a 2 here, I need exactly a 7 and a 9. Makes sense. Okay. 1 in column 1 is placed. I agree. We do have a 2-5 pair, which rules a 5 out of that cell and a 2 and a 5 out of this cell. So I probably should have noticed that, but I didn't. But that was very helpful. That looked over here, saw that was an 8. That's not an 8 anymore. Okay. So if this is an 8 and a 5, then that sums to 13. And so I'd need these two to sum to 13 as well. But they could be, well, they couldn't be 6, 7. They couldn't be 8, 5. But they could be 4, 9. So is what I'm learning that there's always a 9 in this cage? Yeah, because these either need to sum to 13 and be 4, 9, or they need to sum to 16 and be 7, 9. So there's always a 9 in one of these two cells, so that's not a 9. It's, again, a very minor deduction, but it's something. The blue box 1 still must have a 9. Yep, that's what we just decided. I mean, I realize you typed that before I decided it, but I figured it out as I was then looking to your comment. Let's see. The 3 is in one of those cells over there. That's not super... Yeah, so let's fill in the digits needed in orange. That's a good idea. So orange needs everything but an 8. It's got a 1, needs a 2, it's got a 3, it needs a 4, needs a 5. It's got a 6, it's got a 7, it doesn't need an 8, and it needs a 9. So the 9 is up there. So the 9's over here, which I guess I already kind of knew. Let's see. And these are not 2 or 5. So these digits are 4 or 9. Ah! No, that doesn't do it. Never mind. I was excited, but I was wrong. Don't listen to me. Let's see. What is left in this row. Sorry, let me skip a track for a second. Red, remember, is a 389 triple to finish. We just said there needs to be a 9 in orange. It looks at this cell, so that's not a 9. There's a 3-8 pair in red, so that's a 9. That was a good spot. So that is that. Okay, let's look at this row. It doesn't have that much left. We need a 3, a 4, and a 9. Okay, this can never be a 3. Because if it was a 3, I would have at most 3, 8, 5 is 16. And even plus 9 is smaller than this digit. Which I've already forgotten what it was. But anyway, so this is a 4 or a 9. And so this is either a 5 with a 4, 9 here, or this is a 2 with a 7, 9. So I think this digit, in fact, is always 4, 7, or 9, based on that. The row 2 pair. Yeah, the 2, 5. There's now a 4, 9 pair. Got it. Beautiful. That not being able to be a 3 placed a 3 over here. Good night, Alex. Thanks for coming by. Yeah, we've got lots of low digits pencil marked in this column, but I can't do anything with it yet. Okay, so here's a smart thing to do that Matthew has noted. I know what digits are in all of these cells, because this is a copy of every digit except 8, and this is a copy of every digit except 5. So in all of these cells, I need 2 of every digit except 8 and 5. So I can remove a box, which will take care of 1 of every digit, and I'll now need all the digits from 1 through 9 except 8 and 5. And so that means that I've got my 1, 3, I've got my 6, 7, and so this has got to be 2, 4, and 9. Oops. That's really smart, Matt. That is a very cool way to see that. So that gets me a 2, 4, 9 triple, and in fact gets me a 1, 2, 4, 9 quad in the box. So these are a 3, 5, 8 triple. That one's not a 3. And so we can fill in the rest of this row. Oh, actually, even before I do that, I'm going to notice the 3, 5, 8 tells me that this is not a 5 anymore. It's a 2. So that's a 5. As soon as this is a 5, it means that I need the remaining cells here to sum to 13. So they're a 4 and a 9. So this is just a 4, 9 pair. So this is now 1, 2, 3, 4. We need a 5. We don't need a 6 or a 7. And we need an 8. Now this row, we need 4, a 6. Yep, we need a 4 and a 6. Okay, but we know the order of those because of that 4, 9 pair. It looks down and says that that's a 6 and that's a 4. Okay. Okay, Kurapon says there's no 3 in this cage. Am I supposed... There's no way I can know from the fact that this is a 6 cell 27 cage that it doesn't have a 3 in it, is there? That seems difficult. I mean, maybe. I definitely don't know it. Okay. Medi points out that the 1 in column 2 can only go here now, which gives us the 6 and the 1 there. Okay, Kurban explains. So there are 3 digits missing from this cage, which sums to 27. So the 3 missing digits need to sum to 18. So one of the missing digits is a 9. We just happen to see that there is no 9 in it. One of the missing digits is a 6. And so the other must be a 3. Got it. Yep, I agree. So there's no 3 in here because the digits missing from this cage are exactly a 3, a 6, and a 9. And we can just work that out. So this is not a 3. And so that is a 3, which makes that an 8. Let's see. This column, we have a 1 and a 2. We need a 3. Oops. We don't need 2 3s, though. We've got a 4. We need a 5. We've got a 6. We need a 7 and an 8. And we've got a 9. Okay, I think this can be any of those. This one can't be the 5. Can't be the 8. Which gives me a 3-7 pair in the column, which says this is a 3 or a 7. So that's a 5 or an 8. Okay. Okay. Here's a good point that is being made by Nicholas. This row sums to 45. These sum to 24. So these sum to 21. So the question is, what are they if they sum to 21? Can they involve a 3, for example? They definitely can't involve a 3. They could involve a 4 if they come with an 8 and a 9. This is not a 9. Let's see. So let's see. Over here, we get a 2, a 4, and an 8. This is not a 2. Okay, so now we've got a quadruple. 2, 3, 4, 8 quadruple in this box. So we know what these 2 digits are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are a 5-7 pair. I think I got that these were a 5-7 pair in a way that did not involve set, but I agree with you that these are a 5-7 pair. So that's an 8. This is not an 8. Now I need these 2 to add to 21 minus 8, which is to say I need these 2 to add to 13. Oh, and this is not a 7 anymore. So this is a 4 or a 9 to add to 13. And that gives me a 4-9 pair. So that's a 2. Oops. Well, that's a 4. I will always take the path that does not involve using set. That is my my motto. That is not a 2 anymore. The 2 in gray has to go here. These are not 2. See, but just for your enjoyment, I don't ask the setters if the puzzle involves set before I do it on stream. So sometimes I end up doing set puzzles anyway, and you get to watch me squirm. 3, 4, 5, 6, 7, 8, 9. That 2 looks up and sees that 5 and that 2. Let's see. That 5 looks down and sees the 7 and the 5. The 7 is not here or here. Nor is the 5, because that's the 5. So this is a 4-8 pair. So these two are 3, 4, 5, 6, 7. These are a 7-9 pair. As of yet, unresolved, I think. But maybe if I look at this 18 clue. If this is a 9, then this is an 8, and then this is a 1. So this can't be a 9, because look at the row. If this is a 9, then that's a 4, so this is an 8. And that forces this to be a 1, which is a huge problem, because that's a 1. So this is not a 9, it's a 7. So that's the 9. Okay, so 7 means I need this to sum to 11. Which means this is either going to be a 4 with a 7, which it can't be, or it's going to be an 8 with a 3, which it better be able to be. So that's going to give us a 1 and a 3. Going to give us a 7 up here. Let's see, that 7 gives us a 3 down here. These are not 3. They're a 7-9 pair. Okay, that 4 is looked at by that 4, so that's a 9 and that's a 4. And a 4. Thank you. These are not 4 anymore. These two cells are a 1 and a 3, and I know the order. Now, I should know... yes, there's already a 4 in orange, so none of these are 4, which means that's a 9, that's a 4, that's a 9. These are not 9. They are a 2-5 pair. And I know the order. That's a 2, that's a 5. This down here, that's a 4. It's going to give us that's a 3 and that's a 4. That 3 is going to look across... give us that. So now there's a 7-9 pair in the column, so that's a 3. Let's see. I probably can figure out what this digit is. I believe it's a 2. I should probably turn error checker on because I probably did not. Oh, no, it is. It is 1. Okay, excellent. So I could probably figure out what this digit is, either by Sudoku or math. What do you think? Should we figure out what digit adds to 28? Or should we look at this box and figure out what digit is missing from it? Let's do the math one. So that is a 9 and a 7 is 16. 22, 24. Sounds like this needs to be a 4. Got it. Okay. Also, we had 8. Oh, we didn't have 8s pencil marked over here. But we now can pencil mark these cells. A 1 and an 8 are what these cells are. This cell is a 4 or a 4. So we'll go ahead and pencil mark in and assume that it's the 4 out of those options. Gives us a 1 and a 4. Neither of these is 4, which I guess makes sense because there's a 4 in the row. That 1 bounces up here. 8, 1, 5, 8. If there was nothing in the box, it would have probably made a much more boring movie. Let's see. That's a 5 and that's an 8. Not that it's really one of my favorite movies as it is, but I'm not a very good movie person. This 9 shares a box with this 7 as well as a column, so that's a 7. These two cells are, let's see, I need a 1, 2, 3, 4. I need a 5 and a 6. And then these are 7, 8, 9. That 9 gave me a 7 and a 9, by the way. That 6 is giving me a 5 and a 6. This row, 2, 3, 4, 5, 6, 7, 2 and 7 over here. The given 7 doing work, telling me that's a 2 and that's a 7. That 2 now goes up there and says that's a 9, that's a 2. 2, 3, 4. So that's a 5. 3, 4, 5, 6, 7, 8, 9. And there we go. Well, that was a gorgeous puzzle. I really enjoyed that one. There was some really neat stuff in there. Never mind the fact that I tried very hard to break it at the beginning. Never be afraid to just hit the reset button and start again, I suppose. What a great puzzle, Shye, and a great gift for our favorite murderous penguin. All right, I'm going to take a quick break, and we'll be back with another puzzle. Oops. Welcome back. So our next puzzle, I believe, is also a Secret Santa puzzle. I know who it was by. I'm pretty sure it's public information, but for whatever reason, the link I have says by question mark, question mark, question mark. So I'll go ahead and assume that they can say if they want to, or anyone else who knows can say, but we will try to do this puzzle, which somehow made its way to me. So in this puzzle, there are a couple mechanics. So first of all, there are killer cages, which work just like the previous puzzle. Except in this puzzle, they are actually given to us, so we do not have to draw our own killer cages. We just know the sum of these digits is 28, and the sum of these digits is 28. I assumed so. My notes didn't say anything about it, but then it said by question mark. So I was like, I'm pretty sure that whatever mysterious secret this is long gone, but I figured I would not say it just in case. All right, these are thermos, which means the digits must go up as I go up. So if this is a 5, this has to be at least a 6, and this could be an 8, and this could be a 9, and then this could be an 11, a 13, and an 81, for example. If I were Simon, I would say the digits must rise as Mercury rises, although I admit, despite the fact that I've heard him say that probably 50 times, I try and visualize how to connect the physical image of Mercury rising in a thermometer with the digits going up, and I can't. It doesn't work for me. But if that works for you, great. The digits go up like Mercury. Hey, Andrew, welcome. So that's thermos. And then we have Little German Whispers. And the Little German Whispers, they better be, the German Whispers are just regular German Whispers. And the way the German Whispers work is that the digits between them have to differ by at least 5. So if this is a 9, this could be a 2, this could be a 7, and then this could be a 12 or whatever. Okay. Oh, and there's a white dot somewhere. Ah, yes, here is a white dot. The white dot digits are consecutive. Not all white dots are given. I agree, Logan. Saying that the digits go up like the digits on a thermometer would be a very reasonable way to say it. I'm really not trying to make fun of Simon. It's just a particular way of saying it that he really latched onto, that just every time I hear it, my brain tries to like say, yes, those are words, but it doesn't like connect. Okay. So we also have a bonus rule, which is that on every individual line clue, the digits must sum to 28. So, for example, on this thermometer, the digits sum to 28. On these little candy canes, the digits must sum to 28. And I said, for example, but that's, I think, literally it. That's everything. Okay. So, this is a very 2080 sort of puzzle. I'm guessing this was for someone's 28th birthday, maybe, possibly. Maybe the mysterious masked setter in the chat could tell us. Your Santa. Okay, so this was a Secret Santa puzzle. I thought so, but then I suddenly, once I saw the 28s, was wondering if maybe perhaps it was a 28th birthday puzzle instead. Okay, so 28 happens to be 17 away from thingy. It happens to be 17 away from 45, which means I have to omit digits from this thermometer that total to 17. Which are going to have to be 8 and 9. And now what that means is that we get the most generous opening of any puzzle I have yet seen. We get these 7 instantaneous digits. But we'll wait to dance until we have something slightly more profound. But we do have this. Okay. So we've made some progress already. So I'm trying to decide if I should think about the German Whispers or not. Because it's possible that in order to get to 28, I would need some... Okay, so let's see. So let's say... Let's try and absolutely minimize... I don't know. I think I don't want to do the German Whispers math, I think is the moral of the story. 1, 2, 3, 4, 5. Okay. And okay. I'm not going to good lift these. I really want to good lift these, but I'm not quite going to. But these need to have 4 digits missing from them, and the 4 digits that are missing from them add to 17. Okay, now here's another good point. These digits add to 17, and these digits add to 17. And so there are 2 ways to make 17 in 5 digits. Those ways are 1, 2, 3, 4, 7, and 1, 2, 3, 5, 6. Which means that there is no 8 or 9 in these cells. And so there's definitely an 8 and a 9 in these. So these are not 7. Okay, and so I need to try and remember those options. I'm not going to succeed super well, though. Whatever this bulb is, it's over there by the usual trick. This tip is also over here. Oh, hey! I am now learning for the first time that there are, in fact, 28 cages down here. Who knew? In fact, actually, maybe I should look at this one. I didn't notice this one at all. So these need to sum to 17. So these need to sum to 13. I guess that's not super helpful. Okay, so these can be for 1, 2, 3, 4, 5, 6, 7. Now, these can't be 1. These can't be 2. These can't be 3. Now, this being a thermo means that this needs to go up. So this digit can't be a 7. In fact, the most it can be is 9, 8, 7, 6, 5. The most it can be is 5. So these are not 6 or 7. And so we know, as usual, there's an 8 and a 9 in here, which is not quite useful yet. Oh, let's see. Tall Cat says it can't be. Oh, that's right. There's a 28 rule about these thermos have to sum to 28. So if this were a 5, it would go 5, 6, 7, 8, 9. And I don't know what 5, 6, 7, 8, 9 sums to, but it's 35, and 35 is not the same as 28. So this certainly can't be a 5. Because, again, I have to leave off digits that sum to 17. And so if I start with a 5, I have left off digits that sum to 10. And 10 and 17 are different numbers. Okay, so can this bulb be 4? Well, then I could leave off 1, 2, and 3, and 9. If I leave off 1, 2, 3, and 9, I only get to 15. So these can't be 4 either. Which, in fact, gets us that these are a 1, 2 pair. So that gets us that these are a 4, 6, 7. And that seems pretty nice. Yeah, I do need to remember that these need to sum to 13. The tips are an 8, 9 pair. Okay, so if I try not to use 8, then I would have to not use 7 either, and then I could go 6, 5, 4, 3, and 6, 5, 4, 3 is only 18. So yeah, there's no way I can not use 8, 9 on the tips, because if I don't, then I also lose the 7, is the point. So I know these are from 1, 2, 3, 4, 5, 6. Okay. Now, I don't need both 8 and 9 in a 28 Cajun 5, but I do need 8 or 9 in a 28 Cajun 5, right? No, I don't even think that's true. That's nonsense. Don't listen to me. Yeah, Yeah, so I know there's n 8 or 9 over here, n to 1 or 2 over here. That's not super profound as these things go. I don't even know this can't be a 7. That is very dismaying. Let's see. I think the German whispers have opposite parity. So let's say that they did not have opposite parity. I'm imagining for a second the universe where these have the same parity. And so by parity, what we're talking about here is the high-lowity of these digits. So is the digit more than 5 or less than 5? And because the digits have to be more than 5 apart, or sorry, at least 5 apart, they have to alternate between greater than 5 and less than 5. And so you sort of bounce back and forth. Greater than 5, less than 5, greater than 5, less than 5, greater than 5, less than 5. And so that's often done by coloring these things. And so I was really just attempting to see if the tips of the short thermos are an 8, 9. What short thermos? My puzzle doesn't have short thermos. Unless you mean these that we already got were an 8, 9 pair. I may have missed that. Unfortunately, I'd really like to know whether these are candy caned the same or candy caned oppositely, but I do not see how I can tell that as of yet. I was hoping coloring would illuminate it. Okay, let's see. Nicholas says if both yellows in row 7 are low, they'd both be 4. I don't see why. Okay. Where does row 3, column 1 go in column 2? Okay, got it. Right. So I've been thinking this whole time about where this digit goes in this box, but the correct thing to ask about was where this digit goes in this box. Or in this column, maybe more precisely, because it cannot go in the box with this. It can't go on this thermo, and it's not 8 or 9. So this digit is an 8 or a 9. And these two digits are the same 8 or 9. And these two digits are the same 8 or 9 for the same reason. So these digits are not 8 or 9. Okay, so now Barbie asks where 2 can go in column 2 and column 8. So the 2's not here. Could the 2 possibly be here? So if I make this 1, 2, then the most I could make it would be 1, 2 plus 9, 8, 7, which happens to be 27. Wow. So the 2's form an X-wing, because if I try and put a 1, 2 pair at the start of this thermo, it can't sum to 28. It can only get to 27. So these are not 2's. And these are not 2's. That is quite some setting. That it works out that way. Okay, so there is a purple in here somewhere. the 8, 9... are in the 28 cage in box 8. Ah, yes. Okay, got it. Sorry, I was looking at these boxes and doing this, but Medi has a great spot. Now the 8 and the 9 have been pushed into this box, or sorry, into this cage. And my outies here, remember, sum to 13 once you take away these. And so now how am I making a sum of 13 without 8 or 9? Only is 6, 7. That was a good spot. So these are not 6, 7. And these are from 2, 3, 4, 5. Can't it be 2 or 3 in those 28 cages? Ah, okay, so 8 plus 9 plus 7 is 24. Got it. Okay. So 8 plus 9 plus 7 is 24, which means I can never put a 2 or a 3 in one of these cages, because if I put the absolute maximum in the other 3 cells, then they go 7, 8, 9. That's 24, plus 2 or 3, I'm not still getting to 28. So these are a 4, 5 pair. So these are now a 2, 3 pair. Which has given me a sort of weird X-wing on 2s. Let's see. So one of these is 7, 8, 9, and a 4, and one of them is 6, 8, 9, and a 5. So these are always from 6, 7, 8, 9, which means that indeed our candy cane striping is done. The candy canes are striped the same. Those are the highs, those are the lows. So yeah, so there's a 6 or a 7, and so the key point is this is the only lowish digit we get in a 28 cage. And so these are all 1, 2, 3. These are all 6, 7, 8, 9. These aren't 6 at the very least. Now let's see. That's only 3, 6, 7, 8, 9s in the column. I can go ahead and extend my coloring. I don't know if this is going to be useful, but I'm going to do it anyway. Yeah, like chat, I was trying to prove that the candy canes were going to have opposite striping, but they don't. They end up having the same striping. And it might be possible to prove just by thinking about arithmetic that that candy cane stripes have to be that the candy canes have to be striped high, low. I do not know. These are all orange. These are all blue. These are orange. These are blue. Okay. Let's see. Skip, by the way, welcome, Skip. Says row 5, column 3 can't be a 6. If this were a 6, it would make both of these 1. And that would be a total of 8. And so I would need the other 2 digits to sum to 20, which is definitely not going to happen. So, yes. So that's weird, but it's true. So, like, first order thinking is, I can't put a 6 in the middle of a German whisper line because it would put 2 1s around it. But then the second line of thinking is, but the 2 1s it would put around are in different rows, so it's okay. But then the third line of thinking, the omega brain level, is, but now I need to make these 2 digits sum to 20, which is not going to work. So this is not a 6. This is not a 6. Now, I want to look at this 28 cage because I'm noticing this 28 cage does not have many high digits in it. So here it has 1 high digit and 1 low digit. So let's maximize this. Let's say one of these is a 9 and one of them is a 3. That would be 12. And 7 would be 19. I guess I could then just get by with making these 4 and 5, couldn't I? Darn. I was hoping to prove that like there had to be a 9 in here or something like that. Row 4, column 2. And row 4, column 8 are a 7-8 pair. Oh, yeah, okay. So if I don't make these 7 and 8, then one of them is forced to be 5, because, again, this cell in the middle, just like this 7 did that work of sort of pushing these up, the 6 is doing the same thing. If I don't use both 7 and 8 here, one of these is a 5 or lower, and 5, 4, 3, 2 is only 14. Even plus 9, I'm getting nowhere close. So these are a 7-8 pair and are orange. Okay, what if can I go further? What if I try and make these, what if I try and make one of these, say, a 4? Can I make either of these a 4? Then I could go 4, 3, 2 would be 9, plus 9 plus 8 is 18, 26. Still not there yet. So these can't be, these can't be as low as 4. So these are a 6-7 pair. Which is really cool. So these cells are blue. Okay, what about this? So now if this is 9, 8, 7, that would be 24. Yeah, and then you can get away with 3, 1 is fine. Okay. 7, 8 in box 5. Yep, 7, 8 in box 5 are here. Good catch. Okay, 6, 7 are looking across here and ruling out 7 from there. Okay, so there is a 9 in one of these two cells, as I had sort of hoped. So 9 and 7 sum to 16. The other 3 digits sum to 12. Unfortunately, not the most helpful thing I've ever encountered. Okay, so if I try and maximize one of these, how far over do I get? I would get 8, 3 is 11, and 9 is 20, and 3 is 23, and 9 is 32. So I get over by... I only get over by 4. Can we remove 1 at least from those cells? Okay, so in total, these thermos need to total to 56. Let's see. So let me try and do this. So they need to total to 56. That's 17. Plus 15 is 32. Plus 13 is 45. Plus 3 is 48. So these two digits need to add to 8. They can't be 17. So these digits are either 26 or 35. But we've said already I can't put a 2 in either of these cells, because if I put a 2 there, it's too big. So they have to be 35. And so these cannot be 3. So they're a 1-2 pair. Use the pairs, use the 28 cage with a 7. I'm not sure I understand what I am being told to do. But I agree these are a 3-5 pair. I don't know if that will make people happy or sad. Let's see. 2, 3, 4, 5, 6, 9 pair. We miss you, worm. Okay. So that's all the oranges for Yellow-kitty. So there's only 1 blue left in each place. Sorry, there's 2 blues left between these. Okay, let's see. So now let's see. Column 1 and column 9 clear pencil mark options above forces. Let's see. Do I know that one of these two is a 9? Maybe that's the thing I'm being encouraged to think about. I don't think that I do. Okay, beautiful. Okay, so here's a way to see this. If this is a 9, then I put a 9 in these two cells and a 9 in these two cells, because whatever this digit is, it gets pushed into both of these places. But now that means both of these cells are 6. Okay, and the way to see that, the fancy way to see that, is that there's an X-wing in rows 3 and 6 on 9s. The only places in rows 3 and 6 that 9 can go are here and here, here and here. I kept looking for X-wings in the columns and not finding them, but there we go. Okay, so as a result, these are not 9, and so one of these is a 9, and ergo this is an 8. That's a 9. This is a very well set puzzle, to the surprise of no one who's done many of Niverio's puzzles, but it's a very well set puzzle. Okay, now I have 8s looking down in both of these directions, so I can't have any 8s over here. So now I have an X-wing on 8s in these cells, but I don't think it does anything. I remember there being a grkles thermo puzzle that had just a bajillion X-Wings in that pack he made for cracking the cryptic a while back. Thermos do like to set up for X-Wing stuff. Okay. So, can these really be 6s? So, if this was a 6, that would be a 1. That's 7. Then I could go up to 9. So, that'd be 16, 19, 27. No, these cannot be 6s. If I absolutely maximize everything, if this is a 6, I'm already broken. So these are not 6. For whatever that is worth. I keep trying to place the 3 in row 7 and thinking that I have found something, and then realizing that I probably can place the 3 in row 7, and it's probably not exciting to do so. So we know one of these cages has a 6, and that 6 now is forced to be in one of these 2 cells, so none of these cells are 6. We know one of these 2 cells is 6. One of these 2 cells is 6 for the row. One of these 2 cells is 6, so that gives us another X-Wing on 6s. So these and these aren't 6. Oh, now Abadallah has found a 7 X-Wing in columns 2 and 8. Yes. Okay, yeah. The 7... the 7 in this row is in one of those 2 places. The 7 in this row is in one of these 2 places. So ergo, there's no 7s to be found in those columns outside of this. Hello? There we go. Okay. My keypad was originally trying not to respond. But I got there eventually. Okay. So can I force these 28 cages anymore? That might be helpful. So one of these needs 3 digits that sum to 20. That's still a lot of degrees of freedom. Let's see, I should probably fill in what digits these are, because I just know what digits these are. These are 4, 5, 6, 7, 8, 9. I do not need the corner marks. Okay. Chris says these can't be a 7-8 pair. So let's maximize the sum of the 2 whispers together. Okay, so those 2 sum to 15, plus those 2 sum to 17. That's 32. 35. Oops. No! Dang you. Okay, well, we'll start again. I'm going to sum both of these 2 together. 15 32, 35. Okay, I still need to get to 28 times 2, which is 56. And I'm at 35 now. So I need the total of these to be at least 21. So the maximum these two can be is 5. So I need the total of these two to be at least 16, which means one of them has to be a 9. I agree. So these digits are not 9. So one of these two digits is 9. So these digits are not 9. Okay. So wait, why does one of them have to be a 7? Oh, we need a 3 on the line in box 5. Because if I don't put a 3 on the line... Okay, how many degrees of freedom do we lose? Yeah, okay, so now I need to count this again. Sorry. The absolute maximum I can make these sum to is 15, 20, 32, 35... 35 plus 17 is 35 plus 17 is 57. Yes, okay. So that means there is one total degree of freedom, because they sum to 57, they need to sum to 58. So I can't possibly put a 1 here. Sorry, they sum to 57, they need to sum to 56. If I put a 1 here... Wait. Does it break if I put a 1 here? Now I'm not convinced. Why can't I make this a 1, 3? And these an 8, 9? Oh, this can't be a 1, 2 pair? Oh! Okay, sorry. I was being slow. The point is, I need to put a 7 in one of these places. That's the only place 7 can go in row 7. So I actually have already eaten my degree of freedom. Sorry. This is the whole element I was missing. Chat saw this a while ago and has been trying to walk me through it, and I was following most of it. But the thing I missed was I know one of these is a 7. And so since I only have one degree of freedom, that's my degree of freedom. So these are 7, 9. These are now 2, 3. And so life goes on its merry way and finds a way or something. And so we get that. So these are a 1, 4 pair. Okay. And yes, this means these digits are a 1, 9. Just because that's what's left in the box. Okay, so these digits need to sum to 18. So these digits need to sum to 11. And the only way they're going to sum to 11 is as a 5, 6 pair. Which is going to be very helpful because it's going to remove 5 and 6 from all of these cells. And it's going to make these be a 1, 2, 3, 4, which is going to heavily limit what this can be. this cannot be a 1 anymore, owing to that no longer being able to be a 2. For whatever reason, that's not allowed to be a 2. Let's see. There's a quintuple in row 2. There is a quintuple in row 2. Look at that. That is slick setting. So these are where the 1, 2, 3, 4, and 5 go in the row. So this can't be a 1, 2, 3, 4, or 5. This is a 6 or a 7, making it the last high for its column, which makes this not a 6 or a 7. That is gorgeous. Let's see. This is now officially blue. That's officially blue. That's officially blue. That's officially blue. That's officially blue. Okay. We can blue a lot of things for Michael. Let's see. X-wings on 2s in rows 2 and 3. Yes. We've had that for a while, but then we ignored it. So these aren't 2. So ergo, that's not a 1 anymore. So now this has to be a 4. Sorry, there has to be a 4 on this Kropke dot, I should say more precisely. So none of those are 4s. Column 5 needs 1 more orange, and there's only 1 cell. I'm not sure which column you mean. Column 3. Okay, there we go. Can't be that one. Can't be that one. Can't be that one. Got it. Yep. Good spot, SPQ. This cell has to be orange, because I need 4 oranges in the column, and if you look, there's nowhere else it can go. So this is not 1, 3, 4, 5. It is a 6 or a 7. Okay, so these digits outside of here, they must include a 5, right? Okay. Oh, I guess I need the outies to sum to 17. So these could be 1, 2, 3, 4, if that's a 7. Interesting. Okay. Okay, now what were the options for this again? So I need to actually think about what the actual pairs of these are. So if this is a 9, that's a 7. The 9 presumably goes with a 1. Yeah, so if this is a 9, that's an 8. Maybe that's the better way to say it. If this is a 7, yeah, if this is a 9, that's an 8. So if this is a 7, that's a 9. So unfortunately, that does not really do anything for me, I think, right? Yeah. The row 2 orange. Oh, yeah. We still have our quintuple. We just didn't actually color it, but because our quintuple is on every non-orange digit, these 2 cells are orange automatically. So now that has happened. I'm trying very hard not to try and add these to figure out what 28 has to be. The 8 in row 7. Good point, Chris. The 8 in row 7 is in one of these 2 cells, and so neither of these cells is 8. Uh, row 8, there is a 6-8 pair because you cannot put 7 in both cages. Right. So we figured out carefully what these cages were before. And the moral of the story was one of them has a 4 with a 7, 8, 9. And one of them has a 5 with a 6, 7, 8. So there's only one 7 between these two cages, and we know it's in one of these two cells. So neither of these cages can be, or sorry, neither of those cells can be a 7. That is a very good spot. And so now which of these breaks? Maybe neither of them breaks. So 8, 9, 7. Okay, I think neither of them breaks yet. Oh, we are oh so close. What am I missing? Yeah, one of these two has to be a 7. Well, yeah, the Kropke cell has to break, but we already have this little. That's why I was so looking at this, because I thought it was going to turn out that this cell, which we got from the Kropke breaking the symmetry, I thought this was going to end up immediately being helpful. But I think it turns out that it does not end up being all that helpful immediately. I mean, I'm sure it's helpful somehow, because we have to be able to solve the puzzle. I just don't see how yet. See, Abed says row 1, column 2, and 8 are orange. Do I know these are orange? Let's see. The 28 cage in box 8, says Nicholas. I mean, this cage is basically done. Sudoku is going to force it. So I can hide an extra orange in one of these two cells in order to make that not orange. In fact, I have to hide a 6 in one of these, I suppose, is a different way to put it. So here's a point again. The same math that we did with the 28 cages down here happens up here. So all but 4 or 5 is in here, and there is a 4 or a 5 in each of these cages. row 1, column 3, and row 2, column 7. Not a dumb question at all, Ambrose. I was actually looking at those two and trying to decide if they were the same or not. I think we actually, if we think about it, we know these have to be different, I think. Because if these are the same, then that means both of these cages are the same. Maybe it's not a problem if these two cages are the same. If these are both 7, yeah, if these are both 7, that would be a problem, because that would mean I'd have to put a 5 in those cells twice. Let's see. Niverio has said, don't forget about the fact that all 28 cages need an 8 and a 9. Let's see. One of the 8s is here. One of the 8s is here. Where's the 9? Do I know where the 9 is? Oh, they can't both be 6 either because of the 6-8 pair in row 8. Ah, yes, beautiful. Okay, that is well hidden, well spotted, Ambrose. Okay, so because of this 6-8 pair, one of these two is a 6, so these cannot both be 6. So these are matter and antimatter. One of them is the good 6-7, and one of them is the bad 6-7. So let's see if we can do anything with that, because that seems more likely to be useful. Okay, so where is the good 6-7 in box 2? It has to be there. That's the only place it can go. Okay, so this cell is not an 8. It is the good 6-7. And so now where is the 8? The 8 is here. And so Ambrose's observation about this 6-8 pair is going to break the whole puzzle open. Because now that being an 8 tells us that that's a 7, that's a 6. That being an 8 tells us that that's a 9. That's an 8, because I still need to put an 8 over here. That being a 7 tells us that's an 8. That being a 6 tells us that's a 7. Yeah, that was a really clever way of hiding that. Just hidden enough. Okay, so that's a 6. That's a 9. That being a 9 makes that an 8, and that a 9. Being a 9 makes that a 7. Which makes that a 6, and that a 7, and that a 6. That being a 6 makes that an 8, and that a 6. Was that the intended way to resolve it, Niverio? Makes that a 9. Let's see. Someone wants me to add things on thermos. Let's see. That seems optimistic of them, but let's try it. Okay. These sum to 24. So ergo, I need these to sum to 4. So these have to be the 3 and the 1. These sum to 21. So hopefully this being 5 and 2 will make it work out. That's a 3. That's a 2. That's a 4. That's a 1. That's a 2. That's a 1. So let's see. So the sum on this whispers line is at 17. So I need these to sum to 11. So I need to maximize them. Hopefully this also works. It's 11, 19, 21, 28. Okay, good. Yes, very, very nice puzzle. Okay, so this is not a 1 or a 4. So let's see. Let's fill in the rest of this row. Okay, we need a 2, 3, 4, 5. These are not 4 or 3. They're a 2, 5 pair, so these are not 2, 5. They're 3, 4. It's resolved 4 and the 3. That 2 resolves. That's a 5 and that's a 2. This is not a 5 anymore. This is not a 1, a 3, or a 4. So this is a 5, 7 pair, but there's a 7 in the box already, so that's the 5. So these are not 5s. So there's a 1, 2, 3, 4 triple. Sorry, 1, 2, 3, 4 quadruple. So this is my last high digit. That's the 9. That's not a 9 anymore. Slash hasn't been for a long time. Take your pick. Let's see. So that 5 looks down, says that's a 7. So that's a 3. So now this is the last high digit. That's a 7. For the column, I meant. Let's see. So these are not 1 or 3. That's a 4, 5 pair. So that's a 6. This is not a 6 anymore. These aren't 3 anymore. I probably know what this digit is. Well, I at least know it's low. So it's 1, 2, or 4 in order to make the row balance out. Let's take a moment to tidy up our coloring before people get upset. I wouldn't want anyone to be upset. Okay. 3 is low, 7 is high, 6 is high, 3 is low, 2 is low, 2 is low, 3 and 4 are low. I am being encouraged to do arithmetic over here, I think. So probably that has to be a 4 in order to make that arithmetically work out. So that's a 5, that's a 4. 4 is blue. This dot needs a 4 on it. It can't go there anymore, so it goes there. So that is not a 4. It is a 3 or a 5. These are not 4 anymore. Let's see. These aren't 4 anymore. That's not 4 anymore. Let's see here. There we go. That's a 3 to finish the blues for the column, so that is a nasty 5 there. So these aren't 3 anymore. 1, 2, 4. Let's see. The box 9 cage, or just box 9 Sudoku in general, probably, to make that all work out so that it adds up to the right number. Let's see, that's a 1. These are double blue, so that is a 2. That's a 3. So 1, that's a 4. That's a 2, 3 pair, so that's a 1. 2, that's a 1. Yep, we've finished off box 9. These are not 4 anymore. That's not 4 either. So this is 4. And it's blue. This 3 looks up and says that's a 2, that's a 3. This 1 looks down and says that's a 9, that's a 1, which lets us do more coloring, which is the important thing. As long as you're coloring, you're succeeding. That is an important thing to remember in puzzle solving. That's 7, sees that that's a 6 and that's a 7. Oops. It's a 6 and that's a 7. That's 6, looks up and sees that's a 5 and that's a 6. Not that one, that one. You knew what I meant. Okay. We've got a 5-8 pair in the box now, so that's got to be the 9. That's got to be orange. We've got a 5 up there, so that's got to be 8, and that's 5. And that's orange. And we're done. Oh no, I left a 1 uncolored? Poor 1. It shouldn't have hit on the thermobulb when I was giving everyone out their colors. I have avenged the 1. You made plenty of good contributions there, Medi. Sorry, I have been this whole time saying Medhi because I have been transposing the letters in your name. Medi, I think, is better. Let me know if I am. Let me know if I can do even better. But I will go with Medi for now. That I have actually recognized what order the letters go in. I am going to just do one more quick puzzle to wrap up. I am going to do this Sam Cappleman-Lynes star battle. And then I am going to call it good. I am going to remember to change this to Penpa mode. Oh, it does this like weird phase transition between those. I had not realized it did that. Okay. So I think the nice thing about Star Battle is that I think I can use the tools and everything. Okay. So if you've never seen a Star Battle before, every Star Battle has a number of stars. And in this case, that number is 2. And this number is the number of stars you have to put in every row, column, and region. Now, note there are no numbers in these puzzles. One moment. Let me go ask Tristan to put a link in the chat. I think he's got it. 1 second. He got it before I got to it. So there are going to be no numbers in this grid. The only things that are ever going to be in this grid are stars, and that's it. I can put in X's just to mark that I know something's not a star. But the way the puzzle works is that every row, column, and region has exactly 2 stars in it. And the magic rule is that stars can't touch even diagonally. So if I put a star here, I immediately cannot put a star any of those places. Okay. So one observation is that in any 4x4 region, you can only put 1 star. And so I have to put a star in this 2x2. Sorry, when I said 4x4, I meant 2x2. And I have to put 1 here, which means I can never put a star here. Because if I put a star here, this little heptamino region can't ever finish. And I know one of these 3 is a star and one of these 3 is a star. Let's see. I would like to know more than that. Okay. So, oh, not quite. So if I count all the stars in this region, that's 2, plus this region, that's 3. I only get 1 more star for these 2 columns. But unfortunately, 1 is not 0. Let's see. It often is very helpful to sort of bunch regions together like that and try and count the total number of stars that you will see. But it is not quite helping as best I can see so far. I have so far gotten 1 pencil mark. Let's see. This is really... Okay, so here's another one. Okay, this region can only have 1 star in the... what do you call the thing that sticks up from a submarine? Whatever. It can only have 1 star up here. And so there's at least 1 star down here. And so... Well, that doesn't quite tell me anything. Periscope. There we go. The periscope. The periscope has at most 1 star. So there's at least 1 star down here, but that still doesn't quite get it for me. I do not believe I can color. Oh, maybe I can. Let's see. Paint. Oh, no. Let's see. I can maybe paint regions just to facilitate talking about this. Okay. So let's see. We can have. One moment. We can have a purple region. We can have an orange region. Oops. Okay, this could be a puzzle type unto itself. You just get one of these and you just color it in whatever way makes you feel good. I think that would be very popular. As a new puzzle genre. Let's see. It can be brown. Let's see. Now I've got to start repeating. Oh, I don't have a pink yet. Okay, so the periscope can be pink. Let's see. And we can do another yellow down here. And then this one can be gray. Okay. That was a good idea. Thank you. Let's go back to... okay. We're now back in this mode. And so now we have everything all... Okay. Well, I didn't say they would be easy. There would be some difficult ones. Let's see. Row 1, column 2 is not a star. Let's see why. Let's see. Row 3, column 3. Okay. I definitely agree with this. So Jay points out, if this was a star, now I suddenly can't put stars in... Now I suddenly can't put enough stars in blue. I spelled the X's all over the place. Sorry about that. So this is an X. Let's see. If I put a star here... Why can't I put 2 stars in blue? This is a little more complicated than I can do 8 hours into the stream. Because I could put a star here... And then I could still put a star down here, right? Like over here? Isn't that okay? I don't see that argument yet. I can relate. Doesn't that limit stars in brown? I mean, quite possibly, but not in a way that I'm able to articulate at the moment. But I am open to suggestions about how I should think about this. Brown doesn't quite have to have a star in column 1. Okay, so do red and yellow need a star in the sticky downy bit, is Ambrose's suggestion. So could I have no stars? So Ambrose is asking, could there be no star here? In which case, then I would need to get 4 stars in here. Which seems plausible. But I feel like almost certainly you're right that I'm supposed to do that. So what if I do something absolutely ridiculous, like count stars above this line? How many are there? So if I count stars above this line, there are 2 in orange, 2 in purple, that's 4, 2 in blue, that's 6, 2 in green, that's 8. And now there's at least 3 in here, that's 11. We're counting at this mark and above. So If there is no star down here, then that means we have all the stars spoken for up here. We have exactly 12, which is the number we should have. Otherwise, if there is a star down here, then there has to be a star exactly here. So a star somewhere around this dot is a biconditional with a star here. Oh, what about this cell? Oh, that just barely works. Doesn't it? Oops. Row 3, column 10. 5, 6, 7, 8, 9, 10. Yes. Row 3, column 10 can't be a star because it would, to borrow Nebu's words, kill orange. Because now orange could not have a star in any of these spots, and so it'd have to have 2 there, but you can't have 2 in a 2x2. Okay, so that's good, because now there are definitely 2 stars in the first 2 rows coming from purple. And I think that's going to be really crucial. Because now I think if I start looking back at some of the options, like what if I put a star here or here? Can I force too many stars up here? So there are 2 stars in purple here. Unfortunately, I can just barely get away with something ridiculous like that or something. Okay, Nicholas says green and blue need 1 star each in column 1 and column 2. Let's see. If green tries not to, yeah, that's not going to work. Yeah, so green needs to have a star in column 1. If green tries not to have a star in column 1, then what happens is you have to block all of blue off. There's no way to put 2 stars in green in row 1 without blocking all of blue off. Sorry, not in column 1 without blocking all blue off. But then you've now put... you've now forced there to be 2 over here. Wait, doesn't that just barely work if I do some nonsense like that? I'm now a little concerned about whether that's true or not. Okay, if... Yeah, so this space is very, very egregious. If I put one here, then I've blocked off all of these. And so I have to put 1 there, and I'd have to put 1 there. Which then kills row 2 completely, because row 2 now has its stars done. This one, in fact, would have to be exactly here. Yeah, I think if you chase that long enough, it breaks, but I think you have to chase a little bit further than I'm comfortable with in order to get that to break. Okay, what about this cell? Can this cell be a star? Because if this cell is a star, I have forced both of Pink's stars to be in row 10, which then forces exactly this to be a star, which would then force exactly that to be a star. Again, looks vaguely okay. green and blue can only have... okay. That is an excellent point, Jay. So green and blue are covered in below row 2 by these 2 green dots. And remember, a 2x2 can only have 1 star. So I could get at most 2 stars into green and blue below row 2. But now that means that row 1 and 2 have to have at least 2 stars here. They have 2 stars in purple, means that's never a star. Good catch, Jay. And Chris got to the same idea. Okay, so now orange needs to have 1 star on this dot and 1 star on this dot, which... and this has 1 star on this dot. This has 1 star on this dot. Okay, so that's 3 stars without even touching purple in columns 9 and 10. Is there anywhere in gray that would just immediately break yellow? Like, what if I try to put a star here? Does that work? Unfortunately, I think it kind of does. That also means green and blue do need 2 stars below row 1 and 2. Oh, good point. Because we only get 1 star. We only get 2 total stars between green and blue. And I don't know how it's distributed. I think some people tried to make that argument. But we definitely know there need to be 4 total stars between green and blue. And we know only 2 of them can go up here. So there needs to be a star in this 2x2 and a star in this 2x2, which means that cell is definitely X'd. Because there needs to be a star in blue or green here. Okay, now this cell definitely can't be a star because it would way kill brown. This cell... could just be a star if brown had a star there and a star there. Okay, but now if I look at the bottom 4 rows, the bottom 4 rows contain stars for brown, pink, yellow, and gray. And so, as Chad is pointing out beautifully, there actually is no star in any of these cells, because that's already... the bottom 4 rows already have their 8 stars before they grab those. Okay, great observations by all. Yep, so this sticky downy bit that was originally sus has been cleared of its suspicion of stardom. Let's see. Let's see. Brown is going to be really tight. But unfortunately, I don't quite know anything of the form. Brown definitely has a star in this chunk just yet. There and there, but that seems okay. So if this is the star, that will finish the stars for columns 9 and 10. Is that a problem? Somehow, if this is a star? Uh, I don't know. Here's an interesting point. In this row, the two stars definitely go into gray and brown. Uh, let's see. Nicholas asks if purple has both stars in row 2, is that a problem? And I think the answer is yes, but I don't think I know how to show it. So, like, if purple looked like that, for example, what is it going to do to blue? It's going to force both of these things to be in blue. Both of these things will be in green. But I think I'd have to chase it without some clear articulation. I think I'd have to chase it awfully far to in order to be sure that I have missed it. Yeah, so if brown does not have a... yeah, okay, so here's a good question. Can brown have no cells here? No. Brown has to have a cell in this L shape. But that still doesn't prove the thing that I think chat wants to prove. Yeah, I don't think we can just chase this chain long enough to get there. I agree that brown is tight, but I think we need to make this argument careful. So here's a way to at least say something along these lines, which is that one of the 4 stars in these first 2 columns is in brown. So we know the location approximately of 3 of the 4 stars in the first 2 columns. Now, close, because I'm noticing these two. If I add these two, it's very close to covering blue and green. The only issue is this. Is this cell? Can we prove this cell's not a star? Because I think if we can prove this cell's not a star, I think that will do lots of good for us. Yeah, purple, again, annoyingly has sort of 3 zones where it could get a star. That we have to carefully work our way through. I really don't want yellow to take one of its stars here. Okay, so Chris is now looking at red and yellow. And okay, got it. Okay. Looking at these 2 rows, that's gorgeous. Okay, that is really smart. Chris has noticed that in these 2 rows, once I get this 2x2 ruled out, I actually need a star in every one of these 2x2s. That is glorious. So that gets us 4 dots. 4 dots of dotitude. That is very clever. Okay, so now I should hopefully be able to sort out... same for the columns. Gorgeous. Oops. That is super cool. I've never seen that trick before in a star battle, but that's very cool. To exclude a 2x2 and then place a bunch of those. Okay. Can I rule anything out of yellow now? It feels like I must be able to rule something out of yellow. Yes. I cannot possibly place a star here anymore, because if I place a star here, that's my star. Oh, do I know these 2 stars are different? Maybe I don't know these 2 stars are different. I don't think I know those 2 stars are different. That's unfortunate. Resolves the top right of purple. Yeah, okay. So we're going to ignore this because I don't know that it's distinct from the others. But I now know the locations of the 4 stars in these columns. So none of those are stars anymore. We can come back to the fact there has to be a star in here, but I don't know that it's... I don't know it's different, which is why I pulled it out of these. Okay, so now purple needs to have a star in here, and purple needs to have a star in here, which means green can't have a star here. It's not allowed. And so now green and blue have to legitimately have stars in this 2x2 and this 2x2 in order to get enough stars. Because that was a thing we noticed before, was if we could rule a star out of this thing, then we would get those for free. And so we got them. I mean, for quote-unquote free. Let's see. So now I have 4 dots that I know about up here, which now rules out all of these cells. And so now there are 2 stars in pink in... Oh, no, sorry. This could still be a star, right? This could still be a star. Sorry, don't let me get overexcited and place a star prematurely. Because, yeah, there's that outage still. Oh, yeah, okay. If this was a star, that would super kill brown. Yep. And so then brown definitely would work. Okay, and so now we're about to get our first star, because now there are 2 stars in pink in row 10, so there can't be any more stars. And remember, this needed a star, and so we get our star dance. The star dance is suspiciously similar to the digit dance. We'll have to work on that. But that pushes this star up, which now says these 2 can't be stars. Oops. Which pushes this star up, which now says these 2 can't be stars, which places a star here. And, oops, and places a bunch of X's around there. So we get a whole bunch of free X's. Okay. Dots across the row 9, row 10 border. Okay, yes, sorry. So the two cells in purple, actually, I can be more specific. They have to be exactly in those 2 dominoes, which means there are no stars there. Which means there's definitely a star in this domino, because I need one for the row, which means there's no star in either of these dominoes. Which now, depending on how you look at it, puts a star here, but there are a million different ways to see it. But that now is the last star for yellow. These are the stars for gray, which is going to D-star those. This now is a star. That now is a star. Over there. Okay, that's cool. Okay, so those stars are good. Those stars are good, I think. All right, I know I have a domino here. Let's see. Okay, I do need stars in row 6, and they have to go somewhere. And I'm running out of places to put them. Yeah, it's a bit a long one, Megalam. I'm not gonna lie. This has been more of a challenge than I thought it would be when I got on board for the easy light end of the stream star battle. Okay, which forces a star in row 1 and another in row 2 in purple. I'm not sure which we're talking about here when we say which. Oh, are you saying, okay, so now there's definitely a star in these cells in green, so there's one in these cells in green, which means one of these is a star. I think it's probably easier to look at column 2 now. No, maybe not. Okay. Okay. Let's see. Look at column 2 and column 3. Must have a star in the bottom purple. I don't see it yet. There's one in red, yellow in columns 7 and 8. Okay. So that's a good point. Okay, so let's look at column 7 and 8. So far, we only have 2 stars. One there and one here. I can cover it with a domino and a 4 thingy. So there actually has to be a star in this domino and has to be a star in this 4, which now means there's no stars in the rest of this row, which places a star here in blue. It moves this dot to there. It means that's not a star. Which is good progress. Yeah, the 2x2 logic strikes back. Isn't that 5 stars in those 2 columns? Uh-oh. Oh yeah, sorry, you're right. I don't need 2 more stars. I only need 1 more star. Good point. Thank you for catching me, chat. I got a little bit eager on the stars. Do the same thing in columns 2 and 3. Well, I can't put stars in columns 2 and 3 without extreme care because it'll overlap with the dots I already have. But let's see. If I maximize it... Okay, but if I maximize it... Okay, here's the point. I could put 1 here, 1 here, and 1 here. I'm not going to mark it because it will be confusing. But I can put at most 3 stars in this piece, which means I have to put 1 here. That is Chris's point. And it is well said. So... Okay, I know I only get one more star in this column to fill this whole mess. Yeah, one of those goes in purple. I cannot put a star here, because if I put a star here, it will put a star here as well, which will then force 2 stars in green in a column that cannot possibly have 2 stars. So that can't be a star, which means that this star is actually in this domino, which means these aren't stars, which means this star is in this domino, which means these 2 aren't stars, so this star's in this domino. So that is a helpful cascade of things. I was hoping one of these cells would kill blue, but I don't think so. Let's see. Red is actually getting very, very congested. Because red has got just X's all over the place, but unfortunately, I don't think it quite has enough X's to actually resolve anything. Row 2, column 3, says Andrew. Okay, if this was a star, then I would have to put 3 stars in column 1. Agree. Good point. I feel like it is going to turn out that both of blue's stars are going to be in column 2, even though I think I and most of chat tried to prove spent a significant amount of time trying to prove that could not be the case. But I think it's going to turn out, because I don't think this is going to turn out to be a star, but I could be wrong. Yeah, there's no cell that does quite enough damage to red to completely hopelessly break it, but red is really teetering on the edge of chaos, so to speak. Row 5, column 3 is an X by Chris Logic. Let's see. If this was a star, if this was a star, I would have to put a star in these 2 cells and this cell. It would eliminate all spaces for a second star. Oh, in row 6, sorry. I was looking at the wrong place. Breaks row 6. Yeah, so row 6 needs a second star. One of them is there, but if I put this here, then I finished all of my stars in yellow. So I am done for as far as putting stars in row 6. That's really cool. Let's see. If I put a star here, then my other star in row 6 has to go there. Let's see. Are there any columns or rows where things are particularly interesting? Let's see. That was a really good spot, by the way. I would not have seen that very quickly. Bottom right yellow. That one kills red. If I put a star here, then I would have to put a red star here and one over here. Aren't there just enough places? I feel like there's just enough places. Oh, so through columns 7 and 8. Let's see. Sorry, through columns 7 and 8. Okay. Column 7, 8 would be full. Let's see. There's 1 star, 2 stars, 3 stars. Ah, okay, got it. Yep. If either of these two cells is a star, that's the last star for columns 7 and 8. So red would lose these, but couldn't it still get those two? The row 6 red dot would need to be red. Yeah, one of these two. I mean, any yellow cell I put this dot in makes this dot red, because there's definitely a yellow here. Only the bottom right. Oh, got it. Okay, got it. Okay, just through yellow alone. If I put a star here, got it. If I put a star here, what that does is it finishes the stars in yellow, and so then we wrap around to this domino, and now it can't go here, so it has to go here, but now they touch. That is how I will see that. I think it is slightly different than how Ben saw it. And I am still missing a star somewhere in these two columns. I have not marked all the stars. So there does have to be a star either here or in one of these two cells. Yeah, this is super interesting. Row 4, column 7. See, I thought I was going to get that for free, but I don't think I do. So I think if I put a star here, it puts a star here, but they don't touch. And so I'd have to find something it breaks. Let's see. Row 5, column 4. Can't find two places to put stars in yellow. So there'd be one yellow star there. And then I couldn't take this or this. I'm eliminating these by star adjacency. I'm eliminating these by the column. And this has been pushed over here, so that's eliminated. Okay, yes, I agree. That's really hard to see. But yeah, if this is a star, it actually breaks my ability to finish stars in yellow. Okay, so now I think that's going to tell us that if this is a star, red breaks. Because now if this is a star, this star is pushed there, and now red only has one star, and it's not done. So this is not a star now. Beautiful. let's see. I'm trying to look over here, just trying to cheat slightly and look at how on earth, how is uniqueness going to disambiguate this mess? Because uniqueness has to touch over here. Or by uniqueness, we have to do something that touches over in this part of the grid. So I think that means there's going to have to be a star here. Okay, so where is the last star in column 7 or 8? The answer is it has to be in red. So we've got one there, one there, one there, and red is the only place that has any available spots. So one of these two is a star. At least. Maybe both of them are stars. See, if this is a star, it pushes both the purple and the yellow star over into this column. Yeah, so it can't be both. Okay. Oh yeah, there just aren't enough stars. Never mind. So one of these two is a star, and one of these two is a star. Sorry about that. Yeah, it's not so easy to talk about locations in pencil puzzles. Like in a Sudoku grid, you've got the grid just there, so you sort of learn sort of, ish, how to refer to the cells, but it just does not work for me in these. So I just sort of shamble on by. Okay, one of these three needs to be thing. Okay, Jay has discovered something. Red star in row 3 pushes those left and the purple right. Okay, so if this is a star, it pushes both of these left over here, which then pushes this right and this right. Yeah, this purple, we don't know quite what happens to it. Oh, no problem. I appreciate the help I can get. Let's see. What about this cell? Can this cell be a star? It would push this star over here. Yeah, I guess it's not immediately a deal breaker. Just missing like the tiniest bit. There's so much subtle communication across the regions in this puzzle. Let's see. There's only one more in column 5 and 6. see. Amber says row 3, column 4 can't be a star because it pushes 3 stars into column 6. Okay, I will look at that. So if this is a star, then it pushes this star into column 6. It pushes that star into column 6. And it pushes this star into column 6. Beautiful, beautiful. Yes, I agree. This cell, being a star, pushes these 2 stars into column 6 by force, and it pushes this one into column 6 through the fact that it finishes yellow. Okay. Okay. If there's a star in row 4, column 4, I think you can't put 2 stars in row 3. I don't see it immediately. Which is far from saying I don't believe you, just to say I can't visualize it. Okay, so if this is a star, it's going to push both of the gray stars sort of in a chain reaction across here. Is that going to do anything? Well, it's going to say this isn't a star, and that's not a star. So these two are mutually exclusive in red, which is interesting. Column 7, 8, gray and purple. Yeah, well, there's a star here, there's a star here, but we still need one more star. So yeah, one of these two is a star in red, and ergo one of these two is a star. But these two being a star are mutually exclusive. So if this is a star, that's a star. There's a link between those two. Row 4, column 3. Okay, let's look at row 6. 1, 2, 3, 4, 5, 6. Okay. Yeah, the stars in row 6, one of them is here. One of them has to be over here somewhere. But I just don't quite... like, one of them can be in yellow, or it can be not in yellow. It can be in blue instead. If you count 2x2s in rows 2 and 3... yeah, so let's clear these out so we can pencil on it some more. Actually, I'm not going to do those, but yeah, let's do it in rows 2 and 3. Yeah, okay, so rows 2 and 3, If I look at these, there has to be one here. There has to be one here. Has to be one here. Then row 1, column 4. Right, okay. So yeah, the thing we've learned is there has to be a 1 in this, or there has to be a star in this domino, so that's not a star. Okay, agree. So now row 3 is really hurting for getting a star, as is row 4. Yeah, green definitely has at least one star in row 1. Right. We know green has at least one star in row 1. Beautiful, beautiful. Okay. Green needs a star in row 1, and because it can't have both of them in column 1. And so this can't be a star. I mean, they could be here and here, for example, Nicholas, as far as I am currently aware. Let's see. I'm going to just remind myself that I need one. Do I need one there? Maybe I don't need one here. Let's see. I should count again. Okay, so row 1 and 2. Yeah, okay, so it'd go there, there, there. Row 2, column 6 is not a star. 1, 2, 3, 4, 5, 6. Let's see. If this is a star, I can't put a star there. So if this is a star, I would have to put a star here and a star there. And then a star there, and then a star over here somewhere. Okay, the purple region. The thing I know about purple is I know purple has a star in one of these two cells. And I know purple has a star in one of these cells up here. So either these two are stars, or the middle one's a star. There must be a star in one of the 3 cells in column 7. So, sorry, 1, 2, 3, 4, 5, 6, 7. Okay. Row 2, column 6. Can't be a star because of column 7. Gorgeous, gorgeous. Okay, yes. I need to put 2 stars in column 7. If I make this a star, then none of these can be a star, and so this has to be a double star, and that is not allowed. This is not a Schrodinger star battle cell. So this is not a star. So this is a star. So that's not a star. Okay. And so the reality that we have been trying to prove, or at least I know Nicholas and I tried to prove extensively that there could not be 2 stars in blue in this column, and there are, in fact, 2 stars in blue in this column. That's life for you. So that's definitely a star, because I need to have a star here in green, otherwise green can't get 2 stars. That finishes the stars for column 3. Now I know that one of these 2 stars has to be, or sorry, one of these 2 is a star. I again have this sort of confusing triple dot pattern, where it's either these are both stars, or this is a star. Let's see, that's a star. One of these is a star. Let's see. Yeah, I need a star in one of these two cells, although I don't think that lets me mark anything, unfortunately, but one of these two is a star. It does, actually, because this is the last... I need, in order for row 1 and row 2 to work, I need a star in one of these two, which finishes green. So now green is all done starred, as they say. I know blue needs a star in each of these dominoes. Let's see. I need star 2 in yellow, so row 6, column 6 can't be a star. Can't I put 2 stars in this row? Don't I have to put 2 stars in this row? Oh, orange. Okay, orange needs a star in one of these 2 cells. Column 4 needs a star. Let's see, it is in one of those 2 places. But I don't think I know which one yet. Now row 5, 6 does things. 3, 4, 5, 6. Okay, so now I know I've got one in row 5 and 6. I've got 1 star here, 1 star over here. So I need 2 more stars. They're either both here, or one of them is here and one of them is over here somewhere. Unfortunately, that does not quite... This is certainly the most robust star battle puzzle I've ever done in terms of, like, having a continual chain of logic that just keeps going. A lot of these just sort of instantly fall apart when you look at them funny. Like, there's often, like, a break-in like this, but then usually it does not. Okay, red in row 3. So yeah, row 3, one of these 2 is a star. Yeah, this is slightly confusing, this pair of dots. If you redraw the dots in row 3 and 4. Okay, let's redraw the dots in row 3 and 4. Okay, that's a good point. I can put 1 there, 1 there. I have to put 1 here. In this, or I cannot make it work. Yes, honey?
Just want to let you know I'm going out to pick up pizza.
Okay, thank you. I'll be done shortly. But yeah, that's an excellent point to Chris. Rows 3 and 4, in order to finish, I need 4 stars. I need to put 1 in this cluster, which means that has to be a star. So that's not a star. So that's a star up there. That's not a star. That's a star. That's not a... Oops, that's not a star. That's a star. That's not a star. That's a star. That's not a star. That's a star. No, you're a star, or whatever. That's not a star. That has done a lot of damage. Stop. Oh, no. What? Oh, no. Let's go back to where I had this. Okay. Why not row 4, column 4? Oh, because I'm blind. Sorry. Yeah, okay. Completely right. Yes. This cell I was not counting when I was sort of starring this mentally. So let's undo all the stars and let's star it correctly, like that. So there has to be 1 in this domino. There has to be 1 in this domino. And then there has to be 1 in one of these 2. I think that, if I do this correctly, I think is I think that is the way that these stars end up looking. Now look at the dots in columns 4 and 5. So there's 1, there's 1, Okay, so so now I have all my stars in columns 4 and 5. I cannot put a star here, so therefore that's a star. Progress. So yeah, just between this little X-wing, we have good things happening. So column 4's remaining star, where is it? It is one of the pieces of our X-wing, but I don't know which piece. Yes, the setting on this is quite impressive. I mean, I think Sam is one of the very small number of people who can claim to have come by the experienced Sutter role honestly, because his knowledge and skill at this is just immense. And the speed at which he sets is also highly enviable for someone who's been working on a puzzle for like 2 weeks now. Yeah, so I've got my little X-wing over here. So many things. Okay, second purple star must be in column 7. Let's see. Okay, why can the star not be here? If this is a star, then that's a star. And we've now ruled stars out of these 2 cells in red. So that's a star. It's a star. That's a star. I've lost track. Row 4, column 6. Is the same as row 5, column 7. It isn't that row 5, column 7? Let's see, if this is a star, what happens that's bad? It pushes this over here. It pushes one here. Row 5, column 8. Okay. Row 4, column 6. Row 5, column 8. These two. That'll get better with time, Logan. As you become a more experienced solver, you'll get to know more people. You'll make more friends in the community, and then your puzzles will be better. More people will want to solve them. Let's see. Okay. So Chris says purple star in row 1, column 8. 2, 3, 4, 5, 6, 7, 8. Leaves only 3 stars in columns 6 and 7. Let's see, because now... Yeah, so now I can't put any stars here if I put a star here. So now I could put a star here, I can put a star here, but that's not enough. So yeah, so that is not a star. Oops. So there's a star here. Okay, beautiful. So that puts a solver that definitely puts a star somewhere in one of these two cells in purple. So now, okay, so now people are suggesting that I color, sorry, I've lost track. Someone was suggesting that I relook at stars in some number of columns, but I've now lost track. Okay. There is. Okay, there's another way to figure out that this purple had to go in one of these two cells. Yeah, so let's look at this row by row. So our two stars in rows 1 and 2, we know where they are. Roughly, they're in that domino and that domino. In 2 and 3, we have one star in this pair and one star in this domino. Does knowing there's a star in this domino do me any good? So is it possible, in other words, that both of these cells are stars? Both of these cells are stars. That's a star. That's not a star. Let's see. There's definitely a second star in row 6 in yellow. 4, 5, 6. Oh yeah, remember we used to know there was a yellow star here, right? Sorry, I think Nicholas is right. I think we actually know for sure that one of these is a star, if I count this correctly. So let's look at the rows 3 and 4. Sorry, I don't know if professionals do this this sort of weird counting that I've been doing. So if I look at rows 3 and 4, oh, maybe that doesn't quite give it to me. Oh, maybe I'm supposed to look at rows 4 and 5 to see that? Because I know we saw this before. Rows 4 and 5, that's got to be one. There's got to be one there. No. Count in yellow itself. Yes. So there's... yes. Okay. Yes. Just for yellow to be done, there has to be one in these two and one in these two. Does that tell me anything? I fear it does not actually get me anywhere. But I may be wrong. Let's see. SPQ is looking at... row 4, column 6. Oh, yeah, I think I tried to understand this before, and I did not, but let's try again. Row 4, column 6. Row 5, column 8. So the claim is these are the same. So let's see. Josh says there's an X-wing on blue and red in row 4 and 6. So yeah, so there's a star in one of these two. And there is a star in one of these two. No, sorry, a star in one of these two. Okay, and that's going to actually get me something. So in row 4, one of these two cells is a star. In row 6, one of these two cells is a star. Oh, could they both be in red, though? No. Wait. No, they can't both be in red. If they're both in red, it breaks yellow, because then this domino's broken. So one of those is in blue and one of them's in red. And the thing that tells me is this can't be a star. Because if this is a star, then I cease to be able to put one in yellow and one in red and one in blue in these two rows. Because I need one of these two is a star. That's basically the point. So that gets us another X. Which now means this row is finished. Haha! There we go. So that means this row has to look like this. That's not a star, that's a star. That's not a star, that's a star. That's not a star now, because it's next to a star. That's a star as well, because I know I have one of these to do. Let's see. Okay. And now, keep going. Keep going. Row 4. Column 6. 1, 2, 3, 4, 5, 6. Column 6 now only has one cell that doesn't have a marking. Good. So that's now a star. That's a star. That's not 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 a star. That's a star. Woohoo! We did it! We made it through! I was a little worried 9 days in that we weren't going to make it, but we got there. Was that a naked single star? It could have been a naked single star. Yeah, boy, yeah, that was a tough one, but yeah, what a puzzle! Wow, yeah, that is one of my favorites of the star battles I've done. I have no idea what the difficulty on this one was. I would have sworn it was a 2, maybe a 3. I don't think it was higher than that, but I'm not sure. You can find it on LMD. I'm not sure if that's the link that Tristan gave or not. No, I don't have the LMD link. Yeah, that was quite a nut to crack, but we got there. All right. Well, with that being said, there is now pizza, so I am going to go eat pizza. But thank you for joining me and for keeping me awake on a day when I otherwise might not have stayed awake. But I'm going to go eat pizza. Thank you for joining us. And I'll be back with more Sudoku and puzzles and other such joys on Saturday at the usual time. So please stop by. Oops. Be right back was a lie. It's the thanks for watching. And thank you again to all of our patrons, all of our subscribers, all the people who watch the videos. It really does make this a lot of fun for me that, well, I guess I wouldn't do it if there wasn't anyone, but it makes it a lot of fun for me that you all are here with me. So thumbs up. Thank you all. If you want to subscribe, please do so. And as always, thank you to the patrons. Bye-bye for now.